Yeah, I think in the paucity of time we will start. So good morning, everyone. Can be a little louder. Good morning, everyone. Welcome to this 113th edition of the Zak World of Façades conference. My name is Ahmed. I'm part of the organizing team here. I'd like to welcome all of you over here. We've tried a new concept this time. It's new to us also. It's a keynote style, something different, something to make it look a little bit more open. This is the 8th time we are doing this in Dubai. And for Dubai, you always have to keep doing something different. So we've also tried something different. I hope you like the concept, and I hope most of our speakers can walk and talk. I'm actually trying to set an example here. I know some of them have some notes, so they'll take the podium. But I hope most of them can do a keynote style. So, as I mentioned, this is the 113th edition of the Zak World of Façade conference series. I'd like to quickly introduce the event for those who have not attended this event before. So we've been doing this event since 2012. This is edition 113. We've done this event in 33 countries, and we've got plans to hit 37, 38 countries by the end of the year. Every country is different, every region is different. There are different challenges, there are different opportunities in every region. So for us, it's been a lucky blessing that we've been able to take things which are a trend in one region to other regions and vice versa. So this is with us right from Auckland, which we did the event last week. Till Canada, we've got events, so it's spread throughout the globe. But all this would have not been possible thanks to our event sponsors. I'll try to introduce all of them very quickly so that we get into it. So a pillar of support for our events is Schüco. Schüco is a global leader in aluminum door, window, curtain wall systems. It's a German manufacturer. They are the presenting partner of this event. Guardian Glass are our powered by partners here in the Middle East. They are a high-performance glass manufacturer. North Aqua Panel is a fiber cement board manufacturer. Axalta is a coating manufacturer of liquid and powder coating. Caparol is a German paint manufacturer. They have a solution for the facade, which is the EIFS, external insulated facade system. Codina is a Spanish manufacturer of mesh, which can be used for the external skin. Cosentino, another Spanish company, they have an interesting cladding product, non-combustible, called Decton. I think those who are standing there, we have seats that side. So please, if you can take the seats there, thank you. Ductal is a French, is originally part of Lafarge, now it's Wholesome. So Ductal is UHPC, ultra high performance concrete. It's a technology which is very popular in Europe, in the UK. It's also been done in some projects in the Middle East. So Ductal are here with us. Effisus is a Portuguese manufacturer of membranes, of weatherproofing solutions. Fischer is a German manufacturer of fixing systems, real ventilated claddings, screws, and lot many more, pacifier protection, lot many more things. Foster is a stainless steel systems company. Future Architectural Glass is a value-added glass processor based out of the UAE. ISD Group is a German software solutions for CAD and CAM solutions. Kinlong is a Chinese Chinese hardware provider for glass fittings, for curtain wall, for hardware, and a lot of other stuff. I see they have launched sealants also. Curare is the mother company of the laminated glass interlayers, Trosifol and Sentry Glass. Laswit is a company from the Czech Republic. They have specialty glass products, cast glass, art glass, and a lot of other stuff. IBECE is a British manufacturer of membranes, tapes, and other products for airtightness. Ozone is an Indian manufacturer of glass hardware solutions, fittings, railings, lot many more stuff. Pentagon is again an Indian manufacturer of tapes for structural glazing. A. Proctor Group, a British manufacturer of airtightness solutions, which are basically membranes, vapor barriers, and other stuff. Quandat is one of Vietnam's leading aluminum curtain wall companies. So they are here for the first time, and they are showcasing their fabrication solutions, which are fabricated in Vietnam. This is Saint-Gobain EIFS division, the external insulated facade solutions division, which is a merger of three of their products, Kimco, Weber, and Gyproc. Serge Ferrari is a French company. They have fabrics which can be used for architectural applications like the roof and the facade. SVT is a manufacturer of pacifier protections in the form of cavity barriers and other stuff for facades and curtain walls. Terraco is a UAE-based manufacturer of EIFS solutions. Vector Foiltec, German manufacturer, installer, engineer of ETFE. Orga Data is our technology partner. Those who have the red color lanyards with you, you will see a USB stick hanging over it. So that's courtesy Orga Data. That USB stick has all the brochures of all our sponsors from today's event. And of course, something interesting, it's a gimmick, I hope it works out. So we've got a glass slide networking partner, SEDAC. SEDAC are one of the global leaders in glass processing technologies. They have a glass which can go up to 18, 20 meters, I'm being told. They have supplied the glass for the glass slide, which is on top of this building, 53rd floor. Right at the end of this event, we have a small activity, a networking activity, which is sponsored by SEDAC, which is basically riding the glass slide and viewing the glass observatory. So this is on the 53rd floor. You can slide from the 53rd floor and go to the 52nd floor. It's a quick 3-second, 4-second activity. And of course, you've got the observatory for the whole downtown Dubai views. And the glass for this is actually provided by SEDAC. There was another glass slide in the world, which was in the US Tower in Los Angeles. That's shut, that's closed, so this makes it the only glass slide in the world. Those who want to ride this glass slide, there's a stand outside right at the end next to Caparol's booth, where we are giving away tickets for this activity this evening. It's on first come, first serve basis. 200 tickets only we have, that's the only quota we could get. So the first 200 people can take the tickets over there. So you can go and register yourself over there. You just don't need to do anything. Just show your badge. They'll take a photo of your badge, and right at the end of the event, around 5:30, whenever we complete, come back over there. We'll escort all of you to go to the observatory and the glass slide on top. Our next events, next week, Singapore, Istanbul, the week after that, Madrid, Mexico City, Ahmedabad in India, and Birmingham. So these are our next few events. Of course, we've got many more events. We've got a lot of new places which we are going to. But yes, the whole idea is connecting the facade industry. This is what we've been doing globally. I'm very thankful to our event partners and all of you for taking time out and coming and learning. We've got some interesting presentations being spoken today. I'm done with what I have to say, but I'd like to call upon today's event host and convener, Osama Abbas from IBECE. He's the chairman and managing director. He would be hosting today's event and be taking this discussion forward. Okay, Osama, over to you.
Thank you, Ahmed, for the very warm welcome. Please allow me to thank you all.
I'm so sorry. I forgot. Ammar, yes. I'm so sorry. I had to introduce that and not Osama. Before we get Osama on board, I'd like to call upon Mr. Ammar Alul, Chairman, Managing Director of Schüco Middle East. It was my job to introduce him, not Osama. I think I got overwhelmed going round and round, something the speakers need to take care of. Mr. Ammar Alul, he's the Managing Director of Schüco Middle East. Schüco is our presenting partner of the event, and he'll be talking a couple of minutes.
Hello. Hi. Well, I would have. Whoa, this is too loud, right? I would have loved to be introduced by Osama as well, so no issues, Ahad. Good morning, everyone. Thank you very much for joining us. Of course, we're always proud to be the presenting partner of Zak, and not to forget. I promise I won't take long. Not to forget the focus on the UAE, because now as the construction industry is moving a lot of its attention to Saudi Arabia, but I think that Dubai, specifically the UAE in general, and other countries in the region still have a lot to offer. Hence, we are here, and this is a great participation at this edition of Zak. I just want to give a very brief overview of what we will be focusing on at the largest construction event in the world, at least outside North America and probably in the world, which is the BAU in Munich on the 17th of April. As always, Schüco will be the stand. It's massive, it's huge, it's impressive, and I hope that most of you, if not all of you, get to join us in Munich this April. Our focus will be on building networks, specifically on the area of sustainability, security, smart, fascination, and partnership. Sustainability, of course, Schüco is very active, and it has its own department within the company and is very serious about cradle to cradle, the recycling, the sustainability of the building environment and the building envelope specifically, which is what we are focused on, of course. Security, of course, Schüco has its own products as well as products in association with partner companies like Seltzer. Fire, safety, smoke, burglar, blast, bullet, etc. And that you will see also at BAU, some innovations that have not been introduced before. Smart is always very close to Schüco's heart. Smart in the sense of digitalization, from Internet of Façades, and you can Google that, which is an amazing where the building envelope, the building element, will have its digital twin on the cloud. And that is something that is very important in terms of using digitalization to streamline the construction industry and how we do things on site and at the factory. Of course, fascination, that area will focus on how we can also imagine how things can be done. From floor to, of course, the products, the height, the building envelope where you can move things around, just like you see here. Not that we are moving this element, but how the flexibility can be used in the building envelope. And of course, at the end, partnership. Partnership is very dear to Schüco because at this day and age, at this time, interdisciplinary cooperation is critical to any industry. And Schüco is not different. And Schüco is focused on partnership. So when you visit us there, that's where we will talk about how we can do things together, whether it is at the early stages of the construction project or after the construction project has been completed, years after. And that's the true test of leadership and quality. How is that project doing 5 years after it has been delivered? That's a key test. I hope you will enjoy today. I hope you will be able to visit us in Munich in a couple of months. And other than that, take care, enjoy the day. And Osama, sorry to upstage you like that. Thank you.
Thank you, Ammar and Ahmed, for the very warm welcome. First of all, I would like to thank you all for taking the time to join us here at Zak World of Façades, the 113th division in Dubai. And for those of you who don't know me, I'm Osama Abbas. I'm the CEO of IBECE Façades and IBECE Energy. And before we go into the details of the conference, if it is possible, I would like us all to take a stand, to have a 1-minute stand out of respect for the souls that have been lost in Turkey and in the Syria earthquakes, if it's possible. All right, I think that's almost a minute. Thank you so much, appreciate it. You know, I was so honored by the invite from Zak World of Façades for me to host this conference. And again, I thank you all for attending it. Standing here, I cannot but reflect on the lot of advancements that happened in facade engineering for the past 20 years. I myself have started this career path, you know, while facade engineering was only needed when we went to the consultant having, you know, a leaflet from a supplier to choose one profile. And that profile was supposed to do all the job that is needed, not more than that. At the end of the day, all the facades leaked, all the windows leaked, and we always blamed the weather. So really, there was no facade engineering in principle. There was nothing. Fast forward 20 years later on, those days are now very much advanced. You know, the facade is now required to perform an armada of functional requirements, of performance requirements, as well as apply and serve the architectural aesthetics of the architect. So there have been some major breakthroughs in facade engineering. Now facade engineers, they have to address multiple level requirements, including but not limited to like building thermal movement, as well as the structural stability, sustainability of the facade itself, as well as the daylighting requirements, the energy efficiency, and the hydrothermal and acoustic requirements of the building. On special occasions, we also have to address the marketing aspects via like media facades, as well as some anti-vandalism, the design for the facades, the bulletproof section, as well as the blast resistant, as just Mr. Ammar has said that Schüco has these systems as well. To top it all off, we are invited also at the end of the event to actually go on a slide, a slide, which adds to the requirements of the facades as well, and which will give an implication at the end of the design that now facades are no longer, just items designed out of one leaflet. They are now pretty much very complex items. Now, advancements in modeling softwares and in the ability to code and the ability to have advanced engineering coded and programmed have given birth to a parametrical facade model, okay, in which we are able now to actually design, procure, fabricate, and install very efficient facade systems at a much faster pace. As well, this has given the rise to something called bent facades with double glazing, in which we are actually pushing the envelope of engineering in that area as well. Global warming, it signals an imminent threat, and accordingly, it drives global leaders to target a state of net zero carbon, and the facades are at the forefront of fighting this as well, because the facades can deliver quite a punch when it comes to the state of the CO2 emissions. As an example, the facade, they produce electric energy, they deliver energy efficiency to reduce heating and cooling loads, and at the same time, they reduce embodied carbon within their construction and life cycle. There's no doubt that facade engineering and facade engineers will have a major role in the fight against CO2 emissions now and in the future. We are living in an age of fast-paced development, and the facade engineering industry is at the forefront of providing a better built environment as well as protecting the environment. This conference is all about the opportunity to discuss and explore these possibilities. It's my privilege to be standing here today presenting our caliber speakers who always fall nothing short from delivering a master class in technical knowledge and hosting an event that always have knowledge sharing and networking at its very heart. Thanks is sincerely due to all the speakers, sponsors, and partners, and to the organizing entity, Zak team, who did not spare any effort to orchestrate all of this. Before we delve into the program, may I inform you that we will not be taking questions for the speakers during or after the presentations. The speakers will be around in the networking area later on, where you will have the opportunity to speak with them. Also, kindly keep your phones on silent mode throughout these sessions. All right, I think we are now ready to welcome our first speaker for the day. Please give a big round of applause to and welcome to the stage the CEO of AESG, Mr. Saeed Abbar.
Thanks very much. Is there a clicker? Good morning. Pleasure to be here. This is, I think, the first time we've had a 360 room presentation, so excuse me if sometimes people are behind me, but we'll try and keep rotating. But yeah, pleasure to be here today. I think I attended a number of these events, and it's always great content. We learn a lot what's developing in the industry from projects and technology, so it's a pleasure to be here today and give a keynote. So I was asked to give a presentation. I guess it's the big topic at the moment with everything going on in the news, with COP28 happening just down the road in Dubai and Abu Dhabi in just a few months' time. Just around net zero and the role that we have as practitioners in the built environment to achieve that. So what I plan to run through today is really just an overview of the concept at a very brief level, why it's important, what's happening, what agenda is going on sort of regionally and nationally as well as globally. And also dive into a bit of detail in terms of some of the work that's happening and projects that have come around as well. So I think this is not new to everyone, but I think when I first sort of started attending conferences and talking around sustainability and things like that, it was all about what might happen in 20 years, 30 years' time. But I think what's striking about these images is everything's within the last sort of 12 to 18 months, is that the sort of impacts of climate change are here. Unfortunately, they're here to stay. It's irreversible now. We've locked in 1.1 degrees of warming, and events like this are going to keep on happening. And as the warming goes up to 1.5, 2 degrees or more, frequency and severity of events are going to continue happening. So I think that's a stark reality. It's not a train in the future that we're looking at. It's something here and now that sort of has immediate consequence. And yeah, I think we've seen a number of these headlines. I think the big phrase that's coming out is code red. It's sort of crisis moments to act now and really tackle things. And I think we're seeing increasingly scientists coming out with increasingly graver, more urgent statements that over 11,000 scientists declared a climate emergency, that really things need to sort of be tackled quite quickly. Last year, the last report from the IPCC highlighting cause and impacts shows that climate breakdown is happening faster than expected. So despite all the research of the last 10, 15, 20 years, it's actually happening before our eyes quicker than we thought, and really calls for governments and the private sector to act drastically, because I think the severity of events is really, really kicking off. I guess a sort of watershed moment was the sort of COP21 in Paris. I was fortunate to attend sort of in two capacities, one with the sort of UAE delegation of some of the entities we've been working with, but also in the role I was serving then with the World Green Building Council as a board director. And obviously that was where the big sort of breakthrough happened, where the world agreed to sort of limit temperature rise to 2 degrees and ideally 1.5 degrees. Now, since then, temperatures have been going up, year on year. So we've not really progressed significantly from there, despite a lot of commitments, rhetoric, etc. But one sort of striking thing that did also take place at that event is that was the first time at any COP that sort of buildings was at the forefront of the discussions. It was the first time, and I think a number of organizations in the built environment that was involved in sort of lobbied and pushed the UNFCCC that buildings need to be at the front of the agenda on this, because that's one where a lot of the impacts and emissions are being generated. But secondly, and probably most importantly, it's probably where we can most easily make very quick change. It's not at a federal political level, it's at city levels. And I think that was also the first COP where sort of mayors and city planners, CEOs of city development entities and the like, were really given sort of a front stage to sort of drive action, which I think was very positive. And again, I guess this is talking sort of around the built environment, why it's important. Again, probably many of you are familiar with these, but obviously buildings are responsible for 39% of global carbon emissions. So it's more than the transport sector, more than the industrial sector. It's the largest sector of emissions. And of those emissions, 11% is from the embodied carbon. So that's the carbon locked into the materials, the concrete, glass, cement, aluminium specifically. And the other 28% is the buildings and operations. So obviously the facade has a very, very big role to play in that. A few statistics on there, but one of the big ones I'll sort of pick on is energy demand's set to increase by 50% by 2050. And by 2050, global population is going to increase 27%, and the global floor area is going to increase by 100%. So I think the challenge that we're really faced with is we need to sort of move towards climate action and decarbonization and net zero. But we're doing that in the face of sort of unprecedented global demand for floor space buildings, as well as energy demand. And I think there was an interesting report from the United Nations last year, actually 2021, which showed that over the last 5 years, prior to that, there's been 17% increase of investments in energy efficiency in buildings. But even despite that, emissions from buildings have gone up 5%. Because of the increased energy demand, increased floor area, we're building buildings at a rate where even all of the great work we're doing in efficiency and things is just not happening quick enough. So I think that's really sort of sets a very stark challenge. And I think if as we looked at some of the previous slides, scientists saying 2030 is the point where we need to sort of halve carbon emissions. Well, we're at a point now, despite all the good work, in 5 years it's gone up 5%. It hasn't actually stabilized or even started to decrease. So not to sort of set the doom and gloom, but I think it sort of sets the sort of urgency and reality of what's ahead. There's lots of great talk, great commitments, but I like to sort of follow the data, and I think the data shows that we're in a very, very dire position for urgent sort of action. So with that, what can we do? So achieving the Paris Agreement, very simply, it needs urgent action towards low carbon buildings. Again, the scientists are telling us we need to sort of halve carbon emissions by 2030. That means that any new buildings we build, 2030 onwards, really need to be operating at a net zero level. We've sort of seen how difficult it is to retrofit existing buildings, trying to get a building that's already a place where people live, work, and play, and upgrade it. The investment in it is very, very challenging. So really what we need to do is the buildings that we are building need to be locked in at sort of decarbonization levels very quickly, and we do need to tackle that sort of retrofit topic very urgently as well. So one of the big sort of commitments, which I think is the groundbreaking ones in the building sector, is the World Green Building Council's Net Zero Carbon Buildings Commitment. So I was quite involved in this in 2017-18 when we were pulling this together off the back of the Paris Agreement. And actually, what this shows is actually sort of the cycle of ambition that we're able to achieve. So initially, when it was launched, the whole idea of it was, right, let's have a commitment whereby, and bear in mind this is 2017-18, where the topic was still a little bit, net zero, not possible, it's too far in the future. If we can get some of the sort of first movers in the industry to commit to this, then hopefully we can drag a lot of the industry along. And I think when that happened, it probably was a bit of a surprise of how quickly it took off. Initially, we had about 3 or 4 organizations, including 1 or 2 from the region, that sort of said, yeah, we'll commit to that. We're not sure how we're going to get there, but we're going to commit and start that journey. After that, a number of others joined, and we're at sort of 50 or 60 sort of major players in the sort of built environment space, sort of developers, architects, contractors, etc., that have sort of said, right, we're behind this, we're going to do it. And what that's done is, and if you sort of anyone that's worked with government will understand sort of government being very slow to move, is that they said, well, if these major players in the private sector have committed to it and believe it's possible, then we should get behind it too. And very quickly, we had about 13, 14 major cities that signed up to this within a 6-month period, which was Paris, New York, Tokyo, London, Sydney, Copenhagen, Stockholm, a number of others. So Dubai as well, following shortly after. So I think what it's been able to do is really create that movement of saying, right, okay, organizations have committed to achieving this, and we need to sort of move forward on that pathway. Us as an organization, so as a consultancy, we said, look, we were one of the first to sort of get behind this as well, and basically commit to sort of the work we do, achieving this sort of 1.52 degrees target from the Paris Agreement. And if you look at, I guess, from ourselves, and I guess most practitioners here, we don't own or operate a large number of buildings. We've got space for our consultancy teams, 300 or so people, which, okay, that's our impact, which is pretty minor. But the big impact we can make is, the hundreds and thousands of buildings that come through our desk every year, which we're sort of having an input in. So what we've sort of taken upon us as an organization is to sort of, any project that we get involved in, then we're getting involved in design. We are pushing the clients and providing pathways of how to achieve net zero on their projects, giving them real parameters of what's the implication going to be, what's going to be the changes to the specifications, what's going to be the renewables, what's going to be, most importantly of all of this, is the cost. So we've worked very closely with our sustainable design, our facade teams and our cost teams to come up with metrics on these projects so that we can very quickly sort of provide that. Because I think one of the big challenges we're seeing of people not adopting this is this sort of fear that it's too difficult, it's too much of an unknown. So That's from ourselves in terms of Karim. A number of other consultancies, architects and the like have done the same thing. And really, it's about having that advancement to really push things quite urgently. So coming through into the region, and you probably know that, so the UAE was the first in the region to sort of produce the 2050 net zero plan. So really to decarbonize the economy by that point. So again, hugely ambitious, and the work is starting on that from today. We've seen in Saudi Arabia, it's followed suit as well. 2060, the Saudi Green Initiative, also based on a carbon circular economy. So we're seeing these ambitions come through as well through there. And I'd also add is that what we've seen in the last 12 months has been probably the fastest acceleration in the region of this adoption. So our strategy team that works sort of at the corporate government level on developer strategies and the like, all of a sudden from working with 1 or 2 clients a year on their sort of sustainability net zero plans, are working with sort of 25 major organizations that develop buildings, own buildings, operate buildings, including infrastructure, ports, etc. So, and a number of others are also doing the same. So what we're seeing is this first wave where they're all putting in place their plans, strategies, and ambitions. And that's literally happened over the last 12 months, COP28 being a big driver of it. So this is coming through into the industry, is that they're all setting net zero ambitions and plans, following the same sort of trajectory that's happened in Europe. The major investment funds, the major REITs, sovereign wealth funds have said we are not investing into any portfolios which are not decarbonized. So that's cascaded through here. And we're seeing that happen very quickly as well. And I think there has been the discussion around cost. Obviously, it's one of the most important things is the CapEx investments and things. But very quickly, a lot of those challenges are being overcome. And I was talking to someone operating at sort of a very high fund level, and they said, look, the discussion from developers and the like around cost is going to be obsolete in a couple of years, because it's something that those that are controlling the flows of money are saying we need to get over this challenge. So it's happening very quickly. And yeah, so I think we've talked about sort of the urgency, the challenge, and the things on there, but sort of on the built environment. Some of this data stuff from our team in London, but also in the region as well. But impact of the building sector. So buildings are estimated to account 40% of global energy consumption. Construction industry in the UK is 49% of carbon emissions. So that's the largest sector there. And when you look at those aspects, heating, hot water, major parts, but business, domestic, and other parts as well. So delivering on net zero carbon development. So the big topic that's coming in now is around sort of whole life net zero. It's not just around the energy efficiency in the operation, it's the materials that go into the building. Some of the targets that have sort of been talked about is one, obviously reducing the consumption as far as possible. Targets, again, UK, Europe is looking at 55 kilowatt hours per square meter per year. Here with our conditioning requirements, it's probably higher, it's probably around 80 to 90. Using renewables as far as possible, on-site, off-site. And then inevitably there is going to be an element which has to be offset through carbon credits as well. But the embodied carbon element is becoming much more important as we see. As I said, that 40% is generally made up of 11% embodied, 28% operational. But what we're seeing in Europe, where energy codes have been in place for a long time, when you look at places like Germany, Denmark, and the like, it's almost like for like in terms of the embodied and the operational. So that as buildings become more efficient, that actual embodied part becomes a lot more important as well. So when we talk around the embodied carbon, what does that consist of? Well, it's effectively the carbon that's sort of embodied within the materials that go in there, obviously producing steel, producing glass, transporting things to site. There is obviously emissions that come with it. But when we're looking at the elements sort of in sort of the construction or construction of a building, the big elements is superstructure, substructure, and facades. That's those elements alone are almost counting for about 80% of the embodied carbon of a building. So that's really the focus. And when you look at the materials with the highest sort of embodied carbon intensity, aluminium there at the top, fiberglass as well, steel very high. So you can see that as an industry, structures and facades is really where it's being tackled. But there's a lot of work that's happened in this space in the last few years, and what's been found is achieving sort of 40, even 50% reductions in embodied carbon can be achieved very easily through just good design measures, making sure you're making the right specifications, etc. So targeting around a 600 kilogram CO2 per square meter embodied carbon has been sort of the target in sort of net zero building elements. On the efficiency targets, again, comparing sort of UK, Middle East, we've seen residential UK about 35 kilowatt hours per square meter a year, office around 55. Obviously, there's more of the sort of cooling and heating requirements there. Middle East, we're looking at around a figure of 90 as from the projects that we've been looking at as sort of the area to look at. If we can get intensity down to that, fill in as much with the renewables, and then get some offsets going, then we're able to kind of be on the right track from that side. That said, we have delivered sort of net zero energy projects, which have had sort of all of their energy utilization being generated on site, and that's projects in the UAE as well. And again, through effective designs of the facades, through BIPVs, through energy efficiencies, and optimizing envelopes, form, etc. We have proven that it's possible, and that actually has been done at a sort of zero cost premium. Again, it's Class A office space and comparable cost per square meter. And again, this is not just research figures, this is tender return prices. We've been able to achieve at a net zero energy building cost parity for like for Class A offices. So again, it shows that data's there, and we're more than happy to share that. This is not sort of a proprietary thing where we're trying to hold information. We're all on the journey, and we're happy to share any of that, and likewise from peers of information, because I think when we look at the timescales we're working to, we need to really obviously collaborate, and any lessons that we learn on that pathway, we capitalize on. But looking sort of where we are today, and again, this is taken from sort of UK, so this is not sort of regional Pacific, but same thing's happening here. But even in so-called sort of sophisticated energy efficiency markets, well-regulated markets, we're a very long way from where the targets need to be. So that top graph at the top, that's where current regulations sit at the moment. So about 140 kilowatt hours per square meter a year. So if you design to the building regulations in UK market, that's where your consumption sits. However, our target that we need to be at is a quarter of that. So 75% below the current regulation. So I think one of the big things we're seeing, and I think there's a lot of work happening in this space, is there's a big lag between where regulations are and where we need to be. The other good thing to see on there as well is best practice is so much better than where current regulation is. So I think we see that the same here. And again, is that regulations really haven't moved nearly as quickly as where they need to be, but also more importantly, they haven't moved nearly as quickly as where the industry has gone. So I think it's pleasing to see in some sense that the industry, even without regulation, has been able to accelerate to that point and is driving things. And largely that's driven by forces outside of regulation, mainly finance, where the finance sector or insurance sectors are sort of driving this. But it shows sort of where we need to really get to. And what we're also seeing is, in terms of, this is some comparison we looked at between code compliant buildings and sort of low energy best practice buildings. And what we're starting to see is the element which is the plug loads, which is you're plugging in your TVs, your laptops, your phone chargers on efficient buildings, is now becoming the dominant sort of consumer, as opposed to sort of the heating and cooling part. And I think that's again where sort of the role of sort of renewables and grid comes in as well. So in terms of, I talked a bit earlier about sort of what we've been looking to do on all our projects to sort of provide sort of pathways to clients around achieving sort of net zero. And I think it follows the same, I guess, prioritization that we've seen through sort of low carbon design. Firstly, it starts on architecture, reducing volume of internal conditioned spaces, optimizing massing, looking at the envelope, reducing window to wall ratios, optimizing performance, reducing leakage, which I think was talked about earlier, lighting equipment performance, and obviously then as well on the HVAC. So I think it's, again, the facade has a very, very important role to play in that. And this is a bit of a live document that we have that we sort of update sort of every 6 months or so as we're kind of feeding in data. And again, it's generalized and it's sort of what we see sort of generally, and obviously you have to apply that appropriately on projects, but it's sort of some rules of thumb that we followed in terms of where sort of low carbon or net zero designs needs to be in terms of the massing orientation and form factor, optimum sort of floor plate depths that we should be looking to achieve, in terms of U-value performances, which is probably relevant to people in this room, in terms of where projects that we've been able to get to sort of net zero have been achieved. Again, then on the sort of systems and equipment where they need to get to as well. So again, we keep this sort of updated, and we have different sort of benchmarks and rules of thumb for different buildings. And again, we'd welcome any feedback from anyone, because as I said, it's a journey we all need to kind of be pushing forward together. And if we can sort of see, look, there's some of these that we can push further, advance performance, then that's something to look at as well. So yeah, that's all. Hopefully there's some insights of information there, but I think it's a very exciting space, I think, at the moment. Despite the challenges, I think we are seeing that there is a lot of trajection behind this, both from the government but also on the private sector. As I said, probably the key snippet of information is that this is coming through at sort of warp speed at the moment. As I said, all of a sudden we're working with a number of sort of corporates and governments that have set net zero 2030, net zero 2040 programs and strategies. So basically anyone that wants to be working with those entities needs to be on board as a supply chain providing that input as well. So thanks very much, and yeah, enjoy the rest of the day. Thank you.
Thank you, Saeed. Thank you, Saeed, for sharing all this useful information. Yes, indeed, you know, the issue of net zero carbon and the CO2 emissions are, like they say, the talk of the town now. And I just want to make a clear differentiation between designing low carbon emission buildings and the fact that we have something called net zero, because they are two different topics. The first one means that we were going to design the building in a way that it will reduce the emissions in the atmosphere, while net zero basically deals with the governmental approach or the country approach to actually take out as much CO2 from the atmosphere as much as they are pumping in. So that's the net zero effect. So on a building design level, it cannot be net zero, but on an overall ecosystem, it can be a net zero effect. Okay, next, I would like to invite our second speaker to the stage, Mr. Jasmin Hodzic, the Marketing Director of AME Guarding Glass.
Hello, good morning, everyone. Well, to start with, I'm very happy to see that there are a lot of facade experts here. And this is an absolute amazing setup here. We are like, I said to Ahmed, it's like a fashion week in Paris or somewhere else. So hopefully we are having another subject. So, but amazing job, guys. I mean, I see Zak, we are now for some years working together, and I see this is really evolving in a very, very interesting way. And this knowledge sharing network that you guys are creating, it's absolutely amazing. So from our side today, I will basically speak about three things. The first one, we would like to showcase one of the projects, which is on the other side of the Sheikh Zayed Road, and how we try to bring the right solution for that building when it comes to glass. The second subject, I think it's very common, as Mr. Abbar mentioned before. There is a lot of discussion around sustainability. At Guardian, we speak rather about stewardship. It's a bit different concept, but at the end of the day, we are all heading for the same goal, right? And how we can help the value chain, the entire value chain at these different stages of the project to find the right solutions. And the third thing, which is very exciting for us, we have some new products and that you can see at our stand. So I will talk a little bit about that as we are basically launching. We launched 2 weeks ago a last comer in our double silver coatings range. Okay, so let's start with so Al-Wasl Tower. So as you guys, I mean, first of all, the venue here, it's amazing. Sky views, that's another Guardian project as well. Same glass solution as Burj Khalifa. So on this side of Sheikh Zayed Road, now we are looking, if you look at the other side of the Sheikh Zayed Road, you will see obviously Al-Wasl Tower under construction. Here also I would like to thank our partners, UN Studio, Werner Sobek, Al-Wasl Properties, who entrusted us to bring the solution for when it comes to glass for this building. So Basically, the idea, and I don't want to talk obviously in the place of UN Studio, but in our discussions was to say, hey, very often it's happening that there are buildings which are built in a kind of isolation. So how to change this concept and make actually the building be much more interactive with its environment. So this is from where the idea of the twisted facade came, actually to make sure that the building is actually, the facade is facing every orientation. On the top of that, there is some very interesting, innovative solutions on that facade when it comes to ceramic fins. So this is also something that was designed by them in order to make sure that the cooling or the energy consumption of the building, it's at the best level, and also to provide a well-being for people. And that has also some LED to make sure that in the evening the building is going to interact with the environment. And moving forward, the building will be also connected to Dubai Mall metro station. So it will be possible also to connect to Dubai Mall by walking, not necessarily by driving. So what Guardian did here, so basically thanks to our network, international network, our colleagues in the Netherlands started to work with UN Studio, who is originally a Dutch company, architects, and together with the team here, to find the right solution for this building when it comes to glass. So once we had in the right understanding of the intention of the architect and the client, we could propose different solutions. But before we come to the solution, basically, what was very important is this interaction and knowledge sharing. So, and on the other side, with our technical experts, we were able to bring different solutions on the table based on the data, different calculations, and obviously the mock-up viewing. So at the end of the day, this is the glass product that was retained. Sangar DS bronze T for the vision part, and HD plus bronze T for the spandrel part. So at the particularity here, and to satisfy the vision of the architect and the client, was to provide something which will not obstruct interaction of people from the building with the exterior, at the same time provide also the well-being for them. So one of the important things is that this glass is coated on clear float, so it's not on a tinted substrate, which allow us to keep rather natural colors looking from inside to outside environment. At the same time, a very low reflection of internal and external reflection are again helping the people inside to have a good connection with the outside as well from outside to inside. So I think I invite you to see the building obviously from outside. Hopefully it will be finished in the next year and a half approximately. And I think it will be really a nice landmark building on that side of the Sheikh Zayed Road. This is what we can see today. Obviously on the left side, it's a photo provided by UN Studio, how it will look like when it's finished. And this is more or less the current status you can see on the other two buildings pictures. Moving forward, I'm coming to my second subject, which is about lead and Guardian whole facade calculation. So what we have recognized some time back is that, well, more and more buildings are basically asking for some level of green building certification. In this region, LEED, it's quite common. And we have seen that many of our partners in the value chain are struggling a little bit how to actually tackle the LEED subject. What we used to do in the past was providing a couple of certifications or a couple of documents for them to help get some points, but we thought, okay, we need to go another step further. So this is basically what we put in place. We said, okay, first of all, our products should help energy saving, and both, embedded carbon as well as once the building is functioning. Okay, so we pay a particular attention when we produce or when we develop a new product, and we have to contribute as much as we can to reach near zero energy buildings. So having said that, we said, okay, well, how we can further help to people reaching lead points. So we, since now almost 2 years, we have all our products who are EPD verified, and also we have a product lens. So those two certifications will help anyone to understand exactly how do we produce and what are the environmental impacts of those products as well as health. At the same time, those two certifications are allowing to compare between different products, different solutions. So in that case, the architect or the designer, the client, can understand actually what he's going to get on his building. At the same time, sometimes we have some products coming from Europe in this region. There are not that many, but our European products, they have also IGM certification, International Green Mark certification that can be used here in the region. Now, to accompany actually our partners, we have also made a couple of our colleagues, technical experts, are actually lead accredited associates. So they can have a fair discussion and recommendation from an early stage of projects to help actually design the right products for the facade, but also give some recommendation about other subjects, because this is what they are accredited for. So we invite, obviously, all our customers to consult us with that. We will be happy to help. The second part is that also since quite some time we were engaged with authorities in different countries here in the region to support them technically writing the building codes. What has changed from the past, in the past the building code was based on the center of the glass, which if you look today in the different building codes that exist in UAE, in Saudi Arabia, in other GCC countries, even Egypt, are not anymore just about the glass, but about the entire system. And again, during our interaction with our different partners, we have seen that there is sometimes some level of struggle for them to interpret and to calculate this building code. So what we have done, we have actually our technical team. It's today able to provide different B-dimensional, two-dimensional modeling of the heat transfers in the entire facade. So we are basically combining 3 different softwares to provide this calculation to our partners, where they will have not only center of glass value, but when it comes to the U value, so thermal insulation and solar heat gain coefficient, we are providing for the entire system, which means we take care of the frame, we take care of the center of glass, and we also do take care of the edges. So at this time, you can see on those slides, we are able to provide a full information so that we have a good understanding whether we are in the building codes or outside. This is one example. I think most of you have visited Expo. This is one of the examples where Saudi Arabian pavilion was awarded as the best pavilion in Expo 2022, and also got a LEED Platinum certification. So we have provided support here from very early stages, and the glass solution was a double silver product from Guardian. As you can see, the facade is inclinated, so there is no too much direct light coming in. So we could put here a product that has a quite high for the region light transmission, around 70%, but quite low solar heat gain coefficient because it's a double silver, quite selective products. But this is there is a lot of quite some work prior to come to this solution, basically with different people in the value chain, starting from the from architects. And this is where we really would invite people to engage with us as early as possible. Even sometimes we do intervene in a pre-design stage to give our recommendation to help the process going through a little bit more smoothly than when we are sometimes asked at the end, hey, can you just provide this glass for us? So I come now to my last part, which is also very exciting for us. We have seen, and I think it's not unknown to all of you, we have seen that the last couple of years, the trend is going away from the colors, especially here in the UAE, and it goes more toward neutrality or, let's say, grayish-looking products. So we started to develop a few products in our range, and I'm happy to introduce the latest innovation. As I said, we launched this product 15 days ago, and well, it is called SN Gray 40. So what is very particular with this product, and you can see this is the real picture of the product. It is coated again on a clear substrate. Okay, it has around 36% of light transmission. With a solar heat gain coefficient of 0.21 for those who are familiar. I think most of you are. And it has a natural grayish color without color shift when we move from the angle. So which means if you even look at the facade from a certain angle, the color will remain as it is. And on the top of that, both outside and inside reflections are very low. So 8% for the outer reflection and 13% for inner reflection will again allow to have this natural connection between inside and outside of the building. So we are very excited to launch this product right now. And if you go outside, on the left side, I think when we go out from this door, there is our stand. We have some samples of different glass products, obviously this one as well, and which are displayed in a bit different way. We are also trying to innovate a little bit in the way how we show glass, because this is another art. I believe many times when we visit people and when we look a sample inside the room, basically we don't see the true color, because the lighting conditions are the same on both sides of the glass, and we have came out with some innovative, let's say, way of showing where people can see the sky, custard sky or the blue sky with some lighting conditions that will allow to see the real colors. So I think that's basically all what I had to say. Again, thank you very much for hosting us. We are super excited to see all of you and to interact with you at our stand. Thank you.
Thank you, Jasmin, for the enlightening presentation.
Thank you.
Our company, IBECE, actually doing the facade engineering execution for the Al-Wasl Tower. And it's very nice that we've seen Jasmin talk about it. He was focusing on the, on the aesthetic part and on the function of the glass. But he should also know that his glass is called bent into location in many areas. And that's a very highly advanced kind of technique we are using, because that building is no easy job. It's a very challenging job. Okay, and there are so many twisted profiles and kink panels as well as cold bent panels. So we're planning like later on to prepare a presentation in specific for Al-Wasl Tower. Okay, right now it's under construction. As you can see, it is being built, 18 months until completion. Another thing is the actual thing of selectivity that also Jasmin talked about. Actually, when you select the glass, there's something called selectivity. We cannot basically filter all the sunlight out or the heat out and choose all the light to be in. There's something called selectivity in the matter, and I think technology right now with the deposition of metals, we are able to hit around 2.1. So for every one bundle of energy, of heat energy we get into the glass, okay, we are able to get 2.1 light, but not more than that. We cannot block all the heat and take all the light. We have a limit of technology. We are hoping, like, by triple layer and even more, we are able to do better. We have our third speaker of the day. So, ladies and gentlemen, please give a round of applause to Mr. Obada Adra. Mr. Obada is the Associate Principal and Office Director for CallisonRTKL.
Thank you very much. Okay, good morning, and thank you for having me here. Now, we have a very mixed audience here, so what I'm about to present might be very boring for some, so apologies, but I hope it will be interesting for some, so please be patient. So, my name is Obada. I'm CRTKL's Dubai Office Director. Allow me to introduce our company. We are a global architecture, planning, and design practice. We've been around for 70 years. We've got 900 people in 17 offices around the world. 50 are based in Dubai. Throughout our career, we've been very lucky to work with some great clients on very exciting projects and win awards while doing so that was fun. But what we pride ourselves with, what I would like to share with you, is how we work. Because collaboration is at the heart of what we do. We do not create, we co-create. This always gives us better results, but it's a lot of fun as well. We are a partner end-to-end, working with our clients and partners through strategy, vision, and development. We believe that the spaces between disciplines are where innovation would happen. Learning from each other is where new ideas come to life. We base everything we do on our understanding of people. We believe in the power of design, collaboration, designing for change, our talents and expertise, our clients and partners. What I would like to talk about right now is the combination of facade and parametric design and how we can use it to achieve different targets. And of course, the possibilities are limitless. So in different projects, we go with different approaches. Our peers will have their own approaches as well. But what I would like to show here is in a narrow spectrum of what we do in different projects. So I'll start with the first one, Exit 10. And this is what we call a conventional approach. We've worked on this with WME as the engineers and Inhabit as our facade consultants. Now, this is an entertainment cluster, one of many that are being built in Saudi right now under construction. And because it is all about entertainment, it was supposed to be playful from the inside out. And this is one of those projects when you get caught in the moment and you do something funky that the client likes, and you get stuck and you have to deliver it. So what we wanted to do is that we wanted to make sure that our process is streamlined, it's simple, it allows for experimentations, iterations, going back and forth until you get the right result. And because we're 100% BIM, so we'll work on Revit, but we want to make sure that we get the right platform that supports what we do. So we use Grasshopper and Rhino. And then what we do is that we integrate both. So we've got Rhino inside Revit, which allows us to design on Rhino and have all the fun that we want to do, but eventually see it in Revit and document it the way we want. And through a very simple script, like the one you see on screen right now, we were able to create this playful envelope. And instantly, we can see the panel sizes, the joints, these fine details like lighting on the screen, tweak it, and go back and forth until we get what we're all happy with. And the process is quite simple because you start with a simple plane that eventually will be folded to give you the right envelope, and then unfolded to be documented. So it allows for that integration and experimentation as needed. Now, it also allows you to go back to go more into details, so looking into textures and fine fenestrations, all can be done at the same time. Of course, we can't do it without working with the engineers and the facade consultants, but this is the process that we usually do. The other part of the project was the cinema box. So if we do this one on Revit, it's very hard to do. It wouldn't even give us what we wanted to do, but following the same process, through a simple script on Grasshopper, we start to get the right envelope, we get the right panelization, and then we get the final geometry. So this is the conventional approach. You use Rhino and Grasshopper, integrate those into Revit, and you get your final result. And this is, I believe, what everybody else is doing. Now, on a different approach, and this is a project that is also under construction in Saudi, we've done it in collaboration with a big team. AESG was one of them as well, but the part that I'm going to present was developed working with Werner Sobek and RWDI. So this is a part of a big master plan. This is Mohammed bin Salman non-profit city. So the master plan was developed by ASMP. We're doing what they call phase 1, Al-Mishraq. And it's your conventional mix of uses. So it has lots of residential. It has retail and F&B at the base. It has an office cluster in the middle. And it has also a cinema, a culinary institute, and so on. But the interesting part, I mean, there are two parts that we believe are interesting about this project, is that one, it is meant to be an incubator for the youth. So this is where they'll get their opportunity, they'll get their training, they'll get their first step towards growth. And the other thing is that we were asked to design for a specific challenge, which is designing a thermally comfortable outdoor space that works all year long in Riyadh, and also remain sustainable at the same time. And that was fun. So like what we do in every project, we start to look into the architecture, the planning principles of what's in the region. We analyze it. We come up with simple principles that we apply to our project. On the right, then we cross-check it against what was built years ago in the region to make sure that we get the right balance. Then we work into the architecture, same like most people are doing in Saudi. It has to be off the place. It's Salmani. So we make sure we get the right massing, the right fenestration. But at the heart of the project, the blue part here on screen, is what we call the linear lab. This is where the experimentation would happen. This is where you break the rules. And this is what we also changed the architecture. And this is where we introduced that central spine, the thermally comfortable spine. So step one was to ensure that it is shaded, because it's really hot in Saudi. So you shade it, but you want to make sure that your shading is inspired by the local culture. It is an innovative design that ignites this in the youth around it. It allows for the required connectivity between the different sides of the project, and it allows for thermal comfort. And we've looked around, and then we found our inspiration in the project itself. It's called Al-Mishraq. Al-Mishraq in Arabic, in Saudi culture, actually, it is the place where the elderly used to sit to observe sunrise and catch up on their day. In Arabic language, it's the direction from which the sunrise is observed. It's deeply rooted in Saudi culture, but it's also a strong metaphor for the path of progression and enlightenment. So we wanted to capture that moment, simplify it, and use it to create our canopy. Now the challenge is, how can we do that? So step one, that's the linear part that we have in our project, which eventually will connect east and west throughout the whole master plan. So we create a simple shading structure, we refine it to fit our context, we bend it down so it actually rests on the roof of the building. Then we introduced 4 key moments where this will sit on the ground, and this is where we insert our wind towers. Of course, we cannot provide the thermal comfort levels that we wanted to do without shading and air movement. So those wind towers eventually will play a key part in the development of this scheme. But what we wanted to do as well is to break the scale down into something smaller, a bit more human scale, so people can observe it from below. So what we've worked on with the engineers from Werner Sobek is breaking the scale down. We've agreed eventually to use PTFE as our main shading devices and a supporting steel structure around. But what was nice and what was interesting in the process is that we want to make sure that we have enough daylight. We want to have sun only when we need the sun to penetrate, so very early during the day, very late in the afternoon. So working also on Rhino and Grasshopper, we were able to panelize this canopy, break it down into smaller components, then tilt it as needed, and then check the amount of light that we get and go refine and back and forth until you make sure that, yes, you get light at the right time, but during the middle of the day, you don't get any. The other thing is that we've worked on the wind towers. Now, it was a long process of modeling, then CFD simulations done in collaboration with Werner Sobek and RWDI until we get to something that actually is buildable. So while it looks quite simple from the outside, there's a lot that goes inside to ensure that, one, it allows for passive airflow when there is enough wind in around. And when there isn't, it actually would, the drum would rotate and it would close. And then you start to funnel air through fans that enforce the air down to make sure that you have a constant stream of air. And then you start to mist it and so on. So this was, I would say, the tools that we've used. But the challenge was to be able to show how can you get that thermal comfort levels that you wanted. So what we designed for is not the red temperature that you see on your phone or your watch in the morning. It is the felt temperature, and there's a difference between the two. If you're standing under the sun in the middle of summer, you'll feel really bad. It's going to be very hot, and while the temperature might say 45 degrees, you will actually feel what is equivalent to a 55 degrees. But the moment you move into the shade, you feel much better, even though the temperature didn't change. So, but that's a felt temperature, and if there is a good breeze of air around you, then you feel even better. And in a dry weather like Riyadh, if you have to have enough mist in the air and humidity, you feel even much better. So while the temperature still reads the same, the way you feel it is totally different, and this is what we're designing for. So we said, if you stand in the middle of our project, the middle of the summer, 1st of August, which is the hottest day in Saudi, and then you will feel as if it's 55 degrees, which is horrible. The moment you shade it, deeply shade it, reject between 80 to 90% of the heat that you can get from the sun, you'll feel as if it was dropped by 10 degrees. So it goes down from 55 to 45, which is good, but not good enough. You insert our wind towers, start to get the passive air to go through. It feels a bit better. You get what is equivalent to 5 more degrees. Then you start to move the air, force it through the fans so it's a bit higher, so you get more out of it. You add canopies, you add trees and umbrellas, so you feel a bit more better. So that's 2 more degrees. And then you add your final layer of misting and evaporative cooling, which will drop it down by additional 5 degrees, takes you down to 23 degrees. Now, this could be a guess unless we actually can do the right simulations, and this is what we've been working on. So this is the amount of air that we get through the wind towers when they're just working passively. And the moment you start to force the air through the fans, it gets a bit better. We've supplemented those fans with booster fans that are actually mounted on the roofs of the buildings, so it feels a bit more better. Now, in terms of thermal comforts, the yellow, the bar that you see shows you, it goes between black or dark blue all the way to red, so the closer it is to red, the worse it is. So with simple air movement, you have a little bit of green in the middle, so it's not very comfortable all the way around. With forced air movement, it's a bit better. With booster fans, it's even better. Then the moment you add your evaporative cooling and misting, the whole thing becomes green, and so it's much more comfortable. And then if you take into consideration the fact that people will be sitting and dining there, so it's even much more comfortable. So this was done through a series of simulations back and forth, working with the engineers, and then refining the design and increasing the air velocity or the amount of air and so on, until we get what actually is comfortable. So now that we have solved, I would say, the main challenge, which is the thermal comfort levels of it, and we want to make sure that actually it looks nice, so when you're underneath, it feels like a playful, dynamic thing, even though it is still, because of the way light will move the shadows all around, and at night, the whole thing will become more like a canvas, so you can project, you can do whatever you want to do with it. So architecturally, it works. In terms of thermal comfort, it works. Now we want to be able to build it. Now, this shows the wind towers where it hits the ground, and then we've got the water feature at the base, which eventually deflects the air to make sure that it reaches the biggest footprint as possible. Now, the challenge was, one, to model it correctly. So we start like we usually do on Rhino, then we create the simple geometry, then we panelize it, then we start to rotate those sheets to allow for the desired amount of light. Then we somehow extrapolate our main supporting structure and our panels. Now, this is where the architects finish, I would say, playing, and everything goes to the engineers when they need to make things reality. Now, the good thing is that we share the same platforms, so what we use Rhino and Grasshopper, they use the same also integrated within the software, so they took our models and they start to work around it, going back and forth until we get, we'll be very sure that what we see on the screen can actually stand in reality. So there was a lot of revisions and refinements to ensure that we get there. And then at the end, we've reached out to the final amount of details, and we were actually sure that we can build it the way we see it right now on screen. So this was the end result. And this is, as I say, a different approach of integrating facade and parametric design together. Now, the third approach is a project that we've done in Dubai. It's also under construction. And while it also is based on facade and parametric design, but it's a smaller component, but the project would never have happened without it. So our client here, Miras, came to us with a vision. This is the site of what they call City Walk Phase 5, and they've asked us to help out. They had a vision, wanted to create something unique, as a community that revolves around the park, so it has to stand out. It's a new typology, and they wanted, use it as a differentiator in the market. They had an existing master plan, which is what we see on screen, and we, as CRTKL, we were asked to look at only one of the buildings to design the facades. And because of what we do and the way we do it, we try to investigate everything around it. So we've assessed the existing master plan, and we believe that it doesn't achieve what the client wanted, even though it was approved, but it doesn't do what it needs to do. Because one, it's a divided community. Two, residences are isolated from the park. Three, only a small component, small percentage of your residents will actually be able to see the park. So you're spending a lot of money, but you're not getting the most out of it. So if it doesn't work, what should we do? So our goal as architects is to use architecture to positively influence the residents and the community. So we wanted to give something back to the end users by giving them, maximizing their exposure to and access to greenery, to the city by introducing a big park, and to the developer by improving their ROIs. So what we did is that took a few steps backward, say, okay, you want us to look at the building, but we actually will look at the bigger master plan first, then we go back to the building. So what we did is that, okay, so this is park living. So what defines park living? So one, you have to have an uninterrupted view of the park directly from your living room. You should be sitting and seeing the park in front of you. What does that do? It promotes mental well-being, which is scientifically proven. The other thing is that you need to have a direct access to the park. Right from your front door, you need to go to the park, never cross a road or anything. The third thing is that you need to allow for freedom of space. People should be able to walk around and enjoy the park. This promotes their physical well-being. It's also scientifically proven. If you have access to a recreational area, you'll use it more often as if it was quite far. So with these three simple principles, we said, okay, we know what we want to do. Now, how can we do it? How can we design for park views? Now, unlike when we design for sea views or Burj Khalifa views, where the higher you go, the better it is, designing for greenery is the opposite. The higher you go, the less you see, because you have a finite amount of greenery in front of you. So one, we need to set our height. How high can we go? So we're designing for someone sitting inside his living room. So by the time we reach our 18th floor, we can only see half the park without a balcony. But if we have a balcony, we can see almost none of the park. So we know our challenges. The other thing here is how can we scientifically measure the amount of views that we see, the amount of park that we see. And this is where facade and parametric design came through. So we've developed a script, same thing, using Grasshopper and Rhino. The script creates links from every point of the park all the way to the facade. And then based on the amount of points that you get, that color of that facade changes. So we know what we get, we can quantify it. So we ran that quick simulation, and we've tested the master plan that we were given. And we saw that what we thought was right. Only 25% of those who live here can actually see the park. So it is a hugely underutilized value. So we've quickly tested the building topology that we have. We went from a U shape to an L shape, and this is the beauty of parametric design. It allows you to do this. And the moment you go into an L-shaped topology, you've gone up from 25% to 39%. So that's good, but it's not good enough. Then we've tested a V shape, not much better, an inverted V shape, a tower topology. None of these actually gave us what we wanted to do. So they're all better than what we had, but they're not good enough. So it doesn't really achieve what the client wanted. We still have the same challenges. So what we thought is that, okay, let's think different. Why live in front of a park when you can live inside the park? Now, how can we do that? We went back to the design that we got from the client. This is the master plan that you've given us. And these are the masses that actually compromise the views. This is what makes it worse for those who live here. So let's take those and place them inside the park. So instead of being the worst units, they become the best units. And then to make sure that the park is not compromised. We've lifted everything up. We've sloped our podiums down, so the park, instead of stopping at the end of the podium, it goes all the way to the edge of the master plan, and then we've lifted the whole thing up, created openings, and inserted community facilities in the middle of the park. Now, what does that do? Eventually, it means that you can exit your living room, go down the lifts, and through your lobby, you're in the middle of the park. And this is what we wanted to do. We wanted to make sure that you have that leisure of living inside the park. Step 2 was to go back and test our design against the same criteria. So we went up from 25% to 63% of our facades now have direct views. And we've more than doubled the client's ROIs without increasing the cost. Now, we went back to the building that we were asked to design, and we reran our simulation. We're at 70%. So between 25% to 70%, almost 3 times the returns for the developer, but it's also 70% more people, or 3 times more people actually have that luxury of seeing greenery and accessing greenery. And we have the park itself is now twice as big as it was before. Now, the end result was a simple typology as a master plan. It's almost like a courtyard, but it's not a building. It's a community. But it acts actually like a heart of the bigger development in City Walk. This is currently under construction. I think the last 2 buildings will be launched soon, but we've been working with Miras on this one. So as a result, we won the competition. We've redesigned the master plan. We've redesigned all the buildings. We're working with them one by one, and every building is launched, is actually sold within an hour or 2, so it's quite successful now in the market. But what we were proud of is that we were actually able to provide people with this. So you are immersed, you're sitting within it. And we could have only done it if we thought differently about the tools that we have, which is facade and parametric design. But the end result is something that is very simple, but it adds a lot of value to everyone around it. And that's it. Thank you very much. Let me just put this one back.
Thank you, Obada.
Thank you.
Very nice presentation indeed. Very insightful, and thinking outside the box is what we need. As we can see, the use of software and modeling and Python and Grasshopper and Rhino, and all these softwares are giving us an edge in terms of actually, deciding what to do with these buildings. Otherwise, we just, hope that it would work. I mean, the actual push from 25% park views into 70% is something phenomenal. So thank you. Our next speaker is Paulo Carvalho, Mr. Paulo Carvalho. He's the Commercial and Corporate Relations Director, MENA, at Effisus.
I'm here.
Thank you.
So, good morning, everybody. I think this is, yeah. So, good morning, everybody. So, my name is Paulo Carvalho. I'm the Commercial Corporate Relations of Effisus. It's a pleasure to be here in Zak, and congratulations to Zak. We are upgrading the level. It's a nice stage, actually. It's good to see familiar faces, new faces as well. People experts from Façades. So thank you very much for being here. Thank you for your time to be here to listen to my presentation. So today I will speak about how can we save lives through non-combustible membranes. I would like to start my presentation with a quote. Of course, it's not my quote, but I think I want to start in this way because it will give a guidance for my presentation. So the quote, and I'll quote, says, architecture can't solve the problems of the world, but it can make the difference. It can create spaces that nature and heal. It can be a refugee for those in need. It can save lives. This is a quote from Michael Murphy. So in my presentation today, I'll speak about the standard approach in the market, the way that Effisus approaches. I'll speak about non-combustible weatherproofing solutions. Effisus is a worldwide brand. We are weatherproofing experts. And I think it's also important that we speak on reality, what we have examples. And we have examples all over the world, in UAE, UK, and in all the globe. So there is a generic approach that is approach of cost-driven approach. So we are, all of us know, because price is always an issue. But when we are driven only by this, there's a lack of customization. There's a limit in the innovation. There's a lack of flexibility for the projects. And it's a big dependence on the supply chain. So this is the mass production directive approach. We have a completely different approach. We have an approach of interaction, being in contact with the different agents of the market. We are, from the starting to the end, we are in contact with the architects. We are in contact with the consultants. We try to understand the needs of the project and the needs of the market. With this, we deliver bespoke solutions that are adapted to the project, to the market, to the region. And we do strong partnerships. For us, success is being together with our direct customer, but not only, with everyone that intervenes in the project. So it's our goal always that we reach in the end of each project with increased satisfaction and peace of mind. I brought in here these examples of severe fires, and unfortunately, I brought also last year. And unfortunately, this continues worldwide. And here in our city, for instance, this week, we had another fire in our residential tower in Al-Handasah. Also, unfortunately, these situations of severe fires, they are increasing. If we see the chart, they are increasing drastically. And they are increasing because we keep using materials that are combustible materials in the facades. So the number of incidents is rising drastically in the last 30 years. At the same time, we have the fire regulations. For instance, in UK, the fire regulation in UK clearly states that materials used in facades should comply with A1, S1, D0. Also, in the UAE, it states the same. For instance, vapor barriers, they should comply with A1, S1, D0. So, code regulations, and this is not only in UK, not only in Dubai, also in Europe, and is a trend, the code regulations mention that the solution should be fire-rated. So, the facade industry, consultants, contractors, architects, insurance companies, universities, laboratories, we have a problem. That is the severe fires that are keep on growing. At the same time, there is the regulations that states that we should use in the facades fire-rated solutions. So there is a responsibility for each one of us, that is the power of decision, that is the power of influence to change the outcome. For the last years, for the last decades, we are working together with the facade industry, with our industrial partners, with labs, with universities, and with architects. I will ask your attention, please, for 2 minutes, because I would like to bring the opinion of some of your colleagues, some experts. So please, 2 minutes of your attention.
If there is a product available then that has an improved fire performance and it gets to A2, A1, then we should use it. But I think we also have to have a wider consideration of the product, the product's performance and capabilities, and what the actual risk is. If we can make sure that those products at the beginning, they've got a compatibility between all the constituent parts, we've got certification, and there is some history of use, and they've done some weather testing, that will give us the confidence really to recommend those products.
To move everything into the limited combustibility bucket, if you like, is where you want to be. And that's not just for EPDM membranes or
for all the overall picture. Yes.
Overall pictures. Yeah. So that's where we should be going ideally. That's where the industry should be heading towards.
It's absolutely critical. In the UK, we suffer from extremes of climate, temperature, moisture in the air. All of our buildings are constantly, settling in foundation terms are moving due to thermal expansion or contraction during the colder period. So the elasticity properties of EBPMs are really critical.
I think it's more than afraid. I'm really concerned that when we are approaching this building safety bill now going to be implemented on all of our projects. I think we all need to be accountable for the work we do, and it really is going to be a eye opener for a lot of people who had shied away from responsible working, specifying correct products and also approving the correct products, on the details. So I think it's coming that, we all need to be accountable and, responsible in the way we work and, not compromise on the, the quality over cost is, I think,
Right.
should be the main concern. But yeah, it's frightening when it's coming.
In the grand scheme of things, life is immediate. In an instant, it has come and gone. Time has passed us by. Have we seized it? Life is urgent. It's important. We must care for it in revolutionary ways. Waiting for tomorrow is a waste of time. We will never reach it. It will always be a day away. The universe expanding. Why shouldn't we? Proflex FR, elongation, fire rated.
So I wanted to bring this because we had the opinion of experts. What is the need in the market? We know what are the requirements of the market. And we work for the last decades, and we bring something that can fulfill these requirements. We bring something that is completely revolutionary, and we are very happy to announce this, because it's fire-rated with elasticity. So this is an answer for one of the problems that before they didn't have answer. So this is a kind of solution that is elongated fire-rated, and this is completely revolutionary. So this is a solution that before we didn't have an answer. So around the perimeters, we have an answer for previously for fire-rated barriers, but not for the interconnections. So this was the challenge that now we have an answer. I also want to resume because effectively it is in our hands to choose the solutions that fulfill and that comply in terms of weatherproofing and in terms of fire. We have the vapor, the system, we have the new product that is revolutionary, and we have the breather. So if we think in terms of what I mentioned previously, in terms of what are requirements of the market, in terms of what are the problems that exist in terms of fire, then we have the solution, then we have an answer, and we have an answer. Also, I brought an example because when we work in different markets and in different climates, we need to adapt the solutions in terms of weatherproofing envelope to each region. And for instance, if we have a cold climate like UK, so in the exterior, we should use a breather membrane, and the interior, we should use an ABCL vapor control layer to block from the inside. For instance, this is the breather membrane. It's a typical detail, for instance, that we use in UK or in Europe. We see the cement particle board, and on top of it, we should use a membrane that is fire, UV resistant, and breathable at the same time. And this is the resume. So if we are in a cold climate, we should use something, a membrane, a solution, a system that is fire-rated, at the same time is a breathable, and that can be a completely system in order that you can adapt and customize for each project. If we are in a climate like Dubai, then it's the other way around. We should block the vapor from the outside. Why? Because we have hot outside and cold inside. So we should adapt. So we should use a membrane that is vapor control layer, AVCL, that is fire rated and that is a system. This is just a resume. So if we are in a cold climate, like hot climate, sorry, like Dubai, we should use some system that is fire rated and that blocks the vapor from the outside to the inside. The systems that we are presenting here, they are completed because we have the different accessories that we can customize to each project. So to concrete, to aluminum, to glass. And a very particular important thing are the details in the project when we have penetrations, when we have overlaps. The sealing of these penetrations and overlaps, it's really, really important. So with the different accessories, we can do the overlaps and we can seal each detail, each penetration. And this is very, very important. So, of course, that the solutions and the systems, they should be tested according with the different standards in the different markets. For instance, here we can see how we do the test, British standard AN 1026. We see the window frame and we see the membrane with the connections all around. And of course, that each market that we are present, we have the specific certificates for those markets. For instance, British Board of Agreement or Socotec in France, in the perspective of fire, Dubai Civil Defense. So each market that we approach, we certify the products according with the requirements of each market. And of course, one thing is test, the other thing is certifications, the other thing is examples of installation. So we have these solutions installed, used worldwide. And I brought some particular projects that we did here in Dubai. For instance, this is, all of us know, Burj Al Arab. On the heliport recladding, we are using there the vapor control layer with accessories. Also, I brought one example of UAE Pavilion in Expo 2020, where we use the vapor control layer. Another example in Dubai Creek Harbor, where we use the vapor control layer with accessories to seal the penetrations. Dubai Creek Harbor, the Grand, this is just one of the examples of the projects. We have been involved in several projects in Dubai Creek Harbor. Icon City, it's a project that is ongoing and that we are using a vapor control layer and sealing all the penetrations with accessories that are tested and certified in the system. A project that was that we made, that we are involved with, the Central Bank of Iraq. Because of this particular detailing, we are using the breather system. So it's a breathable membrane that is fire rated. Also in Riyadh, we are involved in the metro station. So the specs in this particular project were to use a vapor control layer that was A1 fire rated. And of course, different geographies in UK. As I mentioned previous, we have an example where we use the breather from the outside, the vapor from inside, and all the perimeters are sealed with our accessories. So as we saw, we don't need to compromise. So we have the solutions, we have the answers. So we can, not only from the technical point of view, but from the fire rate point of view, we have the solutions. So it depends on us. So we are the only one, again, the one and only again. We have been the only one in 2011 to have the first A2 fire rated membrane, and we are the only one again in the world to have something that is fire rated at the same time with elasticity. And I'm proud to enunciate this here in Zak. So thank you very much to all. It's a pleasure to be here, and I wish you all a very nice day. Thank you very much.
Thank you, Paulo, for the nice presentation. Yeah, of course, fire and the fire saving, it saves lives. And we all, unfortunately, we had our fair share of these fires here in Dubai. Additionally, and unfortunately, so many of we face problems with people not understanding that the difference between a breather membrane, a water vapor control membrane, as well as a waterproofing membrane. So that elaboration was also noted. Please, we will now head for a 20-minute break, where you can take this chance to actually, mingle among the crowds, exchange business cards, do some networking, and have some tea and coffee. I would like to please invite the speakers, Mr. Saeed, Mr. Jasmin, Mr. Obada, and Mr. Paulo to remain with us so that we can exchange some souvenirs given by Schüco. Okay. Okay. Everybody can go to the break now if you want. Thank you so much. Nice networking session, and had enough coffee to fuel yourselves for the remaining sessions and to keep you and I awake. Okay, so as for now, we're going to have 5 more presentations for this session. So for our 5th presenter, let's give a warm welcome to our 5th speaker of the day, Mr. Sam Park. He's a partner architect at Foster & Partners.
Good morning, everyone. Nice to see you all. My name is Sam Park from Foster & Partners. It's first time to stand on this cruciform stage, so I'll try to rotate around so I can see you all. I've been working for Foster's for about 17 years, so 10 years in London and 7 years in Dubai. So I have my colleagues from Dubai office cheering for me today. So it's a pleasure also to, thank you for having us here so we can talk about the way we design facade. So I'll be talking about facade design from composing, communicating, and conducting a facade perspective. A facade comes in different tempos and speed. And a facade also has different variations and materials and patterns. It also plays with light and shadow. Also, sometimes it brings a memory of nature. Sometimes there is crescendo and decrescendo on the facade. Sometimes it moves to the rhythm. I like to think about facade in terms of music because there are a lot of similarities. So composing on music requires putting the idea and developing that idea, putting a motif, and then put that as a piece of music. And facade design has a very similar process. We come up with ideas, we develop ideas and put that as motifs and then apply to the building design. And like music, which requires understanding of instrument players to be able to write good piece of music, also facade design requires good understanding of how engineers work, how and environmentally it works, how it works commercially, how it works aesthetically altogether. And then the intended piece of music is getting played through orchestra. Now, often a conductor faces a challenge because he has an amazing piece of music, however, he doesn't have a flutist that he wanted, or he doesn't have a drummer that he wanted. And then he needs to then make adjustment to play the piece of music while maintaining the intended the piece of music. Now, architects face same challenge on site because there are challenges technically, commercially, or other reasons. So architect will have to adjust certain things on site, but again, while maintaining the design intent. So I like to compare architecture against music because of that reason. So today I'll be talking about how an architect composes, coordinates, and conducts a facade design through a few projects we've done in this region. the Alif, the mobility pavilion. Many of you may have visited it, and many of you have remember how interesting that was. I want to talk a little bit about the background of that project. So the site has 3 different thematic districts, and our project is located in Mobility District. It's a signature pavilion as a permanent building. Site is triangular shape, and there were 3 different sub-themes to be accommodated. So there's digital world, the physical world, and the unified world. So what we wanted to create was a seamless experience through these 3 sub-themes. And that really led us to think about how we can create this experience through this seamless kind of loop experience. So as you can see, there are so many different ideas being tested. I cannot show everything on this one screen, but these are a few selected ideas that I'm showing to you on the screen. This is probably the form that you are familiar with. Some of you may think that we have followed the shape of a fidget spinner toy. Well, we didn't look at that. We actually went through the process of finding the best form that can accommodate what it has to accommodate. So there are 3 petals accommodating 3 different exhibitions. So there is a mobility of people, mobility of goods, and mobility of information. That's what informed the shape of these 3 petals. Then this experience of inside a building goes outside as well, through the landscape. Then there's a brief to design a building that can be used for 2 different phases. So in a way, this building has 2 different lives. So during the expo time, it's going to be used, as an exhibition space to accommodate those 3 themes. During the legacy period, then this building turns into an office building. So this building was designed in a way that it can receive extra floor plates, extra cores, and toilet blocks to function as office building during the legacy. We were inspired by the movement of cars. So this is a mobility track in Lingotto in Italy, used by Fiat. So they do the test run on top of their building. So this really inspired us how to design this building. So we came up with an idea of these tracks having different speeds, weaving in and out the building. So these brings people under the building, come outside the building, becomes a bridge, and comes down again. We also looked at, in terms of facade, how aerodynamics informs the shape. So what you see on the screen is a metallic aeroplane wing, which really inspired us. The way it was designed is really telling us about the speed and movement. Another image that really inspired us was this correlation between the vehicle and this jet's smoke that really tells the aerodynamics of a vehicle. So even although this is a still motion, you can still feel the motion and the movement of the car. So this informed the facade design. So there's a stainless steel fins horizontally wrapping around the building. And then there is also interesting play between the glass panels and the stainless steel. Sometimes glass panels gets revealed, sometimes stainless steel fins getting pronounced, sometimes fins go up and down, creating entrances. The stainless steel also reflects during the daytime the sky, and during the sunset, it reflects also the surroundings. During the nighttime, there's a flood of light. The sequence has been designed in a way that the building has an illusion of movement. So the building looks like it's moving. Maybe that's why many people think that this is related to fidget spinner, because it feels like it's moving. In terms of facade, it was very complicated geometry, so we had to use our parametric tools. In the beginning, every fin shape was different. So as you can see, the sections, it was challenging in terms of manufacturing it, in terms of standardize it, but we managed to standardize in sections so that we don't have to deal with so many different profiles. Also, as I mentioned briefly, the legacy. The top image is showing the way the building is now, which is during the expo time. There is a lift in the middle that moves up and down, and there are void spaces in the petals accommodating the exhibition. But during the legacy period, down below, then there are extra floor plates getting inserted, and the lift in the middle gets removed, and it's going to be used as a skylight. And the facade has been designed in a way that it can accommodate these extra floor plates for the future use. So this is a view of an office during the legacy period. So there's ample daylight coming through, and also there's a view that connects between upper levels and lower levels. So one on the left-hand side is design mock-up that we built. So we have a sketch model shop where we can build this one-to-one scale model out of cardboard. This is a very important process for us to understand the scale of it and inclination of it and what kind of experience we can get from the facade. And that informed the design geometry statement, which is the image in the middle, so that help us to refine the facade design. And it led to engineering, detailing, and modeling on the right-hand side. For us, it's really important to review samples, not in an isolated way, but put them together to simulate the condition that is as close as possible to the reality. So on this photo, you can see different glass samples being reviewed, also stainless steel and then soffit. As much as possible, put them all together and then review and give meaningful comments. Then that led to the one-to-one scale, full-scale mock-up, or rather visual prototype using the actual materials. So this was a very important piece of mock-up that we had to build to make sure that we select the right glass types, and also this was used, it wasn't just used to celebrate the piece of architecture, but we left it outside during the sandstorm and the weather conditions so that it can be dirty, so we can test how we can clean this effectively through different cleaning methodologies. There have been a few issues also discovered during the mock-up stage because there are so many things that you cannot see on the piece of paper. So when you put things together, especially at the interfaces, you start discovering these issues three-dimensionally, which gives an opportunity through the mock-up that we can address these issues. So facade design in a very simple term, this is a parametric geometry and then different sections. Another important thing that we normally carry out is a factory visit because it gives us an opportunity to understand the capacity of the manufacturer, but also we can give them the direct comments and adjustments. So this is the section of the fins. And then different finishes were reviewed in their factory. Then we asked them to put them together to demonstrate by the contractor what was commented through the mock-up was actually addressed. So this is what we call a first article. So there is a process of cutting, grinding, welding, and polishing, and applying right finishes all together in their factory, which we have examined and also gave comments on. This is an area that is super challenging because of the geometry. There's no column, so there's a massive span that this steel structure had to overcome. So this stainless steel fin has a steel structure inside of it, but because of the span, there was a movement that we had to rectify. So there was active damper used to control the movement, to counterbalance it. That's the view that shows how that was manufactured and then built on site. And this is how it looks like nowadays. Our role on site is very, very important because we go to the site every day. And because as a designer, we know our design intent. Therefore, we can go to the site and examine what has been built. Even before the inspection request is issued to us, we go around the site and we pick up anything that seems to be wrong. So we give early warnings to the contractor. So this is a very important aspect that role that we play on site as a conductor role, as I mentioned, because we care about the quality, we care about what we have intended is actually delivered. Sustainable aspects, so there are photovoltaic panels and solar hot water panels used on the roof, but really, thanks to the great play of the facade design, we achieved LEED Gold with this building. And it became super popular, if you remember, during the expo time. Yeah. Next project I want to talk about is Palm Flower. So this is a residential building on the Palm Jumeirah, on the western beach, right behind Coco Bay. The brief was very interesting and challenging at the same time to us. So the client wanted a new level of luxury as a residential building. So we started thinking about how we can bring the level of luxury that is not existing in Dubai. So we come up with an idea of having every single floor has one apartment, but also every apartment has double height living room spaces. To achieve this double height living room space on every single apartment, we had to stagger them. So there are units facing Marina side, there are units facing the Palm side. So because of this staggered kind of arrangement, we can achieve double height living room for every single apartment. It was also designed during the time of COVID. So one of the requirements was all the amenities should be within the apartments. So the swimming pool is on the terrace, and also on the back side there's a landscape garden for individuals, and also the gym is within the apartment without having to share these amenities. The shape of the balconies were really inspired by palm flowers. So hence the project name, Palm Flower Project. So the petals of this palm flower inspired us to think about how we can shape these balconies. And we collaborate early on with our design communications team, which helped us to refine our ideas and develop this idea of having inside out and outside in, which got developed through a series of visualizations, as well as model studies. So this is a one-section model that shows the balcony, which accommodates the swimming pool. And you can see the double-height living room right behind it that has staircase that connects to the upper level within that apartment. Solar analysis helped us to redefine and adjust the petal, the balcony, to make sure that there's not undesired solar gain to the units, but effectively it creates a shade to the units and also privacy that's required. That's the view from the beach amongst the neighboring buildings. Structurally speaking, the petals are having steel structure to accommodate the swimming pool inside, to make sure that weight is not too much. So to maintain the lightweight, we have steel structure that is fixed onto the edge of the precast concrete slabs. That's the section. In terms of orientation, so we have, towards the water, we have swimming pools, and towards the back side of the building, we have plants, and that's more private functions in terms of planning. That's the rear side of the apartment. Now the petal cladding. One of the things that we wanted to achieve was a seamless expression of this petal. However, there are limitations of materials. So what we wanted was to minimize the joints and maximize the panel sizes within the context of what the logistics allows for. So we studied different materials, so all the way from GRC and precast concrete, UHPC, welded aluminum, and ceramic tiles, which come with different pros and cons. And these are a few examples where these materials are used. So this is a panelization of how these petals are designed. So this is RCP, reflective ceiling plans, showing the paneling layout. Now this is in 3D, so it's a 3 meters maximum width and 12 meters maximum length. So this is a one unit that's going to be manufactured in factory and delivered on site with a 10 mil joint. We had 1 meter by 1 meter mock-up in different materials, so welded aluminum, Corian, and styro. So these helped us to understand the pros and cons of each material and also limits of its material. So that helps us to narrow down the selection of materials. So this is one of the examples that we're exploring at the moment, UHPC. So full-size mock-up is being fabricated. So using the CNC machine, this robotic arm is cutting the polystyrene form in the desired geometry and assembled. And this is used to create a concrete panel, UHPC, that is following the geometry. So this is all work in progress at the moment. And this is not another example, welded aluminum. So this is a 3 meter by 6 meter mock-up. Also, this was a very helpful piece of a mock-up to understand the opportunities and limitations of such material. This is the way it's been fabricated. So there is a mold in 3D, having correct 3D curvature. And then aluminum panel is then wrapped around it and then stretched against the mold. Then it gets adjusted and welded and ground together. And then it receives desired finishes. So that's a photo of work in progress 1-to-1 scale mock-up. So with the client, I'm just looking at the petal mock-up. So this is, we are so excited the way that this is coming along at the moment. Now this is receiving the right finishes. So this project is on site at the moment. There's a big hole in Palm Jumeirah. So we hope that we can show this project completed sometime soon. The last project I want to talk about is ICD Brookfield Place in DIFC Dubai. Has a very different language. So this is a master plan of the IFC that was given to us, which was done a long time ago. So that's a site, that's a ground floor of the site. What we want to challenge was the way this plot connects to the DIFC, because there was no meaningful connection given to us. So we proposed this, which is diagonal, 12-meter wide connection that connects the street back onto the IFC mall. And then that informed the podium, and also that informed the tower that is 45-degree rotated. And importantly, summer garden that sits between the tower and podium, which is the heart of the project. Different forms of tower has been tested in early on stage. So these are all the models we made during very, very early on time. We tested different materiality from more solid facade to facade that has directionality, so fins blocking certain views and solar gain, and that allows views to the other angles. Different permutations, so we use parametric tools to understand how we can modify and improve the facade design. So by pulling and pushing these nodes and also changing the tapering amount, we could achieve the balance between what was economically required and what was aesthetically desired. These are all study models we made. And another very important aspect of this project is what we call A-frame. So the tower columns are coming down on the perimeters, and if you let them coming through, we'll end up seeing lots of columns on the ground floor. So we wanted to get rid of them by transferring them. So it's called A-frame. So it's actually mega structure, transferring all the load coming down from the tower using these diagonal columns. And it's clad with this stainless steel. I can tell you more about this a little bit later. And another feature that we studied was what we call tapered mullions. So basically the reason why we looked at tapered mullion that's shown in the middle is because we wanted to minimize the optical size of the mullion. There's a physical size we need, but by tapering it from where you are standing, you can actually minimize the visual impact of it to maximize the view from the office. Another feature is what we call kissing transom, because we didn't want to break the spandrel panel, so we wanted to have floor-to-floor full glazing while having the spandrel, while having the transom behind this. So transom is just touching the glass without breaking the glass. So we can really emphasize the verticality of this facade. These are study models that we made to find the best form of the mullions. And this is how it looks from the actual office inside. Another feature that we studied was a podium, the fins, canopy. So this allows shading to the facade, while it allows the mechanical ventilation that can be connected to this system, which looks like this. This is how we usually work together, which we have forgotten during the COVID time. We all go into the same meeting room, client, all the consultants, architects together from morning to the evening until we find solutions on the agenda. No one leaves the room until we find a solution. This is using the VR. It may not seem very new to you, but this was taken in 2015. So 8 years ago, when VR was not really known to anybody, we used a game engine to bring the 3D model into the game engine, and we invited the client to have him experience the building before we build it, which was a very effective tool. Glass sample reviews, these are some of you might be very familiar with this. Then we scale up. We filter down the glasses that are not suitable for the project. Then we build a glass box. So we review this during daytime and nighttime from outside and inside. Then we filter out what is not suitable for the project. Stainless steel, also having similar process. This is a tabletop mock-up, but this one-to-one scale kind of shrunken version, testing the crucial details. Also on site, rather than having just trackers going through, we have workshops with consultants and contractors together to find their solutions for the project. Glass manufacturing, we visit and review this glass as well. And really importantly, this mock-up. So for ICD Brookfield Place, we built 5 mock-ups having different aspects. So this is a typical tower facade mock-up, which was about 20 meters tall. But we use this not only for the facade, but we use this for interior mock-up as well as the lighting mock-up. These are details tested, and interior also was tested. Anisotropy, another very important aspect, was also tested through this, and other crucial details. Jumbo glass on the low level, and this is how we measure the stainless steel deviations. But at the end of the day, it's all about the relationship. So we try to maintain good relationship with everyone. So it's, yes, a memorable moment, consultants and contractors smiling together. Because at the end of the day, although we are sometimes hated on site because we reject so many things, when the building is completed, contractors actually are happy with this result because we push their limit. And then they use that project as a benchmark for next job. So it's win-win for everyone. So thank you for listening, and thank you.
Thank you, Elsa. Speaking of being hated on site, okay, so yeah, I mean, like architects, they have this notorious, description that they are being hated on site. I'm a facade engineer. I hold an MSc in facade engineering, so I'm not an architect. And yes, at the start, we always think, why are architects doing all this crazy stuff? Why are they making engineers' lives so difficult here and there? But the truth of the matter is, without architects pushing the boundaries and doing all this crazy stuff so that we could enhance our engineering skills to achieve what they want, we, as engineers, would build boxes. We'd be out of jobs. So that's the truth of the matter. On to our next speaker, Mr. Phil Schneider, Head of Sales, EMEA, Vector Foiltec.
Thanks, Osama, and to say I'm very impressed about this stage. It's always a surprise. You surprise me, always, Zak World of Façades. I've joined a lot of these conferences, but this 360 degrees view, it's very impressive. I hope I will do it quite well. Therefore, I brought a little question to you. Whom of you knows this project? Whom of you has seen this project, maybe from Dubai commuting to Abu Dhabi? Anyone recognizes this? Maybe raise your hands. Okay. And see, maybe 50% of you have seen it. Another question, who knows what this building is and of what kind of material it is? It's not that many anymore, but some of you, yeah. Thanks a lot. Yeah, actually, this is ETFE. This is a botanical garden. Actually, it's open, it's for free, it's for kids. In there, they're trying to grow now all the plants. And just between Dubai and Abu Dhabi, like a little recommendation when you're passing by or going to Abu Dhabi, passing by, just drop there and maybe have a little look to this ETFE system. But let's start with the idea. It's creating spaces. And this was a very futuristic, visionary idea of Buckminster Fuller back in the 60s, covering the whole of Manhattan in order to have no air conditioning anymore, no heating, no nothing. It's all one tempered space. This is a waste area, and you would ask yourself, what are these guys doing? Exactly, building another botanical garden. This is the first, let's say, worldwide known ETFE project. Back 20 years ago, the Eden project in Cornwall. And what you can see is that it's a transparent roof, but it's ultra lightweight. We are talking about only 5 kilos, and therefore a substructure that is almost not seen, and a material that is UV transparent. Therefore, all these plants can grow and grow. Just to give you some examples of how it can be used for concerts, you see the lighting effects. And best of all, I know this is not a high-resolution photo, but I still love it. The guy, the installer, our rope access installer, you can see how small someone is in front of these big, huge panels. One of these panels has a side length of 9 meters in total. Perfect.
Well, it's always impressive to walk into a building like this where you really don't walk into a building, you walk right into the middle of the jungle. All elements are a technology to clad large structures as well as small structures. For a project like the Eden project, the foil elements are of a very important nature because they are UV transparent, and plants need UV transparency to grow fast and to be healthy. The core feature is transparent buildings, but we can do other things as well. Well, we've developed this cladding material 30 years ago. It's a multi-layer system of duopolymer foils that we weld by chamber, and once on site, we install it with and fill the cushions with air. I've been for years competing in ocean races around the world, and the technology of designing sails is very similar to what we do today. Technology that we have developed can only be done by a small and medium-sized company. You need to react fast, come up with a technical solution fast, and it helps a lot being a couple of friends, so you rely on each other very
So at least the music is going well, not that much, the video before. I'm sorry for that. But you might ask yourself, okay, you have seen this Eden project in the UK, what it has to do here with the region, with the Gulf region. And I would love to introduce a mega project built approximately 10 years ago in Kuwait, one of the biggest shopping malls here in the region, 75,000 square meters of ETFE. And the joy of it is bringing the outside in. So obviously, especially during summer, it's very hot, it's unbearable, so you need enclosed spaces, but on the other hand, you want to feel like you're outside. You shouldn't feel any structure that you can see here. So our solution is, for example, in here, a barrel-walled roof. This is spanning 40 meters. We're having a width of 4.5 meters of one cushion panel, and the joy of it, the people are just exercising. Sometimes they're even jogging, they're meeting, and no one even recognizes this great roof. So actually, for us, the goal is that the people don't recognize and see the roof and say, oh, okay, I was just walking outside and didn't even recognize any structure. And just to give you a little comparison, the first stage of the Avenues project was built in glass. Obviously, very beautiful, this nice diagrams with these triangles. But if you see the comparison of how large spanning our ETFE is in comparison with glass, I see that there's some difference. But on the other hand, we are talking with ETFE about freeform. It's not just boring the rectangular cushions, but it can be also very creative. You can freeform all these things, and this is the dome, the Forum Romanum, also in the Courvals Avenue, that on one hand, they try to have a grand avenue where you don't see anything. You're not seeing the roof. But in this case, actually have a spotlight where people go and take pictures, taking it for Instagram or whatsoever. So this is a big landmark. And one of the other things is what we are getting asked, how do you protect everything from sun? You have seen most of the roofs are transparent, especially the one from the Eden project. This is printed, so we have a certain solar heat gain coefficient, so you can tell us what you need, and we will print it. But nevertheless, I think back there you can see the Hilton in the back. This is a hotel. You see how transparent still this roof is, even though we are coating it, and we achieve with this one a solar heat gain coefficient of 0.22. Just as an example. So there are some other retail projects coming up, but I would love to talk about Dubai. I guess most of you know this area here. It's at the JBR beach, near the marina. They had one big problem. In summer, this was an open space, the walk there at the beach, and most of the restaurants over there were not really visited. And obviously that's a problem. People have to go there, consume, and the idea was then to enclose that. But obviously it's a problem, for example, to enclose it with glass because it would be very heavy. In the beginning, this structure wasn't planned that there was anything on top of it. Therefore, they were thinking about an ultra lightweight solution. So this is our solution, ETFE, as I've mentioned, very, very light, but still transparent. So that was an existing building refurbished with an ETFE solution. And you can see here, this is not, let's say, boring, but a lean arched cushions, which, I actually didn't install, but you can see me here. I was at least with our installation team there. So we as Vector Foiltec designed and built the whole project until installation. And this is the finished one, and maybe showing a little bit of the lifestyle under a roof like that. Also, this roof is printed, so it's, you can still see the sky, even though you have a quite good solar heat gain coefficient. Also, a very nice one, and that's more a biophilic approach for students, the Royal Grammar School. This is just a rendering, but this is how it looks then as a finished project. A nice diamond-shaped roofs, quite big, quite flat. And I think you from CallisonRTKL, Obada, you were mentioning the well-being of people, seeing outside, seeing parks. I think this is also something here with students. They want to see trees and palms, etc., And with the ETFE, which is UV transparent, you can achieve that quite well in getting this atmosphere. Another video, this will be the largest ETFE project in this world. It's a big, huge botanical garden in Riyadh. It will open, I think, in 2 to 3 years, but actually it's already 75% at least installed with ETFE cushions. Just one of these mega projects. So previously you saw some of the smaller projects, which we love, great applications, but also for mega projects, this is obviously in a sense of botanical garden. I'm very sorry that the resolution is not really there. This was one of our guys from a tower crane that took a picture. Yeah, this is how it looks right now. Quite nice, quite impressive, and massively big. Just to give you some impressions of our installation, and also me visiting the site with some colleagues, and that's where we are at the moment. So I'm really looking forward to one of these mega projects KSA. So we as Vector Foiltec, not only here in the region in the UAE, but also Vector Foiltec KSA. But let's talk quickly about the system itself, of how it works. You have seen a lot of pictures, obviously, and the system usually has a supporting steel structure. We have the supporting steel structure, an upstand made of steel, and then an aluminum clamping system, quite similar to the one in glass. So this is the base extrusion. Then we clip in the foil, the ETFE foil, which then is clamped by a cap and a screw. It's sealed with silicone, with a silicone gasket. So therefore, it's 100% waterproof 2 times. And then it's getting air pressured. So the idea of the whole system, it's air pressured. So first of all, good thing is you have a static component to it. It's stable. And on the other hand, you have a certain insulation, which is quite important for the U value, obviously. So we can play around with the U values, 2, 3 layers, up to 4 layers, and achieve U values up to 1.0. So just because maybe some of you are afraid of this, what does it mean, air inflation unit? What you can see here is one air inflation unit that covers 3,000 square meters approximately. So this can be hidden anywhere, you won't recognize it or see it. Something very important here in the region, material durability. On the left hand, you see our owner who invented the system, very young. And on the right hand, almost 40 years later, he's still there, a lot grayer, but it's still the same roof. So the longevity of this material is very long, and the best thing about the foil, it's UV stable. And often we are asked here in the region, okay guys, you are from Europe, you don't understand our climate, how does it work with UV? I can assure you it's UV stable, and we have a lifespan of approximately 50 years and more for the ETFE foil itself. The system has a warranty of 10 years, but the design life for the system is approximately 30 years, and the foil more than 50 years. And others are also afraid of the strength. You can see here it's fall-through safe. You could even walk on a cushion. A car can do it. Of course, it will get scratches, so we don't recommend that, but it's We'll go through the prints coating. I've mentioned that already, so we can achieve certain G values of solar heat gain coefficient. This is just an example from 1.8 to down to 0.15, depending of what you want to achieve. You just tell us, and we apply that. And last but not least, also the U value characteristic. Enclosed spaces are very important that we insulate that. Usually in this region, we recommend a 2 or 3 layer system in that case. And last but not least, for me very important is the sustainability aspect. We are owning an EPD for our system. And further, what is very, very important, see, okay, now the time is over, perfect timing, which is very, very important, is that obviously with ETFE you need less steel structure. You need less concrete because we have less transfer loads. So therefore, our carbon footprint is very, very low. Also, the transportation is very, very low. So if you take the carbon footprint of ETFE, it's just a pure joy if you think in a holistic way. And to finish up with my presentation is to just showcase you some of the projects here in the region. That was for the Dubai Expo, quite nice structure with lights. And that's what you have just seen, the Botanical Garden in Abu Dhabi, or closing with the royal tent. And maybe to give it away as my last sentence, you saw the futuristic from Buckminster Fuller on the left hand in the 60s, and our vision for the future is to have covered cities with ETFE. It will look like that, and hopefully we will see that soon, maybe here or anywhere in the Gulf region. Thanks a lot.
Thank you, Phil. ETFEs are definitely materials that are creative and unorthodox, and that can be used to reduce carbon print. On to our first lady presenter, and our 7th speaker of the day, Mrs. Michelle Bacellar from Meinhardt Façade. She's the technical director.
Thank you. Where is the... Okay, thanks. Good morning. Pleasure to be here. Good to see so many familiar faces and old colleagues from the industry. Today I'm going to be talking about one of the projects we've been working on for the last 3 years. It's called the Sheibara Island Resort in KSA. This resort is a 73-key hyper-luxurious resort located in the Sheibara Island, which is a 45-minute boat ride from the mainland in the Red Sea. The site is completely off-grid, so the development includes solar farm that generates all the power for the development. It also includes solar desalination plant that supplies all the fresh water, and it also has its own recycling plant to minimize the amount of waste that goes back into the main land. The project is developed by the Red Sea Global. The architect was Killer Design. The engineering team was Arcadis Middle East. We were employed under the engineering team to develop the design of the facade and provide the supervision during the construction stages. And the facade works were awarded to Grandcraft, did all the metal works, Glassline did all the glazing works, and Thomas Bell White was the third-party lab awarded for the thermal testing of this project. So this development, it spreads horizontally across the site in the forms of several individual assets. So you have a bunch of amenity assets, such as the arrival lobby, restaurants, family pool, adult pool, and so on. And then you have the residential assets, the accommodation assets, which come in the form of beach villas and overwater villas. In this presentation, I'm going to be focusing on the facade design for a typical one-bedroom overwater villa. So the design approach for this villa was to minimize the environment footprint of the villa. So the villa only touches the ground on a very few square meters, and it's connected to the ground via a column that we call the neck. The villa, it's an ellipsoid shape, and it's got two cutouts for the entrance and for the external terrace. The roof incorporates a skylight and a roof access hatch. The overall dimensions of this villa is 18 meters diameter, 6 meters high. The design approach for the facade of this villa was to minimize the visual impact. So the idea was to have a very high reflective finish, so the villa could reflect its surrounds and merge with the environment. So our job was to find the correct or the right system and also the materials that would achieve this design vision. So initially, the design intent for the structure of the shell was to have a carbon fiber reinforced structure. So our job was to look at ways of cladding this shell to achieve the design vision. So we looked at this stage, we looked at very high reflective coatings. We've looked at actually cladding the shell with, and then we looked at options of having flat, very small stainless steel tiles. We looked at options of having single curved stainless steel strips. We've looked at options of having large double curved tiles. We've presented, all the samples have been done for all those options. We presented to the client, but this was rejected by the client and by the architect because they didn't feel we achieved the design vision. The coated solutions, they provided a seamless look, but they weren't reflective enough, and the stainless steel panel solutions, they had too many joints. So at this stage, we've been asked to look at the feasibility of having this villa done as a one unit of stainless steel panels welded together, forming a completely seamless envelope. So we've started our design by looking at precedent examples for such structure. And at the time, the only thing that we could find was art pieces or monument-like structures that were non-habitable. So this is a very famous structure, the Cloud9 or the Bing in Chicago, which is made out of 168 stainless steel panels, 10 millimeter thick with stiffener plates. And it's, all the plates are welded together and polished to provide this completely seamless appearance. So during the construction of this Bing, they've built a tent on site, and they had a crew of 24 workers working for over 12 months, just polishing the structure to achieve this similar appearance. So based on this example, we knew we had a very big challenge ahead of us, which was to design a construction of similar appearance, but with a much lighter weight construction and achieve a much faster construction period. So we began our design by looking what would be the most optimum thickness for the shell. Now, when you work on structures like this, the thickness is not only driven by the structural requirements, we need to look at fabrication as well. So, the thickness of the material needs to withstand the fabrication, needs to withstand the double curving process, it needs to withstand the welding, the grinding, the polishing, and so on. And there's another point that was very a driving factor on this project, which was the visual appearance. So we need to make sure that the shell was thick enough so we wouldn't have any visual distortions, but also thin enough to keep the construction weight down. So we've begun our analysis by testing different structural arrangements for the supporting frame. And then we've designed this, we've analyzed these structural arrangements and the thermal loads. Then we've got the deflected shape of the shell and the thermal loads, and we've rendered under different backgrounds so we could understand how much that deflection would impact on the visual distortion of the shell. So we've tested different backgrounds. So on the zebra background, obviously, all the deflections are very visible. But then we looked at other conditions that are more closely to the final condition on site, which is clear sky and cloudy skies. So we found that, we could compromise on a little bit of deflection because, when the shell reflected those images, like the sky and cloudy sky and the water below, the deflections, the visual disturbance was not so apparent. Also, another thing that we found on this analysis is that the majority of the deflections were happening either on the roof or the underbelly of the structure, that the geometry was a little bit flatter. So those were the two areas that were reflecting either sky or water, so we didn't have too much visual disturbance there. And on the sides of the structure, because of the curvature shape of the structure, the shell was much stiffer there, so we had hardly any deflections there that caused vision disturbance. So this analysis was used for two main things. First, to determine what was the best structural framing arrangement for the shell, but also to help us determine what would be the deflection criteria that we would use in order to maintain the visual quality of the shell. Also, as part of the design, we had to ensure that all connections were flexible. So we've designed all the connections to be sliding connections. So all the connections are fitted with Teflon pads to allow for the sliding, and also they allow minor compression. So what that does is it allows the external shell to deflect almost independent from the base structure. Also, we've specified, in order to make sure that confirm the design, we specified a number of tests for this structure. So we had, obviously, the standard impact tests, surface scratch, indentation tests. All those tests, we've also nominated that the contractor should also make the repair on the shell, so we could also understand what would be the quality of the repairing works. And then we have the weld tests, load tests. We've also done accelerated weathering tests. So all the stainless steel has been subjected to over 1,000 hours of salt spray to make sure that it wasn't going to corrode over time. But one thing that we've developed for this project was a non-standard test. The reason why we've done that is because this is not a typical project. So on a typical facade design, you have panels, and then the panels have joints around the panels. So that enables you to design the facade to accommodate any movements from the building structure. In this project, we didn't have that. We have one unit. So there was great concern of how this shell would behave under the temperature loads. So for this, we've developed this test that is based on the AMA thermal cycling test, where we've built a full villa, and then this villa is subjected to 3 thermal cycles of loads between 5 to 85 degrees centigrade. The chamber for this test had to be built on the assembly facility. So it's a massive chamber, 22 by 22 meters. The chamber is clad with insulated panels and fitted in with infrared bulb panels, and also air conditioning equipment to create the thermal cycles. The temperature inside the villa during the test is kept at 24 degrees. And also the chamber is fitted with cameras to record any visual distortion on the shell during the test. And inside the villa, we have audio equipment that records any noises that the structure generates during the test. So as you can see, there was a lot of work done in order to ensure that that we would minimize any risks during the construction stage. Okay, so the villa is accessed for cleaning via access rope. So for this, we have an access hatch and anchorage points on the roof. There was big concern from the architect because they didn't want any of these elements to be visible. They wanted as much as possible to maintain this similar appearance. So the access hatch was completely custom designed, and you can see, I don't know if this is working here. Yeah, you can hardly see, it's a little bit dirty, this picture, the villa is a bit dirty, but you can just see the outline of the access hatch. All the anchorage points have been covered with small cover plates that are, I can't get it, that it's almost flush to the shell, so they're almost invisible. The skylight design was carefully placed, and the size of this skylight was also carefully designed to ensure that we could fit a 1 one direction curvature within the two directional curved shape of the shell. So that enabled us to use a standard flat glass that was cold bent into place into this one directional curve shape, which obviously, using a standard flat glass has significantly reduced the cost of this skylight as opposed to using a double curved glass. The glazing system is done by using these minimal sliding door frames. The door is curved and it's got concealed track. So I think if anyone is familiar with those systems, you know that the door lifts, they don't have the standard two rollers on the lift. They have a set of bearings that sit on the track of the door. So for the operation of the door, it's essential that the track needs to be 100% flat. If you have any undulations or any inclination on this track, then it compromises the door operation. So the design of this steel that supports the track had to be verified under a number of different design conditions. So the design strategy for the delivery of this project is to have a complete off-site manufacturing for the full villa. So the villa is assembled at the manufacturer's facility, and during assembly, it's supported on a temporary frame at 4 points. Then this villa is loaded onto a barge, and then the barge takes the villa to site where it's unloaded. When it's unloaded, it's connected at the neck to the pile caps. So this, and then the temporary support is removed. So when you remove the temporary support and connect the villa to the neck, there's a small movement on the structure due to that because it's a different support condition. And then later on during operation, the swimming pool at the terrace areas is filled with water, which again, the structure witnessed another set of movements. So all this had to be taken into account when designing the steel beam that supports the glazing to make sure that the glazing would not witness any of those movements. Okay, so then when we, as the design team, we were happy that most of the challenges related to the design were taken care of, we started looking at construction. So the project went out for tender. There was a lot of bidders that participated, and they all submitted samples as part of the tendering. Eventually, this project was awarded to Grandcraft Industries in Dubai, and this is the first sample that they've presented. Now, this sample includes 2 vertical weld joints, which is, as you can see from the photographs, they are almost unnoticeable. So it's very good quality. Everyone was very happy, but the question on everyone's heads was, okay, can they maintain this quality for a full villa? So as I said before, the design of the villa, there was a couple of cutout areas for the terrace in the entrance where the shell wraps on itself. And we knew that those areas were going to be very tricky to build. So the next, we've requested the contractor to make a mock-up of those areas. So the mock-ups and the samples, they got bigger and bigger, and each time they've included more details. But then at this stage, I think the whole design team and the client were very satisfied with the quality that could be achieved. So meanwhile, the production of the villas was ongoing. So the one-bedroom villa consists of 4 typical panels to create the ellipsoid shades, which essentially means that you have 4 modes for this villa. So the methodology used to double form the panels was the same as presented by you, Sam, before. It's a stretch forming, which essentially means you get the panel, you put over the mold, and you stretch until it takes the shape. Once the sheets were double banded, they were cut to size using a laser machine. After that, they were polished. So Grandcraft created a number of custom design machines to accommodate all the different panel shapes. So then those sheets were polished until they achieved the mirror finish. Once the sheets were finally fabricated, they were sent to the assembly area and erected onto the structural steel frame. After the erection, once they were aligned and connected, you'd start welding the seams and then polishing the seams. So it's a lot of manual work involved in getting these villas. And this is the result of the first villa produced. This is also being used as the benchmark villa. So this villa, when the contractor presented this villa to the design team and the client, They've moved the villa outside the fabrication facility, so the villa would reflect sky, and they've created a little pond under the villa to, reflect water to simulate the site conditions. This was, obviously everyone was very impressed because it achieves the design vision very well. As I said before, the strategy for the delivery of this project was to manufacture all the villas off-site. So the villas are being manufactured here in Dubai, in Sharjah, and all the subcontractors that are installing their respective works under this facility. As well as the structural steel frame and the stainless steel shell, the glazing works, the swimming pool, the MEP, and part of the idea being fitted into this villa before it's being sent to site. The total weight of the construction is about 115 tons. So once the villas are ready, they are wrapped, packed for transportation. Grand Craft facility is located in Al-Hamria, in Sharjah, by a canal, which facilitates the loading of the villas onto the back of the barge. So I think this photo is taken from Google Earth, and you can see two shiny circles there, which is two villas that are kind of at the end of the production line, ready for loading. The barges feed 4 villas at a time, and the trip to site takes about 22 days. Once the villas get near the site, they are then moved onto a smaller barge that can navigate the shallow waters. Then from the smaller barge, they are taken into their final position and unloaded onto the pile cap. So once the neck is connected to the pile cap, then the temporary frame is removed and the villa is ready to go. So I just want to finish this presentation by saying, by speaking a little bit about my experience working on this project, and I think Ilsen probably covered a little bit there as well. But working on such unique and innovative projects is not easy. It requires a lot of innovative thinking. You're doing something that has never been done before. So having a good relationship with the design team is really important because you need to kind of support each other through those decisions. But even more important is to have a good relationship with the client and the contractor because there's many challenges that come along the way with projects like that, and we need to work as a united team to overcome all those challenges. That's it. Thank you.
Thank you, Michelle.
Thank you.
A beautiful project indeed, and it's very nice to see how the facade design moved from the design stage into procurement, into fabrication, shipping, and installation. So again, thank you, Michelle. Anybody here from ChatGPT? Okay, good. So have you heard about ChatGPT? Can I have a show of hands? Okay. So we've used AI in our modeling, in our parametric modeling to achieve what we want at a faster pace and to get results. But for the ChatGPT, they always say that this software or this app can answer any question you think about, and it will answer in a matter of seconds. So Zak, people called me. They said, Osama, we want you to host this event. I was quite, interested, and I have a problem. I don't have any time to prepare anything, any speech. I was in Riyadh last week and just came at the start of this week. And I thought, I'll try ChatGPT so that I can, I'll ask it to write my complete keynote. And, I kind of pulled my app and I wrote basically best conference opening speech ever. Fingers crossed, huh? So I got this output, guys. Dear colleagues, our world is facing many challenges as we live in social instability caused by the pandemic. Obviously, according to their website, the app has a limited knowledge of world events after 2021. But then it continues, it says, however, there is still hope. Yeah, that's the only thing that was true because, I had 24-hour window to write my keynote speech. And that's all. Okay, guys. On to our next speaker, the very famous project director from Schüco Middle East, Mr. Alastair. Thank you, Osama. Just the middle one, yeah? Okay, thank you, thank you. So good afternoon, it should have been good morning, but obviously we're running a little bit late, so I will do my best to keep this within time. So for those of you who don't know me, my name is Alastair, and sorry, Osama, but I'm the technical director, not project director, but it's okay. So today I would like to go over 3 topics. For those of you who don't know, but these are very much our latest innovation systems, grid to shell, Internet of Facades, and subject on safety restraints, which is completely unknown in the industry to all intents and purposes. So first of all, G2S. Now, what if we had a system that is fully parametric, fully versatile, it's aluminium, we don't do steel, we're an aluminium system supplier, complete freedom of design, easy fabrication and installation, and cost-effective. So from the grid lines of the designer to the geodesic structural shell of the engineers, we bring you grid to shell, or as we like to call it, G2S. So the beauty of G2S is that the whole design and the engineering and the modeling, from the concept design right the way through to the installation even of the system, is all within the one model. So the whole design, and the whole modeling, and the whole generating of the nodal elements and the profiles and the mullions is all generated from within our 3D software. So when we look at a project in the first initial concept stage, even from a rendering or a basic SketchUp 3D model, we then model that into our 3D software to generate the complete skylight or facade system within the G2S system. So this is all done within our software. So we have to model the complete skylight, and then from that, we're able to get all the calculations from it, we're able to get all the cutting lists from it, the generation of the nodes, and the key element within the system are actually the nodal elements. And the nodal elements are produced by Schüco. They can only be produced by Schüco, because the whole key and the crux of the system is in these nodal elements. So they are produced by us, by Schüco, and by Schüco here in the UAE. We're not producing them in Europe, we're producing them actually here in the UAE for the global market. So the nodes themselves, they're produced from solid blocks of aluminium by high-precision CNC machines. And those CNC machines are under our control. And like I said, we are responsible. You can see in our booth outside an example of these nodes. And they're produced exactly to the geometry that is required of the skylight system or the grid shell system. And it's the geometry of the node that dictates the geometry of the skylight, because the mullions themselves within the system are all copy and paste. The only thing that changes in the mullion would be the length. So all the mullions are always with a 90-degree cut to the end. There's a special window milling because the connection between the mullion and the node is a bolted connection. So there's no steel in here. There's no welding in this system. It's completely with aluminium. And obviously, between aluminium and steel, in terms of the aesthetics, you cannot compare the two things. If you take a typical steel skylight system, as you can see on the right-hand side, and compare it to the aluminium G2S system on the left-hand side, there is no comparison in terms of the aesthetics. Even the grid shell steel systems compared to the aluminium, you cannot compare the aesthetics between what we can produce in the nodal elements compared to what's potentially possible in steel. And again, these pictures here, I think, just highlight that quite clearly, the difference in quality which is possible between aluminium and steel. And obviously, the benefit of it being aluminium, everything is fabricated and produced completely off-site. So the nodes are produced off-site, they're coated off-site, the mullions likewise. So on-site, there is no coating, there is no welding. Everything is done in a
in a factory environment, other than obviously the assembly. Of course, the system is extensively tested, and tested so much so that I don't think that there is another facade type system in the whole world which can achieve this type of water tightness. I mean, we hear of 4,500 pascals in terms of wind load, but 4,500 pascals in terms of water tightness, I think, is completely unprecedented. And obviously, well, I say obviously, but for those of you who are familiar with testing, you cannot stay in the chamber also beyond a certain pressure because there are safety concerns. So typically within, let's say, 1.2, 1.5 kPa, it wouldn't be safe to stay inside the chamber. So actually we had to stop the water testing at, I think it was 1.2 kPa. The guys had to leave it, and then it got back to, because in EN testing, it goes up in stages. So every 150 pascals, you're increasing the water tightness. So they started again at 1.2 kPa and continued by monitoring it with CCTV from inside the chamber until we got to the actual design load of 4.5 kPa, and it still wasn't leaking. But at that point, we had to stop because that was the maximum design load. And then, of course, safety design load at 1.5 times the wind pressure. So in terms of the performance, and of course, as a skylight or a parametric facade system, you need to have that comfortability in terms of its performance. Now, obviously, as I mentioned, this can be used whether it's a facade or a skylight. You can merge them both together. As a parametric system here, there is complete flexibility within the architect's desire, really, of what you want. It can be used also as a shading feature. It doesn't necessarily have to also be glazed. On this particular project here, it's really just a feature. But let's be honest, it's still a pretty cool feature. This, you're all welcome to come and see it. This is Mirdif Avenue Mall, not far, just around the corner from Mirdif Mall. And this is one of the first projects that we did in this region. This is just a pure feature, basically. It's not glazed, but the design intent was for it not to be glazed. You will notice there is approximately about 20% of the triangular elements, however, which are shaded. So this is what we were presented with in terms of the initial renderings of the project. And as you'll notice, as I mentioned there, you've got the shading features in there. And one of the systems also that we have within our portfolio is a system called Façade. And Façade is essentially a flexible fabric system which we have within our portfolio. So we took the idea of using the grid-to-shell system as well as our Façade system, which looks something like this, and looked how to combine them together. So the Façade plus the grid-to-shell system, put them together so that where we have these triangular shaded elements, we have this perfectly seamless geometry between where it's open and where it's shaded. So I think you can all agree here between the renderings and compared to real life, I think we hit the nail pretty much on the head. But I would like to just play this short video for you, which I think will give you a better insight into this particular project.
At Schüco, we strive to provide our clients with the best possible technical solutions, and our latest innovation system, Grid-to-Shell, or G2S, is the epitome of aluminium engineering. Clients and architects' free-form geometrical desires can readily come to life. The complete parametric aluminium skylight or facade is designed and engineered in our 3D software in a fully digital process from concept design through to fabrication.
مردف افنيو مول موقع مميز، البناء مميز، التصميم مميز، حاولنا نجيب الافضل شيء. فدورنا لين حصلنا شركه الشوكو، اول مشروع في دبي نفذ كنبي بالالومنيوم احنا وشركه الشوكو. قبل ما نركب هذا كان ناس اللي يجون حق التاجير قليلين، بعد ما شافوا الديكور والكنبي اللي جاي العجيب والشغل والتنظيف، احنا حاليا تقريبا اجرنا 70 الى 80%.
Our mission is to deliver world-class bespoke solution to fulfill our clients' requirements.
Here at Murdoch Avenue Mall, you can experience firsthand the true beauty of Schüco G2S. So of course, aluminium being a third of the weight of steel, and as you can see from that video, the installation can be greatly simplified. We don't necessarily need the big heavy scaffolding decks to support such a system in steel. There's several different ways that it can be installed. On, for example, Murdoch, we pre-assembled certain sections there and then lifted them into place. If the skylight is of a certain size, it could also be completely pre-assembled and then lifted directly onto site as well. Here on Murdoch, for example, what we did is that we had the use of one tower crane. So we made sure when we looked at the method statement how to install it, we pre-assembled the sections, obviously within a certain weight that could be capable to be lifted by the tower crane. So the sections further out where we started from were obviously lighter because obviously you got a less capacity of the tower crane at the end. And as we came in closer to the center of the tower crane, we were able to make those sections bigger to also speed up the installation. And this is obviously is possible with an aluminium system. So I can be whatever I want. I can be a skylight, I can be a facade, parametric facade, I can be both. I can be a skylight and I can be a facade. These are all previous examples that we have done as Schüco globally within the G2S system. As you can see here, this morphing between the facade into the skylight, or like I said, as a shading feature. We also looked at this as a link bridge system here. We did this for one exhibition, actually as a curved element of a link bridge, which was obviously challenging in itself. But again, these type of things which are possible with aluminium could be somewhat endless. So I think this is the only system in the world where it's a fully parametric system, and yet fully parametric, yet it is still a system. So all the design and the engineering and the production of the complicated bits, the nodal elements, this all comes under the supply of Schüco as the system supplier. And merging this vertical into horizontal, I think is quite unprecedented, especially when it comes to aluminium facades. The next topic I would like to talk about, as I mentioned, Internet of Facades. And I won't bore you with my voice here. Again, I'll let a video do the talking. But basically, the Internet of Facades is a digital twin of all the information within the window, within the sliding door, within the facade, which is then accessible to any user, particularly in the years to come once the project has been handed over.
Digitalization is changing how we build, but the vast majority of building management is still analog. With Schüco, Internet of Façades, and now our IOFID, we can leave pen and paper behind for good. Windows, doors, and sliding doors will no longer be independent elements, but rather links within a digital network of buildings, turning cities into smart cities. Schüco IOFID is a small tag with a big impact, giving one access to all the relevant product information and making mountains of specification documents a thing of the past. Storing this info digitally saves time, space, and money, and ensures maximum transparency. With IOF, building maintenance is more efficient and sustainable. Which handle was installed? When was maintenance last carried out? How can old components be recycled? All this information is available in the digital twin. It can be tracked anytime, anywhere. For clients, investors, and facility managers, this means more data, and ultimately, greater control. The future of the digital building envelope starts here with the new Internet of Façades ID from Schüco. For facades that can do more.
And lastly, I'm sure this is not new to everybody, and this is a picture which I personally took 2 days ago from our office building. It's not a Schüco facade, and for all the rocket scientists out there, no, that's not a door, but welcome to the Middle East. But top-hung windows are obviously the predominant window system which we sell in this market. Most high-rise projects, they go with top-hung windows. It's a sensible option, it's a logical option, it's the right option as the type of window. However, the reason why this is here is because, not because they don't work, but because there is a huge safety factor within these windows. In one of our offices, actually, that lady came into her office one morning and the window was literally half hanging out of the building, believe it or not. And you can see where the backdrop is. This is not in an unknown location. So, but this is not even necessarily an issue which is only for the Middle East. This is a global issue, and this is something actually which Germany has mandated to us as Schüco, which we will have to implement this into open-out window systems in the future. However, there is no standard for this. There is no standard for it. There is no starting point. What do you test to? What do you test against? Because there are no standards for how to prevent a window from falling out. You test a window when it's in the closed position, you test it to certain wind pressure, you test it to safety. Sure, yes, great. But often what happens, and the reason why windows fail, is because they're not in the closed position. They may be closed, but they're not locked. And if you get a sudden gust of differential air pressure, this can be enough, if the installation has not been done carefully, this can be enough to rip the window out of place. And windows falling out of facades is not unknown. So where do you start when there, like I say, there are no standards for it, so there's no testing for it, there's no procedure for it. So we had to make up our own. So we looked at the different scenarios, what could be the real life situation when it comes to this type of event. So we have a sample actually outside, which you'll be welcome to check. So we created and we developed basically a safety cable, which we fixed in our case, which is most commonly a top-hung window, at the top of the windows, in order so that if, heaven forbid, the window did fall out, it won't actually fall onto the ground and potentially hurt somebody. So we tested the tensile steel rods at the initial stages to approximately 5 times above what would actually be the weight of one of the heavier windows. We then did drop tests of the cables for double the size of what would be a typical window. You see in this little video here. So we tested it with that knee-jerk reaction of the load falling on the cables. We also tested it if, let's say, the window did have a sudden blowout from the facades, then what would happen? And here, this is what's happening at 4,500 pascals. So rather than that window falling out like this and then smashing onto the ground, it will stay in place. We then tested it. Okay, well, let's say it does do that, but then how long will it stay there? Maybe the hurricane, the storm is still going on. So then what happens? So we tested it also. So we tested it also for 48 hours on and off with a propeller being blown against it. So that at least we know that, let's say, if it does fall out and if it is hanging there, it's going to hang along, it's going to stay there for long enough so that people can come and then safely bring it back into the building, and it's not going to hurt somebody. So I think, and like I say, this has now been mandated to us from head office in Germany, that we need to implement these on all open-out window systems. And for the specifiers in this room, I think this is a critical point to bear in mind, is that without such a device, without such this belt and braces approach, there's always going to be that risk. Maybe not today, maybe not tomorrow, maybe in 10 years, maybe 20 years, but at least let's have that peace of mind that we can sleep easy. Thank you very much.
Thank you. Thanks. Thank you, Alastair. Schüco, always providing systems that are engineered at the cutting edge. On to our next speaker. We have a keynote speaker who has come all the way from New York. Please give him a good round of applause for Mr. Yama Karim, partner at studio Libeskind. Libeskind.
Yes, I think this is good. I have it. Thank you. Good afternoon, everyone. Thank you. Yes, I'm a little jet lagged. Slept through my alarm, and I realized again, why am I here? Because when our studio received the call from Zak and asked us to come and speak about facade innovation, I seriously thought they had the wrong number or the wrong office. Because usually we're the guys that are told we need facade engineers, right? And we need facade experts, and we need a solution for what we're trying to do. And that, in fact, often we apparently don't know what we're doing, which is kind of refreshing. I always like to think that I don't know what I'm doing, and there's an opportunity to learn something new. We have a unique kind of perspective on the idea of expertise. In the words of Frank Lloyd Wright, the definition of an expert is somebody who stops thinking. Well, that's obviously overgeneralizing. We do believe in expertise. We do believe in technology. But I think we take a different approach. We don't really take the approach of sort of innovation and technology kind of brought up in an incubator. We kind of like to confront what we know and the systems that are available and the materials that are available with the sort of gravity of the world. And we like to sort of challenge sort of the ordinary means and techniques and materials in new ways. And often we feel like that has led to some form of innovation or some form of, let's say, for the lack of a better word, some form of enlightenment or discovery. And some of the stuff that I'll show you is really rudimentary, especially for an audience like this. It's really not groundbreaking. And for most of you, you're going to realize and say, well, of course you shouldn't have used that material or that technique in this environment. But to me, not being an expert and kind of discovering everything like a kid is kind of enlightening. So our work is quite diverse. We do commercial work, we do museum work, we do some residential. But mostly we try to kind of challenge the standards. First project I'll tell you about is a project that was done really as a completion of the city of Dusseldorf. Like most 1950s, 60s, and 70s planning, the center of the city was in fact vacated and left for infrastructure. This used to be an old bus depot. The city decided that it was basically the heart of the city, the completion of the central square, and a primary public space, and that they would spend the money to sort of dig everything underground. The long and short of this project, aside from the fact that the facade looks quite unusual and animated, it does take cues from the context. It doesn't mimic the context. It does use stone and glass like most of the buildings around it. It uses the stone and glass in a different way, so it really challenges the concept of the cassette system. How does one break up the cassette? How does one unify it? Or how does one modularize it? So as you can see here, how it plays with the context and how it kind of both challenges the context and also takes cues from the context. We originally thought that this would actually look quite good with white marble, like Carrara marble, mixed in with stone, so that it would really kind of, with the cloudy skies of Dusseldorf, it would actually kind of blend with the sky. And of course, marble is used worldwide, and it's a very known entity. And just a very quick kind of anecdote to this idea of using marble. We realized that upon testing and upon actually looking at the expansion and contraction factors, that we couldn't use marble. And to us, that was a revelation. I mean, I thought marble is used everywhere in the world. So why can't we use it here? And it's quite simple. All of you know this. It's because marble is porous. And the fact that it's porous, and with freezing and thawing in a climate like Dusseldorf, it's going to crack over time. And so being a young architect at this time, while looking at this, a younger architect, I should say, that was kind of a revelation for me, saying, well, material has everything to do with context. It has to do with the climate. You can't use marble just because it looks good and just because you want it as a certain aesthetic. So we went with travertine. And travertine is extremely resilient, and it's very stable. And it had a unique effect, and it actually helped blend with the context even more. So this is just a small little anecdote from Dusseldorf. We designed a tile with Casa Grande Padana, and this tile has certain ecological attributes. It's considered self-cleaning. There are titanium particles in the mix, and apparently what that does is that when you use titanium particles, it actually helps expand when it's introduced to light, and if it does that, then the idea is that it actually releases some of the adhesives of all the soot and all the buildup, and when it rains, it helps wash it off. So there's some self-cleaning attributes to this product. It's an urban infill project within the confines of Berlin, Germany, and of course everything has to conform quite strictly. And believe it or not, this actually conforms to all the building regulations, all the setbacks and the heights and the datum lines. And yet the city authorities thought they couldn't really wrap their heads around why it looks so different if it conforms to all the standard sort of neoclassical buildings. As you can see, the geometry is quite complex, and the use of tile is also quite challenging for a project like this. You can see the window system here and how the tile system would actually have to wrap around and kind of conform to the window system. This is an image of the tile. This is the self-cleaning tile. These are some of the attributes that I'm sure all of you guys are familiar with, and some of you might even be skeptical of does this actually work or doesn't it, but it's the idea of it. And we do think that the maintenance has proven to be quite low, and it weathers quite nicely, and there seem to be some self-cleaning. So what do we do when it comes to a tile facade typically? I mean, the first thing that pops into our head and the first thing that we thought of is that it should be a rain screen, right? Especially because the facade is quite complex, the geometries are complex, and if that's the case, then what we want to do, especially in northern climates, European climates, we want to have the insulation on the outside of the building, right? We want to seal the building before it actually gets to the interiors. And so a rain screen facade is very ideal, which typically, as you all know, it means the facade is really a floating open joint tile system that is breathable, and all the weatherproofing and insulation is behind it, and it's on top of the structure, on top of, in this case, concrete structure. And so by the time you're in the interior environment, everything is basically shielded from the outside in. And there's a forgiving factor that the tile is on a bracket system, and the tile in the actual geometry of the structure, they don't have to be one-to-one. There's a tolerance built in a bracket system, where the tile and the bracket system can actually make up the difference between the built structure, which is typically not as precise as the finished structure, which is the tile. So a typical detail that you guys have seen, we've used, and everything is basically floating and attached to the weather barrier, to the insulation on bracket systems. Now, here are some of the results. This is completely open joint, breathable facade, and it's executed immaculately. And the reason I bring this up is because this is the first thing we thought of as the best way to apply this tile as an open joint system. And we were in an environment, in a field where the labor force is completely accustomed to doing this. Triple glazing, breathable facades, double skins, open joints. All of these things are basically second nature in Germany or in most of Northern European environments. So we were quite pleased with the results. The other thing that I should say is that an open joint facade where the skin is breathable and basically attached is also quite easy to maintain or also to replace, right? These aren't necessarily the driving factors of why we thought of this system or this very well-known system and how we applied the system in a very unusual way. I think that taking a very known product and a very known technique and challenging it in new ways is actually, for us, something that often inspires innovation. This is some of the interior courtyards. You can see here, this is nothing. It's basically just a plaster finish. And again, some of the results of the exterior. Which brings us to the same material, slightly different look to our project at the Fiera Milano, which is called City Life. This was part of a really large master plan that we were fortunate enough to win with Zaha Hadid and Arata Isozaki. This is quite a few years ago now. It's basically rebuilding the old Fiera grounds, which are still within the city center of Milan, the historic center. Very unusual to have such a large swath of sort of urban land dedicated to these very unusually large exhibition halls. So when this was given over and the Fiera was moved outside of the city, it became a very unique problem of how to patch and how to sort of restitch this fabric into the historic context. Long story short, we devised a plan where the central towers would be sort of the furthest away from the existing context, and then that we would sort of skirt the master plan with housing, and the housing had a lower scale, and we broke up the housing into smaller units so that it would be a nicer and more seamless transition with the context. And we accepted the new kind of business kind of model that these things have to be much more dense than the existing context. It has to sort of conform to open space planning and higher density and leaving more land for public use, light, air views. And then one of the things that we were challenged with is how to break up the scale of these rather large building blocks. So as architects, we don't necessarily make the business plan. We try to manage and try to become a mediator between the economic realities and sort of the gravity of the site, the neighborhoods, and urbanism. So we took these super blocks and we actually broke it down into these columns, and these columns then started to break down the scale of these super blocks into the scale of essentially the penthouses or the residential villas around the context. And that was quite a challenge in terms of like convincing the neighborhoods that in fact this is a contemporary kind of modern interpretation of the historic context. It's both a reference and rooted into history, but at the same time it's also forward-looking and trying to introduce something new, a new kind of life into the historic context. So as you can see here, you've got the sort of the villa pieces at the top of the building, and these strands kind of come down all the way down to the bottom. Initially, given that it was basically in parallel with the Düsseldorf project, or actually the Berlin project, we of course thought the best way to achieve this was, again, a rain screen system. And just from a kind of design perspective, one of the reasons why each column is so animated is that we wanted to create difference within the repetition of the development. So suddenly we have these massive projects going up all over the world, and each and every single one of them is actually talking about exclusivity and talking about how each unit is really unique in that you're part of a very high standard, unprecedented development. But then you realize you've got 400 units, and within those 400 units, there are like 6 typologies. And so what are you buying into? You're buying into 1 out of 80 very similar units. And how unique is that? So without necessarily challenging the economics of that, what we wanted to do is create a system where the building envelope itself, the performance envelope, is a complete extrusion on the inside. And then the outdoor spaces are totally unique and completely sculpted, so that every time, even if you're entering into unit, the A line, every time you enter a different unit on a different floor, it actually looks and feels unique. Is that facade innovation? No, it's a different kind of incentive, right? We're trying to create difference within repetition. And so this geometry is quite challenging. And should this have been kind of automated? Should this have been prefabricated in a factory environment to control it? No. It was done with very simple technology, and or actually, I should say, it was done with very simple techniques of poured-in-place concrete. But then the geometry was so challenging is that the contractors used GPS. And so it was a really interesting use of very old techniques and very new technology. So the GPS was used to kind of create points in space. The points in space were identified, and then they basically used string between those points in space to define the lines and to conform to the geometry. Now, aside from the fact that the geometry itself was challenging, how do we tile this? How do we actually clad this material? And of course, rain screen facade came to mind, and that seemed to be the most sophisticated. But then we really dug into what's available in northern Italy and what is the labor force really accustomed to using, and what are they most comfortable with. So it wasn't really just about the architects and the experts in the facade telling us, like, this is the most advanced and this is the most sound system that you could use. It was actually trying to understand the context of where this project is being built and who's building it, right? And so we immediately came to the realization that if you force a certain technology into an environment or a context that isn't accustomed to using it, that you might get less than desirable results. So do we go for the so-called most advanced, or do we go for something more rudimentary and challenge that in new ways? So we decided that we wouldn't use the rain screen facade because we would have to import a lot of labor, and that wasn't really conducive to making this economically viable. And we embraced the local culture and the local kind of know-how and basically used a wet system. And what that meant was that the geometry of the actual concrete had to be much more precise, right? So that, in fact, the concrete had to be as precise as the cladding, as the exterior cladding, because there wasn't much tolerance, as opposed to a rain screen with a bracket system where the bracket itself has quite a bit of tolerance that you can adjust to the tolerances of construction. In this case, the tolerances of construction actually had to be quite precise. But at the same time, we had the faith that the labor force actually has the know-how, and they are extremely good at form work and actually creating the structure, the actual base structure in a very accurate way. So as you can see here, this is all basically using new technology in terms of identifying points in space, but using old techniques in terms of basically a jump form, manually kind of constructed geometries. Again, what I was referring to before at the top, where these columns actually become villas and penthouses that reference the context. So aside from using basically a wet system that conforms to the actual base structure being concrete, one of the other things that we also did and we learned from our neighbors was the appropriateness of certain materials. We talk about material authenticity or the integrity of materials often, and the sort of tactile nature of natural materials. And we wanted to initially use a wood screen. And the wood screen is another layer that actually helps create kind of a shading system, but it also creates a kind of a privacy system within these sort of residential spaces. And one of the other things that we realized when we looked at some adjacent developments, that given that Milan is a valley and sort of there's so much that's coming off the Alps and so much that is just sort of settling within this large valley in Lombardia, that the pollution is quite high. And because the pollution is quite high, natural stones and natural materials, they don't weather quite well. Our colleagues decided to use natural wood, and within a couple years, this wood turned black, and it all had to be replaced. Unfortunately, it wasn't something that we could actually, they could have actually anticipated. They were using teak, and the idea was that if you use teak, it's quite maintainable because it's used on yachts and boats all over the world. But yachts are basically maintained on a daily or weekly basis, and buildings are not. So that was quite a lesson learned, and we decided to go against this idea of the so-called the integrity of the material, but really wanted something that would be highly resilient and and with very low maintenance, and we used a composite system, a fiber composite system for the wood screens. And they have maintained their look, they have maintained their performance for the last 10 plus years, and it hasn't had to be replaced or maintained. So another kind of small lesson for us in terms of the integrity of materials and the context itself. As you can see here, some of the benefits of building higher density is that you can actually create more open space, more distance between units, and more light, air, and views. Which brings me to the final project. This is not the final project as in the latest project that we've done, but it's kind of again, within the spirit of using very known technology and construction techniques in very new ways. So we were asked to do a pavilion at the Milan Expo in 2015. This was a project that was done very rapidly, very complex, extremely rapid, but then there's something really inspiring about having to achieve something in such a short amount of time, that you don't fetishize and you don't sort of dwell on how to refine the system itself. We wanted this pavilion to, it was for an Asian company that really wanted to have a great presence within Europe. We wanted to create something that really had a kind of a seamless juxtaposition and seamless kind of posture in its environment where the inside and the outside are really blurred. The space and the geometry itself is constantly changing. You can see from these sort of grand stairs that in fact it's the stair that runs right through the volume of the building and allows you to bypass the building itself and goes directly to the rooftop that actually has a view of the entire expo. We use the same tile as Casa Grande Padana, the tile that we had designed, which is self-cleaning, and we used that in Dusseldorf, actually at the Sapphire in Berlin. But of course, the geometries were quite challenging. It's right in front of the Italian pavilion and a very prominent location with the central kind of fountains, so it's quite visible on that main piazza. And it was inspired by sort of, the Chinese landscape, ever moving, ever changing, and layered. Some of the early sketches of the sort of poetic approach to the project. You can see some of the geometry studies about how the surface basically folds in, and it's almost like some kind of wormhole that goes right through the volume, bypassing the interiors, and really wraps around the geometry. So you're really engaging the building. You're actually engaging, not just going inside the building and looking at the facade, but you're actually on top of the building and walking right through the building envelope. Just some typical plans that shows you how this geometry is constantly changing and how there's like the stair that actually weaves through the spaces and around this geometry. And there's, basically two wrapping stairs, one from the exterior, one from the front, that kind of ends up all on the rooftop. And some of the interior spaces, you're bypassing this entirely, so it really becomes a publicly occupied structure. And this is that stair that goes right through and ends up on the top as an observation deck. So, really complex geometry, use of tile, quite well known. Bracket systems, also well known. A structure that only has a lifespan of 6 months, but is quite complex. So the best way we devised of actually defining the geometry was with a steel frame, basically a cage system. And then we would sort of clad that cage system with the whole weather barrier and insulation. And then we devised a cord system on top of the weather barrier. And that cord system would actually make up the difference of the complexity, and then receive the bracket, a new bracket system that would receive the tiles. I'm sure you guys are familiar with the concept. Here are some of the images, and you can see the steel structure itself has these extruded brackets that are there to receive the cords, and then the cords, given that they're rods, they actually have the movability in 4 directions. Some of the completed steelwork. And then you can see the actual cladding here, and then on top of the cladding, you can see these sort of tracing lines that are attached to the point system from the steel structure. The entire structure is now sealed, insulated, and then the entire cladding system is basically floating. And that floating effect is taking this idea of the rain screen breathable facade to a kind of new existence where it's literally like a feather. It's literally like scales on the building and completely floating. So quite complex, a lot of geometry and calculation, but then at the end of the day, the actual execution is all by hand, and it's kind of like it's something that we came across. We were building a tower. This is a total diversion. The central tower in Milan, it's supposed to be the most state-of-the-art, and it is the state-of-the-art building that's supposed to be. And the clients really wanted a BMU system, like they really wanted to invest in a crane, and because the crane was really an indication that this facade and this building is going to be really advanced and everything is automated and it's going to be maintained, and the client. But then we realized that in fact the crane, as advanced as it is basically extremely difficult and time-consuming to use. And we talked to some other consultants, experts, basically everyone. We talked to Schüco, Lisa, and other experts in the field, and most of them came back and said, well, the fastest and the cheapest and the most reliable way to clean this facade is actually using alpinists. We're like, alpinists? You mean just people on cables and tiebacks? Like, yes, that's actually the best way to do it. So we approached the client, look, we can save money, we can do this. It's like, yes, but we can't really sell and market this building as being state-of-the-art and tell them that we're using climbers to clean it. So if we can't do that, then we should just have the crane there anyway, just because it actually symbolizes advancement. It's not so clear. Yes, we do use the crane. It does work, but on a day-to-day basis, alpinists are much more, let's say, adapt to actually maintaining that building. This case, super high-end technology. Everything had to be calculated. Everything had to be kind of orchestrated. But at the end of the day, it really came down to the individuals using this very advanced system in a very manual way. So every single tile is basically laid out and composed by hand. We devised a plan where the rain screen system wasn't just about simple brackets, but the brackets themselves had to be quite high-tech and innovative. On the left, you can see these steel plates. The steel plates have these joints that allows each plate to move in 3 different axes. So those steel plates get attached to the rod system that is attached to the bracket system that goes all the way back to the actual steel structure. These steel plates then receive the finished tile, and each piece is allowed to actually move. and on 3 different axes, and which creates this kind of feathering system as part of the cladding. You can see some of the results. This all had to be erected and completed within 6 months. The organization was quite nervous about whether this was achievable. But one of the things that we've realized over time is that sometimes when you really challenge your team, you challenge the engineers, you challenge the materials, you challenge the labor force, people become really invested and really focused on trying to achieve something that actually hasn't been done quite the same way before. And so there's a kind of a focus and heightened awareness on these jobs where you can't be complacent just because you feel like you've done this 100 times. And so it's using known technology in new ways. And just on cue, this was the final result of the project. Thank you very much, and I hope I was able to give you more of a kind of a design perspective in the field, that somehow design and innovation or technology and intention, they don't necessarily need to be in conflict, that they can promote each other's advancement, and that sometimes it's really not just basically confronting known systems with gravity. And in our cases, the gravity has to do with context, it has to do with environment, and it has to do with the labor force and what's available. Thank you.
Thank you, Mr. Karim. Ladies and gentlemen, we will be now having a networking lunch break, so please help yourself out to the buffet. We would like to encourage you all, to visit the booths as well as network. Ladies and gentlemen, welcome back. We hope you have enjoyed your lunch. This is Facade Engineering Dubai, session 3. And I would like to welcome Mr. Jeff Brooks, Design Director from Dar Al-Handasah.
Thanks. Good afternoon, everybody. Are we able to put the PowerPoint up on the screen? Excuse my huskiness if I sound like a 70s folk singer. It's a sore throat, so I apologize in advance. So welcome, everyone, and welcome back from lunch. I'd like to give you a short explanation of a project that has been incredibly influenced by facade thinking. Our client is a very interesting one, but just firstly, quickly, just to tell you a little bit about who we are. I am the design director of Dar Al-Handasah, which is the founding member of Dar Group, which holds a number of sister companies underneath it. We are globally positioned, and in that instance, we are doing a lot of work currently at the moment with high-rise buildings in Africa. Now, in terms of the issues, the environmental issues that high-rise buildings face, of course, a lot of these are environmental. And how the building responds to that, of course, is directly linked to what we're all discussing here in terms of facade technology, etc. However, what I want to discuss a little is the inspiration behind the project and give you a kind of MTV, 4 images a second, flavor of the project, so you get a flavor of the place. So Ethiopia is where a number of our high-rise opportunities that are current are based, and we're looking at the city of Addis Ababa, which is a city in transformation, and a city that is got an emerging skyline, which is also a new landscape. We had a wonderful client, and from wonderful clients come wonderful buildings, and the opportunities of integrating, as a wish of the client, integrating the landscape into the actual high-rise building, this biophilia that we all so deeply wish to integrate, came actually from our client. Our client is one of the largest energy providers in Africa, and of course the natural landscape of waterfalls is right at the heart. The chairman said to me, can you please integrate something to do with the actual Grand Renaissance Dam? I said, of course, it would be an absolute pleasure. So one of the things that large opportunities have to offer is they have the opportunity to give back. Large buildings get the opportunity to give back to the urban environment. They get to give back to the street. They need to create a place for people to gather. And also, high-rise buildings have the opportunity to be social. They get the opportunity to leverage the way the lifting structures work, the VT works, and create community spaces in the sky, gardens in the sky. Our plot was incredibly interesting in terms of its opportunity next to Mexico Square, which is very famous, but I won't dwell on it. And the site is in a state of sort of like mid-excavation as we speak. So there were a couple of diagrammatic sort of issues here. One was to push the building back from the street, to create a square, to create a landscape for people to gather. There was a large commercial retail component to the ground floor podium, so of course creating a new square for Addis Ababa was critical. We decided to actually rationally divide the building into a series of packets of buildings that were organized around the MEP strategy, which basically served half up, half down, a standard idea, but integrating this with the VT structure allowed transfer levels to throw the terraced garden landscape of Ethiopia up and into the tower. So you have a landscape square, and that landscape square jumps into the tower. It's crowned at the top, sort of like with boardroom, but also giving back to all of its employees a shared facility for a restaurant and gathering. A podium space delivers all of the facilities that is not included within the actual tower itself. So here comes the crux. If the building is meant to actually have a holistic view, a passive view in regard to its relationship to the environment, then can we do something that is slightly set against the norm? Can we move away from a central core? It's got a problem in the morning and a problem in the afternoon with low sun and high glare and high sort of intensity heating, which has an effect on the MEP systems and of course therefore have an effect on its net to gross, etc. So in order to make a building passive, there's an opportunity to deal with those problems right at the heart of it, which is to cut the central core in half, move it to the external periphery of the building, and to actually deal with that low sun passively. And again, what that produces is a flexible, open plan space that allows for adaptability and future-proofing for the foreseeable future of the building. It also produces an open lobby, which has this opportunity to create permeability and openness within the actual square at ground floor. So diagrammatically, very, very simple. And some of the most simple solutions actually create the best results in my experience. So the lifting structure creates gardens and all the way to the top. So it's a very, very simple little diagram. And as the scheme is developed, we're now in detailed drawings. The packets of office facade are quite interesting in the terms that, excuse me, the building actually faces north and south in its long facades. So if I'm on this one, this is the south facade. Sorry, this is the south facade at the bottom that is louvered, and this is the north facade at the top, which is not louvered and completely open. And the east and west is dealt with by the actual cores. And the great thing is you actually sort of like get a sunrise and sunset experience as the lifts drop off and the cores turn back into commercial office net space. So sustainability and energy generation was right in the heart of the client's view. So we did building integrated PVs into a lot of the actual systems, lots of modularization, lots of standardization, lots of replication in order to drop the actual cost, increase the quality, the same old sort of like view of all of that. The southern facade was louvered in order to guide the views down to the city. And of course, at the top of the building, there was the opportunity with the client partnering with wind generation systems to produce this environmental crown at the top. So these are the social spaces. These are the places where people gather. That would be great. I do apologize. Thank you, sir. Cheers. Thank you very much. Cheers. So these are the social spaces that have an effect of not only producing a really beautiful place to meet, to remote work, to have touchdown space, informal meetings with colleagues, and lunch, etc., but it actually reduces the impact on the lifting systems. People don't leave the building actually at lunchtime. They inhabit it. So peak hour sort of like transfer was actually dropped. There's this incredible sort of like space at the top of the building with the actual boardroom, and we made a sort of like a balsa wood model, probably around about sort of 40 or 50 of them, but this was the final one. There was a long sort of like talk about the verticality and integrating the superstructure into the actual facade systems, and then that provided sort of like a modular organization for how the cassette systems would actually fit. But basically, the whole building is one panel. So how does this community exist, and how do we integrate the landscape within it? So these are the transfer floors, these are the double height garden spaces that introduce this landscape and organize it within a high-rise space that provides this wonderful, relaxing place to be. It also provides the opportunity to, in a way, levitate the MEP section and, in a way, decentralize it throughout the building. It provides very efficient use of riser space. So this is the actual building itself, and the opportunity of actually being within the sky, within these actual spaces. So they differ in terms of their qualities as they go up, and they're organized seasonally with planting, etc. And there was another opportunity. The client actually wished for spaces that didn't really require a lot of external windows. So they wanted a library space that was very much AV orientated, lots of blackout space, auditoria, and cinemas. So, of course, we had the opportunity of blank facades, and blank facades get the opportunity of producing a new sort of digital experience. I'll play this for you, but the client really wanted the ability to give back to the city, and he wanted the opportunity to deliver a sort of like an art component, a digital art component to the street. So I'm sure you're all maybe aware of this or not, but this is quite a famous piece in Seoul in Korea. And it is only limited by digital content. And it gives the opportunity for the street to engage in new ways. Normally you see these things on facades that are slightly dead. However, we wish to actually integrate it as a sort of digital gate, a digital entrance to the building, in a way emphasizing the fact that the client was very much a leader in understanding digital technology about how they interfaced with their clientele. So, this is a view of the podium and these digital facades that actually wrap around the actual structure and give you this digital gate into the actual building. So there's a security issue, and one of the main things about security is for it to disappear, and in a way for it to actually feel as if it's not there yet, provide the security for everyone. So this is the entrance and drop-off. And one of the key things about the board requiring this connection to the Grand Renaissance Dam is to provide connectivity. There's always a situation in large buildings that are inhabited by 5,500 to 6,000 people, is that you've got around about sort of like 3,500 to 4,000 cars. Now, when you're actually in basement number 5, there can sometimes be a tedious way of navigating to find your core to get to the lobby. So we thought that we'd actually use this symbol, this important power generation symbol of the Grand Renaissance Dam, to deliver a sort of 8-story waterfall from the top of the lobby, dropping all the way down to basement number 5. And this gives this amount of natural daylight that's streaming into the lobby, reflected off the water, and gives you this pitch that you actually know where you're going, you know where you're actually trying to get to. There's a wayfinding experience, which is also acoustic. So the square, it also animates the main square, and this provides all of the F&B and retail facilities that I'm providing here. This is a semi-section through the basement. It also provides retail car parking at level -1 and allows retail users to ascend up through a secondary waterfall up to the main square. All of this use of water is also built back into the systems. It allows sort of like evaporative cooling, so there's a control of the spaces environmentally to provide comfort. The main lobby is incredibly grand and very open, and that's actually been delivered by the passive approach to placing the cores in the east and the west and opening up the main center. So this grand experience of the waterfall is experienced in the main lobby, as you see here. So the square is not just at ground level, the square actually extends up to the roof, and the roofs in Addis Ababa are incredibly well used. And one of the key things here is to punctuate the sky in an incredibly simple way, in a very humble way, without overt gymnastics. The building sort of very elegantly sort of is punctuated by the gardens, which is referenced to the landscape, and is literally highlighted by the board room at top. Simple materials, repetition, order, prefabrication, in-factory control of quality delivered us a palette of materials appropriate to not only a vernacular that you find in Addis, but also a 21st century high-rise building for an energy provider. So a very, very simple building that right at its heart, right at its origin, is a passive and a holistic view of reducing energy. A building that generates energy around about sort of 18 to 19% of its overall use is generated by the building envelope itself. Not only that, but it integrates back into the street, delivers an environment that is within a changing and developing city, and delivers a new piece for the skyline of Addis Ababa. Thank you very much.
Facilitate networking, and but in the end we all know each other. So it's not networking, it's just meeting. And yeah, it's not as valuable as it.
خلص?
Can I start? Oh, sorry. So, hello, good afternoon. Thank you to the organization, and thank you to all of you for being here to attend my presentation. So I was here last year just to introduce our solutions in powder coatings for the architectural segment. And this year I want to be here again just to go a bit further and explain our sustainable solutions in powder coatings for the architectural segment. So giving a longer life to the coated metallic elements is, let's say, our goal. So we innovate with the purpose of having these sustainable solutions every day. So let me share with you the points that we are going to tackle. So as we are relatively new in this market in the Middle East, I just will introduce Axalta again. And then I will enter into the topic of this presentation, which is what does it mean, a sustainable solution in powder coatings? And then talk a bit about performance, which is really important, and just some examples of projects done with our product. So, yeah, as I said, Axalta is a global company, leader in powder coatings. In fact, we are the second powder coating supplier around the world. And as you can see, yeah, we have different manufacturing sites, and we are backed by more than 150 years of experience. Before, our name was DuPont, so maybe it's more known by some of you. But yeah, we are the same people, the same experience, the same innovation company, but just with a different name, Axalta now. So as I said, yeah, we are serving the architectural market, yeah, and we have solutions for all type of buildings, from residential, apartments, and until iconic buildings, schools, hospitals. So every type of buildings are covered by our offer. So why or how we serve construction? 3 main pillars. So we have an extensive product portfolio, high quality, high performance. Service is really important for us. So we know that for the projects, you need samples, you need small quantities of products to do the mock-up. So we are here to serve you. So we provide the right service to fulfill your needs. We are, let's say, service is our main way to approach you to solve your needs. And then finally, we are a global company, as I said, which is good. More and more, we are global, so we can support you, we can help you in around the globe. So having projects here in China, Europe, US, so everywhere, as I said. So let's enter already in the topic of the presentation. So powder coatings and sustainability. Axalta is a sustainable company because one of the things is that we are, let's say, certified by EcoVadis. EcoVadis is one of the world's most trusted business sustainability rating company. So we have a silver rating from this company. That means that we are, let's say, obviously we have our objective for 2030 according to operations, to reduction of energy, people, governance, so everything. But on top of this, we are focused on the sustainability of our products. So I'm here to, let's say, to highlight, to introduce our Alesta SD. Alesta is our brand, Axalta is the company. So Alesta Super Durable SD is what we propose as our sustainable solution. Why we say our super durable range SD, Alesta SD, is sustainable? First of all, because we give, as I said at the beginning, a longer life to the metallic coated elements. But on top of this, yeah, you know, there are no solvents compared to liquid coatings. This is one important point. And second to that, yeah, in our case, our range of products doesn't contain any heavy metal, as you can see here, doesn't contain substances of very high concern. At the end, our products, our Alesta SD range, is not having any label related to hazard, related to the environmental or related to the health, which is really free of pictograms. I mean, this is really important today because not only for the environment, but also for the people manipulating these products. On top of this, the product is relatively low cure. That means that applicators can reduce the consumption of energy when they are using our products. In terms of sustainability, we have an environmental product declaration, type 3. What does it mean, type 3? Type 3 means that this environmental product declaration has been certified by a third party. So, and this is impacting on the number of points that using Alesta SD you can have in your LEED projects, LEED certifications. So let me talk a bit about LEED. Everyone here in the different projects you have mentioned LEED, that you are using LEED. LEED is one of the most used, let's say, environmental certifications. So I'm not going to enter here to describe what is LEED. What is important for us is to explain to you how the use of our Alesta SD range can contribute in the certification process according to LEED. So, as you probably know, so when you are certifying a project in terms of or related to LEED, there are different rating systems that you can see here, depending on the type of project you have and with this, or within these different rating systems, there are 6 main categories that need to be considered. So sustainable sites, water efficiency, energy consumption, material and resources, indoor environmental quality, and innovation in operation. The important part here is to understand why I'm putting this here, because what I want to explain is in which of these categories and related to the corresponding rating system, our AESG can contribute giving points. So if we go a bit further, after analyzing, we have been working with an external consultant to understand, to analyze how our powder coatings related to the formulation, the operation, the production process, the application related to everything, how our AESG range can contribute as a sustainable product to obtain points in a LEED certification. Related to coatings, if we enter into these rating systems, so the categories that can be impacted, or when the powder coatings can contribute, coatings in general, can contribute the 4 categories you see here. So from the 6 categories considered in LEED, only 4 are related, let's say, to coatings: sustainable sites, indoor air quality, material and resources, and innovation and design. If we enter into here, it's really interesting to see how our powder coatings, our AESG range, can contribute on getting points. So here what you have is a table based on the different rating systems, and also including, in our case, in our AESG range, we can contribute, we can impact in 2 main categories: indoor air quality and material and resources. It's really important to see that using powder coatings in your projects, in the subcategory of low-emitting materials, you can get up to 3 points, just due to the fact that the powder coatings are free of VOC, so no volatile organic compounds emissions. So this can contribute, this can let's say, add to your project up to 3 points over 3. So related to, we have all is explained. We can enter into the details. If you need information, please contact us. We are here outside, so I'm not going to enter in all the categories, but for instance, in materials and resources, due to the fact that we have a type 3 environmental product declaration, we can contribute to get 1 point over 2. You know that in the category of EPDs, you need 20 products compliant, and then you get 1 point. Our type 3 certification is giving 1 point, or is considered as 1.5 products. So it's really contributing high. So what is really important here is that, for instance, if we take one project, one school, that you analyze or you rate according to the building and construction rating system, if you see the impact on the different categories, you can get up to 8 points, which is an important value, taking into account that for a platinum LEED certification, it's from 80 points you get a platinum certification. 8 over 80, it's a 10%, which is an important amount of points, or an important contribution from our powder coatings super durable range. So this was, as I said, an important topic. I think it's important to understand that how our product can contribute to this type of certifications, how sustainable our product is. And then let's review just the performance of our AESG. So our offer in terms of architectural, we have 3 main lines of products. So class 1, according to AAMA 2603, Class 2, the one that I've been explaining to you in terms of sustainability. So it's according as well as with AAMA 2604. And finally, the ultra-durable powder coatings according to AAMA 2605. This is our offer, but as I said, we are focused on our AESG range, super durable powder coatings. So yeah, it's not necessary to enter again. What is important here is that there are a couple of things to highlight. The first one is that our range of powder coatings, of our super durable powder coatings, is baked with a strong warranty. This is really important because our warranty is up to 25 years. You need to understand the process here because it's really, really important and mandatory to get the warranty to work with an approved applicator, with an Axalta approved applicator. But then, yeah, why we say, or why I said that this is a strong warranty? Because we are warranting not only the color and the gloss, but also the cracking and the chalking in the building itself. So the degradation of the color, gloss, chalking, and cracking. And on top of this, we guarantee the compliance of the product with the specifications in the technical data sheet. So, and another important point is that there is no reduction on the liability. So this is really important as well. So this is what we offer together with our AESG range of products. So this is one point that I wanted to highlight. And the second point that I want to highlight, because I think it's really important in terms of quality, is the improved scratch resistance. So why we have done this, or we have analyzed this, because, yeah, you know that when you are manipulating, applying profiles, manipulating coated pieces, at the end, yeah, there are some problems, some defects due to the fact of the different scratch. So here we have improved the scratch resistance of our range. So if you compare, this is you see the specifications according to Quali-Code. So in our case, our range of super durable powder coatings is more than double in terms of scratch resistance. This is good because it's reducing the number of, let's say, defects that you can have during the installation, during the application, and reducing the touch-ups. Just want to mention that we can provide you with the fire-resistant certification, not only done by the European laboratories, but also done here by the Emirates Safety Laboratories in terms of retouch. Unfortunately, we know that there are some scratch, some problems that may happen in the elements once coated and installed. So we can provide a liquid solution for repairs. This is from our range Percotop. So it's also important to mention because sometimes this is also a problem that we are here to help you to solve. Sealant adhesion testing, we can also provide the documents you need because this is also an important part related to the adhesion to the glass. And then finally, just wanted to mention performance in terms of corrosion. So as we have been seeing here today, yeah, we see aluminum elements, but we also see steel elements in buildings. So in steel, we need to be very careful in terms of corrosion. So just you know that when you analyze the corrosion protection you need to understand the type of environment that this building or project will be affected by. Then you need to analyze the metallic substrate. There are different types of steel. And obviously, yeah, you need to find the right system, not only the right coating, the right system. So we have two solutions here for anti-corrosion. So one is thermoplastic. The brand names are Upside and Blastcoat. And we also have primers in thermosetting technology. So just wanted to show you, obviously we are not going to enter into the details here because it's a very extensive table. But what I want to mention, or the intention to show this table here, is that every time that you have a project, please consider the different things that I said. So first of all, the corrosion category you have. So see if you need C4, C5, then the type of substrate you have, and then if you want a medium durability, high durability, or very high. Depending on this combination, we are proposing different, we are proposing different solutions, okay? So this is the combination of the atmosphere or the environment, the type of substrate you have, and then all this range of solution, depending on the durability that you need in your system. I'm inviting you to visit us in our stand here outside because we can give more details. And in terms of finishes, because I've explained or I've tried to enter into the sustainability related to lead, I've forgotten to say that we can provide all the documents you may need to justify these points in LEED certifications. I've just explained the performance. All the documents that you may need are also at your disposition. Just contact us. And then finally the finishes. So we have just launched a couple of collections. The most recent one is Iconica, which is a range of super durable powder coatings. And I invite you as well to have a look on this collection, and as well as the supranodic one, anodic finishes in powder coatings, which is a real trend in the market. So having said this, just the track record. So some projects that we have to show to you where our powder coatings has been used. This is a classic, so the project done here in Dubai with the Crown Plaza Hotel. This is from 2006. This is good to see because the performance is there. So I always like to show references not done yesterday, but done many years ago, because then you can see the real performance of our products. This is Kuala Lumpur in Malaysia, a tower, the highest tower there. This is an example in Melbourne, all the time within our SD range. This is very recent. This is done in Belgium with one of the products that included in this new Iconica collection. One example of one project in China with a metallic SD as well. This one in France, so we have many references. So in Amsterdam with different black and whites, in UK, so yeah. I'm sorry because I'm running out of the time. So just visit us, any questions, any technical support you need, any service, let us know. So we are here to serve you. Thank you so much again.
Thank you. Yes, the powder coatings, they are very important in keeping the facade vibrant for long years, and getting them specified properly is something that we should do, and also regarding the fire and regarding the sustainable part of the business. For our next speaker, please put your hands together to Mr. Dorian Bumble, Head of Specification, Gulf Countries from Saint-Gobain.
Hello, everybody. Thank you for the introduction. So today I will speak to you about lightweight facade. We mentioned that sustainability is a big topic, and I will show you quickly how Saint-Gobain is addressing this market requirement. I decided to show you a CPD certified presentation, so don't expect a lot of marketing names and details, but we will focus on the technique. We will focus on the performance, and hopefully you will like it. After the presentation, you can visit us outside, and if you require the certificate to get the credits, we will give it to you. Just quickly, Saint-Gobain is a very old company. We started with glass, acquired gypsum activities, insulation, mortars. Here in the country, we have 15 companies, and the whole goal of Saint-Gobain is to develop sustainable and lightweight construction systems and materials. So why the facade is important? You know that actually very well. So I will just show you different way of addressing facade. You can have solid facade, you can have lightweight facade, different type of finishes. So it's very complex actually for a manufacturer like us. We trying to be everywhere, it's a bit of a challenge. But as Saeed mentioned this morning, it's super important to address facade, because facade will help to reduce the to reduce the consumption of the building, but if you don't address lightweight solution, it won't reduce the embodied carbon. So you have to address this topic because of the trend we already discussed this morning. I will go fast on that. Also, a facade is meant to last. You cannot change the facade every other years. Actually, right now in Dubai, we have a lot of refurbishment and deep retrofitting for the facade, for buildings that are less than 10 years old. It's nonsense to me. When you design a facade, it's supposed to last at least 20 years. When you select a system should follow specific standards and should be tested to many factors. What we do usually, right now with retrofitting, we will do EIFS system. It's a very, very efficient way to thermally insulate the building. But this is not fixing the problem with embodied carbon, because you always have a masonry background. Masonry background means concrete, means cement, means a lot of CO2. So what we're doing lightweight system. Basically, it's very simple. You have a head channel, a base channel, studs, boards each side, and insulation for thermal purpose and acoustic also. This is the typical drywall system. If you want more performance, double frame, double board, insulation. But there is something you cannot do with that. Is if you use traditional gypsum board outdoor, it's not designed to go outside, right? So you need specific product. You need what we call a sheeting board. And this market has gypsum-based sheeting board with low embodied carbon. So you can address the lightweight requirement, and you could also address a low embodied carbon product. And these products are EPD verified. So you have the environmental product declaration for the whole life cycle of the product. I can tell you how much CO2 we are emitting for 1 square meter of this product. Then Saint-Gobain will have different companies, different components, but together you have a system. And the whole goal on this industry is to provide a full system, 1 warranty, 1 performance. You have to test those systems. So we will talk about the performance of the system. But basically, this is what we have. Normal gypsum board internally, SFS studs, insulation in the cavity, can be glass wool, it can be stone wool. You have the gypsum-based sheeting board externally, and your render system. It doesn't have to be the render system, by the way. If you want the GRC panels, if you want ACP panels, it's possible. The system will be a little bit different. But this is something you can have full system by 1 manufacturer. If you want more thermal performance, you just put EIFS on top of the board. I will show you the performance of those systems. The picture, top right, is actually the Egyptian pavilion in Expo 2020. It's a project where we had lightweight facade, plus cementitious render, ACP panels, and GRC panels. So it's very polyvalent. You can do whatever you want with that system. You have this flexibility in the design. And thermal performance, it's a very nice system. I will show you why. I will switch this. You are a whole expert in U-value calculation. So hopefully you are not forgetting about the thermal bridges. Yeah, they are everywhere in Dubai. Even if they're supposed to be insulated or removed from the project, you still have a lot of projects where there is thermal bridges. And that's a big problem, because between the U-value calculation you can get from municipality tools, for instance, I won't mention which one, but this is not including the thermal bridges. So the client is paying for a system, is expecting a performance, and when you include the thermal bridge of the joints, of the slab, of the columns, then the actual performance is dropping. So it's nonsense. Only the EIFS system is helping because you are, again, encapsulating the system. So you have the lightweight system. If you go with the direct render application, in a little bit more than 20 centimeters, you can go as low as 0.23 for the U-value. It's not bad. But nowadays, we're working on projects that they are going even further. We can reach 0.1, 39 centimeter, 0.1, in a system that is less than 90 kg per square meter. How good is that? Actually, we use that system on the right side in our new office in Masdar City. We're achieving 0.17 watt per square meter Kelvin, and the total thickness is 25 centimeter. And the weight is something like 74, 75 kg. Now, if it's installed between the slab, you might have an issue with the thermal bridge on the slab edge. So the manufacturer has to provide you with all the set of typical details to deal with those thermal bridge. So this is what we do. We give the CAD files, we give the BIM families for the system, including all the parameters, all the details, up to LOD 400. Fire. Well, you also, I hope, all experts in fire, so I won't spend too much time on fire reaction, passive and passive fire protection. It is important because you save people, you also protect the building, and you could also minimize the insurance cost, especially when you go with non-combustible solutions. Ask the insurance companies. They know about it. And gypsum is very good because in the gypsum itself, you have water. And when the gypsum board is in contact with fire, the gypsum board will release some of this water in the air as moisture. And it will cool down the surface, which means that you will save 60 minutes, 120 minutes, 180 minutes sometime with the right system. In 1 square meter of a typical partition, you have actually 5 liters of water. It's just there. It's in the gypsum. So a lightweight system can achieve great performances in terms of fire insulation. With ASTM E119, you will achieve 60 minutes if, and only if, you have stone mineral wool in the cavity and a 15 mm type X board internally. And if you want 120 minutes, it's not very difficult. You just add 1 layer of type X board. And actually, in the code, they're not even asking for fire ratings, they just ask for fire propagation. But as a manufacturer, we decided to go with non-combustible material. So it's actually easy to pass the NFPA test. So you have all the civil defense, Abu Dhabi, Dubai, everywhere in GCC. Acoustic-wise, it's also a big deal. I'm from Europe. I'm from France, obviously. Maybe you heard my accent. And when I moved to Dubai, one of my main problems was acoustics. Well, it's very noisy. This city is very noisy, right? You move in an apartment, it's a nice apartment, and then you cannot sleep, you're tired, you're not in a good mood. So with Façade, you have to deal with external noise. And that's a big problem. For me, I always have my dB meters on my phone. Everywhere I'm measuring the sound level. But what is noisy? Noisy is about 85 dBA. And the problem is your brain never rests. Even when you sleep, your brain is still listening. And it can put you in a bad mood. If you're in a hospital, you need more painkiller. If you're in a school, your heart level is going up, so it's affecting the teaching and learning experience. And this is super important to specify the exact dB you want. Because more than 1 dB difference, you will hear a difference, really. And 5 dB, so I don't want to see any value engineering where people are dropping the acoustic performance, because at 5 dB, it's a big deal. And 10 dB, you drop the performance by half. So lightweight system, unlike blocks, it's a little bit more difficult to determine the acoustic performance. And there is no softwares out there that will give you an accurate performance. We've done a lot of tests in laboratories, and just if you reduce the screws centers, you might lose 1 or 2 dB. But overall, lightweight systems are better than masonry wall, especially for high performances. So what you have to do with lightweight systems, you have to test them. And as a specifier, as a building owner, you have to request the data. You have to see the data by yourself. And anyway, when you compare the two solutions, let's say 47 dB RW A drywall system will be thinner, usually 50% thinner than masonry wall, but also lighter, 90%. And this is the other good point about lightweight construction. You will reduce the dead load. You will rethink the structural design. You will save on concrete. You will save on CO2. And the acoustic is really good also. For this system that we had installed in our Mazda office, it's achieving RW 70 dB. It's the kind of performance you have in a Vox cinema. Now the structural performance. This is probably the most complicated, and this is why in our company we decided to have in-house structural engineer, because we have a full system. We have to provide, it's our liability, we have to provide a structural calculation. We're using steel, it's nice, 100% recyclable. Zinc coating, super important. You need to have Z100 275 to avoid corrosion. And the good thing is it can be installed in any structural building. It can be a concrete structure, it can be steel structure, timber, also in some CLT timber in some countries. Even if you have a bamboo project, I can have a lightweight solution for the facade. It can be infill between two slabs, or it can be a curtain wall assembly. You decide. Sometimes you really need concrete, let's say for an elevator shaft, but you also really need to insulate that system. So instead of having EIFS going all the way up, you could also have external wall lining, where you will have the board and a low density insulation. And this will help you to have a very neat finish without joint, because again, gypsum board, they don't expand. And you can trick the system. You can use these technologies for your advantage. You can use it for fascia detail, for canopies. I don't want to see any more canopies made of reinforced concrete in Dubai. This is nonsense. Just do steel frame and clad it with the gypsum board. Done. It's actually 3 times cheaper than GRC. And nobody knows why. Only the main contractor knows. You can use it for balcony partition. Why? You don't need acoustic on a balcony partition. You don't even need thermal performance. You just need fire, eventually, and this will help you to simplify all the structural design of the balcony. And you can do crazy shapes. You can do, like in Expo 2020, this is the Irish Pavilion, an inclined cone. Because we have the structural engineer in-house, we can really do bespoke systems. Some very important parameters. You have to mention what is the dead load of the system. You have to tell us if there is any live load to consider. Of course, there is the wind pressure. Usually in Dubai, everybody is telling me 45 meters per second. Nobody has any idea. So you have to give us the real wind pressure, positive or negative. And best is to give us the wind tunnel report. Now the height, of course, it's important. The width, also, the footprint of the system is important for the design of the system. And this is where you can have very cost-efficient system. You will design the limited deflection criteria, how stiff you want the system to be, will actually be related to the cost. In the International Building Code, they ask for L over 360. But in Dubai, it's okay to make L over 240. Then we will provide all the steel frame assembly design, any panel design for doors opening. So remember, this is the factors that you need to ask the manufacturers. Now, if you compare quickly with a traditional system, Profire, same, I'm almost done. Impact resistance, severe duty rating, that's the maximum achievement. Acoustic is better, thermal insulation is better also. And in terms of installation, almost no water on site. 80% faster, 90% lighter. And this is an example of a project in Abu Dhabi, a school. This is so light that we actually increased by 50% the capacity of the school just by building an additional floor on top of the existing structure. This is super sustainable because you don't build a new building. You use the existing real estate and you improve the value of your real estate. And today you cannot notice the difference. LEED, I won't go through the detail. We can ask me outside how many credits, but it's a lot. And we actually got an award for the system. with the Emirates Green Building Council. It has been awarded the best green building material in 2020, I think, yes. Thank you for your attention. If you want your certificate, follow me outside, and yeah, have a good event. Bye-bye.
Thank you, Dorian. Thank you. Okay, guys, next is our presenter number 12 from A. Proctor Group, Head of Business Development, Head of Business Management, Mr. Will Jones. Thank you.
Thank you. Thank you, everybody, for staying around for this. Hopefully it's going to be worth your while. It's not going to be a sales pitch. We're going to look at condensation issues, risks, and air tightness, and how we hopefully solve these problems, understand why these problems occur. So, as mentioned, my name is Will Jones. I work for the A. Proctor Group. Excellent. And we are a supplier, manufacturer of construction membranes, insulation products, a whole host of range of membranes that can help with air tightness, ground gas for groundworks to stop any nasties coming up from the ground, pitch roofing membranes, air open, air closed membranes, vapor permeable membranes, also known as breathable membranes. So quite a whole host of them. We'll focus today just on walling. So, what are the problems? If we don't specify our products and install them in the correct locations, we can end up with some issues. So if we first look at condensation risks, obviously we don't want interstitial condensation to occur in a wall build-up. If that happens, that can obviously affect the materials within that wall. It can not only harm the materials, it can also make them defective. If an insulation product, for instance, was allowed to get wet, we could start to lose the performance of that insulation. So we want to prevent that from happening. We could also affect, further on down the line, the occupancy. We saw earlier in the presentation that potentially the likes of respiratory problems can occur if there's moisture in buildings that are allowed to sort of turn into mold. So we've got to prevent that as well. So membranes are a little bit more than just making sure we prevent condensation occurring. It has a lot more effect than potentially at first thoughts. So what we do is we break the building down into 3 major sectors. And we look at a holistic approach as to how we understand what products we're going to need and where. So if we take this ring here, we start off with the buildings, the building materials that are being used. If I take 2 examples on a high-rise facade, for instance, you could be using concrete, you could be using SFS, lightweight SFS. You could be using both on the same building. They harbor moisture totally differently. The concrete's going to have a much higher moisture load. And SFS obviously will not have that higher moisture load, and that's going to affect the hygrothermal performance of that wall. We then look at the likes of weather. Obviously, we can't control the weather, but it's going to still have a massive impact on the building. Not just, obviously, the external weather conditions that are going to be exposed to that building whilst it's being constructed, but also for the lifetime of the building. So we need to make sure we take that into account as well. And then finally, the occupants. What's the building being used for? Is it going to be a block of apartments? Is it going to be a leisure centre? Is it going to be a hospital, a school? They're all going to have different levels of occupancy at different times. And human beings give quite often a lot of moisture, to be fair. And so that also needs to be taken into account. Once we understand those sort of 3 key factors, we then move on to what at the A. Proctor Group we like to call our HAM principles. So that's our heat, air, and moisture management. So obviously heat, as it sounds, we're looking at the thermal performance of a building, the insulations that are being used, the level of the insulation, the how low the U values are. In the air, we're looking obviously at air tightness. And the issues that we're going to have with air tightness if we don't get this right, obviously if we have a leaky building, we lose the control of that element. And that's obviously really going to be harmful to our thermal performance of the building and our energy performance of the building. Then we have moisture. So obviously when we're looking at moisture, we have risks of moisture building up within the wall itself. And we need to make sure that we actually take into account how we control that. So not only from an ingress point of view, from the water coming from outside to into the building or into the element of the building, but egress. So how we actually safely make sure that any moisture build up within a building is going to safely be ventilated out of that building. So looking at quite a traditional build-up that we'd find here in Dubai, in the UAE, we have, for me, a reverse vapor drive. We're going to have a much warmer climate outside of the building and a much cooler climate inside. Again, it's extremely important that we understand back to our building location, because this can have a massive effect on where we put product within the wall build-up. So we have, in this instance, our external facade, our cladding zone, our insulation on the outside of the structure, sheathing board, SFS in this instance, an internal sheathing board, and then maybe some sort of framing system before we have our internal finishes, our plasterboard. Now, we have, in this instance, two main types of membrane that I want to consider. The first being an AVCL, an air vapor control layer. These are always going to be airtight. They're also vapor tight. They're not going to allow moisture to pass through, as long as they're homogeneous and they've been installed correctly, which of course is another issue which we'll come on to shortly. So they're going to limit moisture ingress into the structure. They're going to limit air leakage, but they should always be reinforced and durable, and they should always be installed correctly. We then have vapor-permeable membranes, also known as breathable membranes. So these can be airtight and air open. How's that possible? How can you have a breathable, airtight membrane? Again, when we talk about breathability, we're talking about the ability of vapor, moisture being able to pass through an object as vapor. It can be airtight and still allow moisture to pass through in the form of vapor. They're moisture neutral, so their location isn't as important as a VCL, and I'll explain why. If we introduce a VCL into the construction in the wrong position, we could essentially trap moisture. So that's why it's really important we understand exactly all those elements I spoke about earlier about the building, its orientation, its location, understand the occupancy levels, and also understand what that wall's being made out of, where the insulation is going to be installed, how thick that insulation is. I see it quite common to have a vapor control layer in between two layers of insulation, which goes against everything I've ever learnt in construction. We need to make sure we understand exactly the thermal performance of those insulation levels to understand exactly what type of material we can use and where we can install our vapor control layer. With a vapor permeable, breathable membrane, this is less important because we've got moisture neutral. It's not going to trap moisture. However, if we install it in the wrong place, it's probably not going to do its function. So it is equally important that we understand where these should be put. The likes of airtightness, we need to again make sure that we've got a simplified installation method. So there's fully adhered membranes on the market. They're very, very good at kind of helping the installation, making sure we get a continuous line with this membrane. People don't understand membranes. That's how I see it. When I talk to people about membranes, they're like, a membrane's just a membrane, isn't it? What's the difference? If we refer to BS 5250, and this is referenced in the Dubai Code E.7.4.1 regarding interstitial condensation, this gives us quite a clear guidance of how to manage moisture. Now, obviously, as I mentioned earlier, build-ups are going to be different. They are going to differ from a British standard to they are out here in Dubai because of, obviously, the climate. However, it gives us a really good, clear understanding of assessment methods and also standard definitions for membranes. A membrane is not like a piece of insulation. You don't have a thermal conductivity, which gives you a resistance, which obviously end up giving you a U value at the end. There's a whole host of membranes out there, and it's a bit of a minefield. And understanding which definition or which category a membrane falls into is also very important. Because sometimes people do use vapor control layers as breathable membranes, and that can be seriously damaging. So we kind of understand how to hopefully collate and understand obviously the most important parts of the building to make sure we're going to specify the right products. How do we go about and measure this? So again, we're looking at a condensation risk analysis. We take that a step further and we look at a dynamic numerical simulation, which is what you're seeing here. So this is hydrothermal assessment of a building. It's much more detailed than a condensation risk analysis that you might be familiar with, such as the Glaser method. We're not looking at steady state, month by month, average temperature and moisture levels and humidity. We're looking at an hour by hour. We also have real live weather data, which can go back 5 years of the exact location. So it actually has some sort of clout behind it and some real data that can actually be sort of used in more detail. And we can also look at every single individual element or piece of material within that build-up as well. So it might be a bit difficult here to sort of see what you're looking at, but this is an example where we're just looking at if we are theoretically going to look at a building such as Dubai International Airport. We have on the left-hand side our cladding. We then have a cladding cavity, a foil-faced piece of insulation, and then we have potentially a vapor control layer, a sheathing board, our SFS frame, another sheathing board, and then obviously our frame before our internal plasterboard finish. And what we can do here, which is quite unique, is we can introduce errors in the calculation. We can remove the VCL and see what might happen, because we all know that when we install membranes on sites, we can only theoretically say how well they're going to perform. This is how it would perform if you installed it absolutely bang on. No gaps, no damage, no unsealed laps, and that's always a risk. So in this instance, we can start removing products. We can introduce a leak. They happen. They're not ideal, but they happen. So then we can understand how quickly that building would, or that element, would harbour that moisture or would allow that moisture to alleviate out the structure. What if the facade became compromised for a period of time? We can then introduce a compromised facade and understand what would happen to that build-up over a period of time after we fix the facade, how long it would take for that moisture to sort of dissipate out from the structure. So, as I mentioned, we can get a whole host of graphs for every single piece of building material within that envelope and understand exactly what's happening at each exact point. Now, we're going to have a quick look at a real live example. And I can't stress enough how, and I know this has kind of probably been a bit of a repetitive point here today in some of the presentations, especially that I've listened to. As designed, as built on site is so important. And trying to reduce that performance gap is one of the most challenging things I think we face today when we're building. We can design a building as high performing as we want to. Actually delivering that on site is where sometimes, or where a lot of the time, we fall down. So this is, the world's first passive house leisure centre. This is St Sidwell's Point in Exeter. And what was really important is obviously to achieve passive house standard here, we needed to make sure we understood everything about this building at the earliest stage possible. So at design stage, we were invited in to have the discussions, how are we going to achieve our air tightness? The air tightness they were designing was 0.6. They aimed for 0.4 as a target. They got 0.36 in the end. Again, it was all down to communication, understanding what everybody's job was. How we understand, not just how we design it, how we build it, who's installing it. Do they understand what the products do? So with the hydrothermal analysis, we were able to sort of demonstrate how well that element was going to perform. And obviously, in certain areas of this building, it was going to be under quite a high level of moisture load. We had a swimming pool, we had gymnasium, and also we're going to have quite high levels of occupancy. And as I said, the most important thing was making sure that the people who were actually using the product at the end, at the installation, understood what they were using, why they were using it, and what it was there to do. So they went to the stage of building up model rigs so they could get early test data not only on air tightness, but also on installation, making sure they understood how to detail, because again, detailing is so important when you're looking at using an airtight membrane such as Wraptight. And you can see that the level of detail that went into sort of upskilling the workforce was sort of replicated and shown on the install itself. We have tape joints on the sheathing board. We have taped up fixing heads, making sure there's absolutely no air leakage. They also introduced a wind membrane. Now, this again is a bit of a phenomenon, wind washing, where we have our insulation behind our facade. And again, it's down to detail. No matter how good you are at installing an insulation board, we're going to end up with gaps. It's inevitable. And if we allow a ventilated facade to sort of allow ventilation or air movement around that insulation, we're going to end up with the risk of knocking out some of the performance of that insulation. So introducing a wind membrane in here made sure that we prevented that from happening. You get the idea with the pictures. I won't harp on about that. But yeah, the most important thing for us was we were sort of brought in at an early stage of the design. We understood exactly what we were trying to achieve with the main contractor. We're always going to work with contractors, consultants, architects, make sure that we get an early hydrothermal assessment, a dynamic numerical simulation done at an early stage so we know exactly what it is that we've got to specify and where. And that's it from me. If anybody wants to come and have a chat with us, we're out by the revolving doors. Be more than happy to hopefully help you with anything you need project-wise. Thank you very much for your time.
Thank you, Will. Thank you. Yeah, so Will's presentation is pretty insightful. Again, he's talking about hydrothermal performance. It's a term used by some people. I'm not sure if all people understand what hydrothermal means. Hydrothermal means, the relationship between the humidity through the skin, through the facade, as well as the heat transfer potential, and understanding how the membranes work, the vapor barrier and the vapor control and the waterproofing, and where to place them in the facade at different climates. For example, if you're talking about European climate, it's very, very much different than having it in a Dubai climate. So yeah, thank you for the insightful presentation again, Will. Our next speaker is Mrs. Agnes Colte, the director of Colte Façades. So please, a round of applause.
Hello. Yeah, hi. Thank you very much. It's always a pleasure to be on Zak conferences. I'm very much keen on this event, and I'm especially happy when it's in Dubai, because in Dubai I don't need to always speak about technical topics. It will be a bit of mix. My thoughts of what's happening currently in the industry, not only in facades industry, but more in architecture and in future of facade. I have quite a bit of echo. Hello? Okay, so normally I would start this presentation Which one? No, I have all of them. Yeah, but it doesn't work. No? Oh, shit, yeah. Okay. Normally I would start this presentation everywhere else by introducing ourselves. Here I'm in the very lucky position that I don't need to do that in detail. The company has been 12 years now here in Dubai, and we did many, many interesting projects. During the COVID period, we also had the advantage of investigating how to work remotely, and that gave an opportunity to work even more worldwide and meet with interesting architects, interesting projects worldwide. I would tell you what we do, and I would tell you that it's very specific on facade engineering, but then the question does what really a specialist is. And by definition, it's someone who has a lot of knowledge on a topic, on a relevant topic. But then let's look at what happened in another field, in the medicine. We used to have a GP when I was little, and I'm still 32 years old, but when I was little, we had a doctor who came to the home and dealt with people there, and he had enough knowledge to make decisions without a hospital background on my health, my sister's health, and advise accordingly. Same for my elderly grandparents. We don't really have a GP anymore, or if we have a GP, he will send you to a specialist. We have, like I just listed 25 different specialists here, and currently I have a pain in my leg that I have seen at least 10 different specialists. The last one was a hematologist who sent me to a gastroenterologist, and I really don't think that my leg has a pain because of my stomach. But this is what happened. And if we think that it's not happening in our industry, maybe we are wrong. I think architecture kind of lost its overall overseeing and overall omnipotent kind of nature, and it went extremely fragmented into many specialists, many engineering fields. And now we have BIM, which is the tool to accommodate coordination and to speed everything else, or everything up. At least this is what developers' clients are thinking, that, okay, it's in the model, everything is just coming from the computer. And then we are inputting that data, all the different disciplines, and it should come together over there. It could be a problem, and times are changing very fast, and you have probably also experienced that it's like speeding up. With all the new AI tools which just came up in the past 3 months, 4 months, I feel that the change and the reliance on softwares and the specialization, the process of getting even more fragmented is actually faster than ever. This is a slide that I had exactly 15 years ago when I first presented on a conference here in Dubai. And that presentation was about cold band glazing. It was kind of a new thing those days. We had a couple of projects which could be done with cold band glass, which makes it faster, cheaper, but there was not enough literature on it. We did some testing, and the presentation was about that. And I started the presentation comparing it to perfume bottles, because they are unique and beautiful, and they are like a product, and they are looking for attention, and buildings feel like that, you know, a little bit. Wanting to be unique, looking for attention, but then for the facade contractor, it is a product and it has to be mass produced. So what's happening now? What is the perfume trend in 2023? And this is a picture, the next one, which I saw. I mean, the picture is what I saw just recently. Actually, it was Riyadh Airport, but it could be in any perfume store. The new trend is having uniform bottles. Does it mean that the building trend is going that way? Hopefully not. But again, by relying more and more on specialties and having their input more and more significantly infused into the building aesthetics, we are getting towards some kind of uniformization. Just think about the line, and this is another line of buildings which some of us has memories, and it's probably not the pinnacle of architecture. Interestingly, when I asked AI to give me an image of a very boring tall building, because I wanted to use this image, AI gave me buildings like this, which is probably boring for AI. I would not call them boring. I would call them cheesy and not very thought of, but not boring. So interesting how AI came to the conclusion that this is what us humans are calling boring. That's just a side thought. But then, what's the process that we are currently working in? Start with design. We have the BIM tools, very commonly used. We have parametric tools, very commonly used in architecture, 20 years ago, 25 years ago, already used. And then the architect have ideas that are coming from things that we would like to do. It would be beautiful if the building would have a construction site with zero wastage. Everything would be recycled. Everything would be energy efficient, which means it needs very tight joints, and those tight joints have to be built. New materials, very exciting. We can use all kinds of interesting things. They are very sustainable. They have very low embodied carbon, but then they have a new erection process. They are not the currently used traditional materials, which is, of course, not necessarily, it's not bad at all, it's good, but we have to think about the consequences of it. So next step is fabrication, and here we already have some snacks. So there are BIM tools and computer-instructed machines available for fabrication, but not everywhere, not for every contract, not for every factory. There are adaptive molds, all kinds of sophisticated tools, but then if you look at these workers staring at their computer, it may be difficult to comprehend at first. It's a change in the way of how everyday things are done in the factory after 10 years of monotonous work and doing the same thing which was working, and then suddenly it's not working because the buildings are getting different faster and faster, because the more specialties we have, the faster we are processing information. It's not one architect doing the thinking, it's like 10 of them, different disciplines, and they all come up with fantastic ideas, and they are all put together in BIM, and then someone has to fabricate it. Is the fabricator ready for it? And yes, some fabricators are, and they are getting ready, but still not everyone. And we did quite a few interesting, complex, pushing the limits of possibility type of buildings. And at the end of the day, when it needs to be built, yes, it's possible, but it will take longer. It needs more trial and error. It needs a very cooperative contractor who's ready to investigate and research with us. So let's go further. Next step is delivery. Doesn't matter if we deliver it from the other end of the world or delivering it from Sharjah, it still needs to be delivered on site. If the materials arriving to site, and I'm talking about custom pieces or groups of different typologies being built on the same facade, they have a sequence in which they should be built. And in the computer, for the architect, for us, it's easy to see that, okay, this is the ideal sequence. But then again, the factory has to be ready to respond to the needs of that sequence and produce everything with the raw materials procured in time, produce everything in time and send everything in time in sequence to site. And meanwhile, there should be done, a lot of logistics should be done with making sure that each element can be identified easily. Easily, because once it arrives to site, the workers on site are trying to put it together. They are not necessarily thinking that after doing this job for 20 years, they need to read a manual for continuing doing it. But the truth is that with projects where every piece has its own place and cannot be fitted anywhere else, yes, it has to be a very strict procedure and very strict way of installing, taking the things from the storage, putting it on site, positioning it correctly, without thinking that the factory did it incorrect and we have to cut it and waste material and do it again. And also new materials may need different techniques of handling. So it's a lot of learning suddenly, originating from the fact that we are 20 different disciplines giving the information to poor factory and contractor. A lot of learning that they have to be catching up, and it's getting faster and faster as information is processed faster and faster. So here I have that image that's the architect after he sees she sees the end result of the building, and none of the joints are matching up, and none of the, of course, that's also AI image. None of the joints matching up, the colors are not matching, the panels are dented, everything, because it's not easy to install. It's not easy to install, especially the traditional ways, and I call traditional the modern way, because it's constantly changing, and now it's changing more and more as we do research of embodied carbon and changing materials and introducing new ideas, new materials, more optimized structures. It needs different techniques to handle on site, and the specialist engineer is not the one who's installing the project. So this is something that we should consider. This is another slide that I recycled from earlier presentations, so some of you may have seen, basically just explaining that at the beginning, the more we can work out, the easier is the construction. And that's still true. So instead of finding out things on site, if we can coordinate it, learn it, study it in time, that helps. But again, the more specialized and interesting the building becomes, the more of these preliminary work is necessary to deal with it. So that then what it takes to have the dream of the developer, the dream of the architect to manifest in reality. Number one, I would say knowing the budget, but this is like a joke as we know, especially here in Middle East. We are lucky to have some projects where actually budget is kept from the beginning, and the cost consultant is evaluating point by point as we go. And the project is aimed actually 10% below budget or even 20% below budget, because they know from experience that it will shoot over budget. So that's a good approach, but it's only possible if there is a clear budget. So in that case, and then second point is coming together with it, the cost awareness in in the context of the building, in the context of the client. So if the architect and us, we know that there is a budget, there is a function of this building, they would like to have a beautiful building, but let's not call it super luxurious because this is not what we are aiming for. Let's just be honest about it. This is the budget. Let's build the maximum possible luxury that we can do from this money. And then comes the cost awareness of the architect, and that's only possible if the architect has experience not only on the design side but with project delivery. And same goes for facade engineers. If the facade engineer has experience with project delivery with the full scope and the other disciplines as well. So in that case, there could be an honest conversation about what's possible, what's not, and how much is the actually quantifiable the consequence of aesthetic decisions. And then I was talking about new materials, new building techniques, interesting ideas. There could be two options. The building owner either waits until it goes mainstream and many contractors, competing contractors knows how to build it exactly from experience, or it's fine, it's very, very nice to do it first time in the history. We did it a few times, that's why I'm saying it's only successful if there's enough allowance, time, financial allowance, and effort allowance and willingness to do physical testing in early phase. It's not physical testing like the performance test in the laboratory. It's physical testing before, having some components, put it together, experiment with that, take another material, experiment with that as well, to come up with something that is really working in big scale, rather than appointing the contractor. Let's see if it's working. If it's really not working, then let's start arguing if it's a variation or not, and continue from there. Software tools using to the potential. This is mostly for fabricators, the shipping organizer, and the construction site, including the storage keeper. The storekeeper is the most important part of the success of projects which are not repetitive. And then, as I started up, maybe let's look into what the architect or the lead consultant should do, and is it still the same role as we had before, and we are traditionally grabbing into it, or is it something that now with the new tools, and there will be even more tool coming up, and I'm of course, AI didn't start to flourish in architecture or in construction, but it will come up, and there will be tools available very, very soon. So we will need to be ready for it, and we will need to embrace it and use it to the best of it. So that's basically my presentation, but I'm very lucky because I will have another session after this conference at it was supposed to be around 5 o'clock. Some of you who are interested will have the opportunity to try the slide. There I will be able to talk about the slide and the story and the technicality and everything about the slide on a non-formal way. But there's no projector. So I was thinking to quickly show you a few pictures of the glass slide. It's one of those projects which was not really done before, not this way, and we did a lot of experiments and tests and research to make it happen. So it's a very Instagrammable structure, as you see. Actually, this is interesting because this is not something that we expected, that this corner of the slide would be the Instagram spot, but it became. If I knew that, I would have extended a little bit the platform. but it's something interesting that happened later. So, as you know, we worked on the whole Skyview building, and the observation deck was always part of the building, but the slide itself was a little bit later, intended later. So by then, the slabs were already built, and with the structural engineer, it was an effort to find a way to build the structure of it. So there are two big trusses coming out of the building. This is mock-up testing that we did to figure out the angle of the slide. This is a very big piece of glass in SEDAC. I will talk about it up there. I'm just showing the slides because you will not see the slides up there. And this is a few slides of the testing. So every component was tested to maximum and even more maximum. Here is the floor of the slide. And you see that basically all the layers are broken already and we can still step on it. It's my colleague Ammar who did the majority of engineering. Behind us, it's Michael Ludwig. He's a facade engineer in New York, and he was a third-party checker. And you see that then we just loaded it even beyond the design limits and the safety limits. So it's quite safe, don't worry. It arrived from SEDAC, beautifully pegged. There was a testing here in Dubai for the service load. And then they elevated the chute up, and then they elevated the other glass pieces. It's 15 pieces of glass in total, and put together there. So this is just the entities and people who contributed the slide. A lot of my colleagues and a lot of company did it. I will talk about it upstairs in more detail. And of course, anytime, come to me with questions. If you expected a very technical presentation and slightly disappointed that I was talking about my thoughts rather than facade details and exciting membranes and anchors and mullions and gaskets, then just give me a call or email me with your question, and we can always talk. Thank you very much. See you upstairs.
Thank you, Agnes, for this lovely presentation. Ladies and gentlemen, I'd like to remind you, whoever wants to see Agnes again and enjoy the ride on the slide, to please pass by the booth outside in order to register the name, because there are limited number of tickets. As Ahmed said at the start, there are only 200 tickets, so first come, first served. This is session 3, and we have our last presenter of the day for this session. Please put your hands together for Mr. Jan Shears, the sales consultant, Middle East and South Africa of Korarai.
Good afternoon, everybody. The Zak people made a fantastic design, but I have to turn around all the time, so I apologize already if you see most of the time my back and not my front. I'll do my best to turn around as much as possible. So I'm part of Korarai. Korarai is a Japanese chemical company, and our part of the company is producing and developing and designing interlayers for the glass lamination industry. We have a variety of products. We try to innovate. We try to develop new products all the time. This thing is not working properly. Okay. Okay. So this is the range of products we have. We are the biggest manufacturer of interlayers in the architectural business. We have our, on the left side, our standard safety interlayers, which is our Trozifol Clear, mainly used for annealed jumbo lamination and cut size lamination. We have our Trozifol Ultra Clear. Some people claim in the market now that they also have an Ultra Clear PVB. There are new players in the market who claim the same thing. We actually are the only one of a very specific Ultra Clear high adhesion PVB for tempered lamination. Our second product types is our colors and our tints. And we have an opaque, fully opaque black and a fully opaque white with zero light transmission. The third part of our business is the acoustic interlayers. This is actually part of the presentation which I will give today. We have a monolayer acoustic and a three-layer acoustic product. Then the security and structural part of our business. This is also part of the presentation for today. Most of you know SentryGlass. We also have a specific SentryGlass non-UV, which is designed to be used in greenhouses and where you actually need UV inside the building. Our latest development in the SentryGlass range is the SentryGlass Extra, which is a slightly different type of SentryGlass. The mechanical properties are a little bit less than the original SentryGlass, but the advantages for multi-laminate compositions, the processability is easier, and it becomes less hazy, you know, for pieces like 70, 80 mm of glass. We also have a translucent white SentryGlass, and we also have a stiff PVB, which we don't actually sell in the market here, because the high temperatures in the region here make it act like a normal PVB. Anything above 30 degrees, it will perform like a regular PVB. We have some specialized products, an autoclave-free product, a UV Extra Protect, which is designed for museums. We have the natural UV, which is actually the PVB type for the SentryGlass non-UV. And we have some other specialized products, including Spall Shield, which is a hard-coated PET, which is used in bullet-resistant glazing. I will talk about it later on. We're also active in auto and transportation. So we have products for the auto industry, we have products for trains, and we have one recycled product, which is called Butasite G. Talking about security glazing applications, you can look for yourself around. These are the types of threats that we see that are important to design security glazing, sorry. There is hurricanes, there's tornadoes, there is blast, there is fire, there's floods, there is burglar-resistant glazing which needs to be developed. Yeah, thank you. So civil unrest and rioting, what is the problem these days? The glass facades and the windows are the weakest point of the building when somebody wants to enter the building, do damage, steal products. So the trend in the industry to have much larger glasses and to have minimal framing is a challenge because we need to make the glass more performing in terms of anti-intrusion. So we have to match the glass and the framing system to have actually a good resistance to the expected threat. So security hazards from man-made threat. We are not talking about natural causes now. We are talking about man-made threats. So forced entry and exit. You can see on the list robbery, theft of property, riots, terrorism. It's valid for the residential sector. It's also valid for the public sector. Another one where we sell a lot of product these days is the doors and windows in prisons are now also designed to prevent people from escape or getting help from the outside to escape. A firearm attack, bullet-resistant glazing these days is becoming more and more important. It's for high-profile individuals in residential areas. It's also, of course, for government and public buildings, bank, jewelries, and also in the automotive industry, armored vehicles. Then the third section is bomb blast and explosion. This is mainly for high security and sensitive buildings, terrorist sensitive areas, also public transportation, and hazardous processes and material storage. I won't spend a lot of time on this because I think most of the people in the room are very much knowledgeable about glass. So the three types of glass we see, the normal annealed glass as it comes off the float line, is actually a very dangerous piece of glass when it breaks. The tempered glass is actually in between. It's a bit more a safe product because when it breaks in very small pieces, but still it's considered not a 100% safe product. So in terms of safety, the best product you have in the market is laminated glass, because whenever the glass breaks, the cracks of the glass will stick to the interlayer and you will have time to replace the glass. So this is just showing you how it is.
Good afternoon, everyone, and thanks first of all to...
Okay, I have a second presenter here. So you have 2 or 3 or more pieces of glass with an interlayer in between. Can be PVB, can be sentry glass. There are also some other types of interlayers on the market. So in terms of security hazard, forced entry, there is 2 things we have to look at. There is the glass itself, and there is also the window system, meaning the glass and the frame combined. So there are European norms and US norms handling only the specification of the glass, and there is also European and US norms handling the specification of the total system, the glass and the frame combined. This is a small video showing a jewelry cabinet. We show now in the video laminated glass with PVB, and then the second part of the video is a laminated glass with sentry glass with CPET or hard-coated PET on the inside of the cabinet. And then you will see that the difference in performance is quite different. So the left-hand picture is actually inside of the cabinet. So here you can see with a hammer, it's quite easy. A standard PVB laminate, after 14, 15 seconds, there is a hole in the glass and people can reach in and steal whatever is inside. So this is the sentry glass one. It's much stronger, much stiffer. And because of the CPET on the inside of the cabinet, there is no glass particles falling inside because it's protecting any piece of glass from falling into the cabinet. These are the European standard for bullet-resistant glazing. So you have from BR1 to BR7, from quite light weapon to quite heavy, powerful rifles. And of course, you can imagine to have a glass withstanding these standards from the top to the bottom. You're going from, let's say, 20, 21 millimeter total thickness of glass, where the BR7, the highest category, you can have glass up to 80, sometimes higher than 80 millimeters. So Spalshield is the product I was explaining to you a bit before. It's a hard-coated PET. It's laminated with a PVB on the inner side of a vehicle glass or an architectural glass, and it just prevents, whenever there's an impact, that the last piece of glass, the fragments from the last piece of glass, are flying into the building or into the car and wounding the person inside. So from low to medium to high requirements in the architectural market. The low to medium classifications, banks and financial institutes, police stations and airports are usually a medium classification for bullet resistant. And then the embassies, military bases and government buildings are usually the higher levels of the European or the US specifications. Non-SPAL is not always required, but often recommended to protect the people inside the buildings. What we did recently was we made a test just to evaluate the different materials without glass. So we just took a block of material of 10 centimeters, and we fired a gun, and we just measured the depth of the bullet inside the product. So this is actually a 50 by 50 centimeter block, 10 centimeter thickness, and we fire the same bullet from the same distance in different type of interlayers to see how they perform or how they resist the bullet. So these are just the pictures of the products. On the left-hand side, you see the standard PVB, so a 10 centimeter block of PVB. You can see that the bullet penetrated the block quite deeply. On the middle and on the right-hand side is the two types of sentry glass. And there you can see that the bullet just entered like 30, 35 mm. I will show you on this slide. So the standard PVB, the bullet entered 75 millimeter in the block, which means that it's not really performing very high. A more stiff material like sentry glass and sentry glass extra, or the product which is used a lot these days as well in bullet-resistant glazing, the polycarbonate, is performing in a similar method than sentry glass and sentry glass extra. So what is the difference between standard PVB product and sentry glass product? You can reduce the glass thickness to have the same performance, which means less thickness, less weight. You can see here that there is a difference for around 20% you can achieve using a stiff interlayer like sentry glass in terms of thickness and in terms of total weight of the glass. So you can imagine for an architectural piece, a large window which has to pass the highest level of bullet-resistant glazing, you're talking several tens of kgs per piece that are less if you're using a high-performance stiff interlayer. Now I go on to the section of sound control, just a few slides. Acoustic performance is getting more and more important. As the gentleman of Saint-Gobain told you before, when he moved to Dubai, he was shocked by the level of poor acoustic performance on the windows, and our products can help you design a better acoustic performance for your glass. So what is sound? Sound is a mechanical wave that propagates through a transmission medium such as gas, air, liquid or solid. And in human psychology and psychoacoustics, sound is the perception of the sound waves and their perception of the brain. Noise is an unwanted sound, but noise is not the same for every person. If I play music, which I like a lot, loud in my room, then for me it's not noise. For the neighbor who wants to sleep at 2 o'clock in the morning, it's considered noise. So urban noise is also becoming more and more a problem. The United Nations are projecting that by 2050, 2/3 of the people will live in big cities, which means there will be a lot more noise pollution in the cities. Transportation also, the volumes of transportation are increasing all the time. So there is an issue in noise in the big cities which has to be addressed. That's the same data, but it's a different slide that Dorian from Saint-Gobain presented. 1 decibel is practically not noticeable for the ear. 3 dB is just perceptible. 5 dB difference makes a big difference, and 10 dB reduction or increase is actually a doubling or a halving of the sound for your impression. So how can you achieve sound insulation with monolithic glass? You can do it by increasing the thickness of the glass. You can do it by using a PVB or another interlayer, or you can do it the best performance you have if you have a special acoustic PVB. So we have 2 types of interlayer, the monolayer and a triple interlayer, the SC multilayer, where you have a standard PVB on the outside and a special soft acoustic layer on the inside. So these are just the differences comparing, for instance, on the left-hand side, 8 millimeter monolithic with 4.4 millimeter, 4 millimeter, and 0.76 interlayer. The rule of thumb is that if you double the mass of the glass, you can save 3 dB. Going from monolithic to a structural interlayer is actually only helping 1 dB because structural interlayers are stiff, so the acoustic performance is not the best in-house. A standard PVB laminate roughly 2 dB gain, for acoustic laminate 4 to 5 dB gain. And the difference between standard PVB and acoustic PVB is roughly 3 decibel. Last, I just want to quickly show you our SoundLab AI calculator, which is available for everybody on our website. You can put every detail of your glass composition on the calculator, the glass thickness, the interlayer thickness, the cavity of the spacer. The other part of the IGU, is it also laminated or single glass? And then the calculator will give you a projected value of sound reduction. And then you can download the program and you can use it for your project. That was everything I had. Thank you very much.
Thank you so much. Okay, guys, now we're entitled to our second coffee break. So please help yourself to some coffee. Good afternoon, ladies and gentlemen. We just commenced session 4. Next, we have 2 guests. One is going to be with us online because he could not make it. And his colleagues also is going to be here physically. Okay. The gentlemen are from Mafis Engineering. We have Mr. Giovanni Zizioli, Regional Director, Middle East, who's going to be with us online, while the in physical person, Mr. Renato Cliento.
Good afternoon, everyone, and thanks first of all to the Zak organization for allowing me presenting, even though in remote. I will make sure I will attend physically over the next event. My colleague Renato and I have prepared a few examples of how complexities are solved via solutions taking into account constructability and sustainability aspects. And this is one of the main challenges of our profession and what we always try to focus on the first example is a beautiful example of what a green project can be. Hoboken 2 is Europe's largest green facade. It's been designed by Werner Sobek and executed by Frenner Reifer. And it's including a green roof and facade planted with hornbeam hedges. It's substantially 3-story building with the north and west glazed facade, including multimedia LED behind the glass, and the south and east green facade, which we're seeing in this slide, which is developed as well over a twisted elevation. The main structure is in reinforced concrete, and then we have a system of brackets and ladder, 6 by 2 meter typical let's say, shape, which are entirely prefabricated, and where the aluminum panels are then supported, and of course, where finally the steel pots, which reach 4 meter cantilevered in the roof, are integrated with the BMU and walkways for maintenance and all the drainage system integration. The construction engineering of this large green facade and roof involve a number of challenges. One of them was the necessity, as we're seeing in this slide, to design backwards to verify the point of contact into the concrete elements. And this was done, including then a post-execution survey, which was done for verification of the geometry of the embeds. Then, of course, one of the complexities and challenges was the tentative to standardize the geometry of the pots as much as possible, knowing that these pots were already procured in an earlier stage, and thus there was little possibility for geometry adaptation. And then finally, of course, the identification of all the aluminum panels layout and configuration, and the decision to control all these aspects with the 3D model, comparing the actual site execution, keeping an eye on one side on the geometry and on the other side also on the material takeoff. A second case study that we have brought is the new extension of the Durst headquarters in Bressanone, which is designed by Monovolume and executed by, as well, Frenner Reifer. And it's including two main components, which are the main facade, which is realized in aluminum panels following, let's say, double curvature geometry and a quite dense punch windows placed in a dedicated niche. And then the glazed roof over steel structure with the Ryco supporting system over the glass. The main intent and challenges in here were the tentative to try and avoid double curvature panel as much as possible, which was achieved almost everywhere, with the exception of some areas in the bottom part, which was anyways entirely cold bent. The necessity to follow a non-vertically stacked mullions arrangement, which are necessary to allocate for the misalignment in the window pockets themselves. The support over an X-lam slab or skin, which is could not be bent at site, but needed to follow in a faceted way the double curvature of the skin, of the second layer of skin, which is the aluminum support sustaining then the cladding. And then, of course, the necessity to guarantee the system warranty with the maximum angle of 3.5 degrees imposed on the curtain wall system itself. One of the complexities in this case was also how, as we saw in the previous example in Kobogen, how to guarantee the geometry of the RC works in combination with the CLT panels, marking all facade types, and having then a full survey with the point cloud survey after execution to control also the distances from the points to the mullions themselves. And this was all done during the construction engineering execution. And from this specific picture, we can appreciate that then the prefabrication in large pieces of the glass roof, which was then installed into the final position. A third example that we have brought is the Luxembourg Pavilion that was designed by Metaform and executed by Tayo Europe for the exposition in Dubai, the World Exposition in Dubai. The geometry is inspired by Mobius strip, where basically the twisting and the folding of a ribbon results in one single surface and symbolize infinity and specifically circular economy. The shape is specifically represented by a structural grid shell, which has then a double skin, an outer 2,500 square meter and an inner 1,500 square meter of PTFE fiberglass. One of the challenges here was how to reduce the number of joints, starting from, let's say, an extreme concept of one entire fabric panel for the inner facade or the inner cladding, and one entire fabric panel for the outer one. Finding, of course, a compromise between aesthetics and desire and a reduced number of panels and clamps with aluminum extrusion, which are, of course, by definition, twisted and curved in two directions. The point of connection then between the internal and the external fabric were identified in the entrance bridge structure. And as we can see from here, one of the necessity to the adaptation of the fabric to the grid shell was achieved with an extensive study of the curvature itself, which was carried out and was basically led to an optimization of the number of clamps. And specifically, as we can see in these slides, this was achieved identifying and minimizing the area of blue zones, which represent negative curvature areas, against green zone, which are substantially flat panels, and red zone, which are convex or positive curvature. This is because in the green and the red area, obviously the fabric is always sitting on the steel structure and thus follows automatically the architectural intent, whereas in the blue zone, the negative curvature leads to the necessity of a more dense clamping system with an anti-suction solution to guarantee the form finding over the grid shell. So as we can see from the picture, from the execution, the final result was really considered satisfactory in this point of view, and was able to balance between desired geometry or design for finding and the complexity of the execution itself. I will then hand over now to Renato, who will proceed presenting a fourth case study, and I would like to thank you all for listening.
There we go, for the third time. Good afternoon again, and thanks for enduring this long day and stay here, especially at the Maffei's team. So I'm gonna share with you the last case study, which is a curved in a concave and convex shape facade. It was designed by the Acme studio in Italy. The building is also located in Italy, and the reason why we are showing this project here is because it's clearly linked with this thread that we are following to resolve or to contribute to sustainability through design. I think that different people has different understandings about what sustainability is, and probably all of them they are right. The one that we prefer most and we apply to our projects is one that we heard taking the opportunity that we had today, Foster and Partners representatives here. It was from Norman Foster, where he was saying that for him sustainability was a simple thing. It was just it is just an attitude, is a way of working, is a way of making things efficiently, and when you do and you spend time doing proper design, you can resolve many requirements at the same time and contributing to the sustainability part of it as well. So this particular project had stringent requirements by the owner in terms of energy performance, acoustic, because the owner was worried about his people who is going to be there. The project is currently under construction, and basically has two clear areas. There is a glazed area with this concave and convex facade, and then there is an opaque area that is resolved with a U-glass that I will show you later on. Obviously, due to the complexity of the geometry, it was not required a wind tunnel test, but it was carried out a proper CFD analysis. And here on the right of the slide, this is the detail that I think that is worthwhile sharing with all of you, because you can see how through a detail that it might look simple, but there is a lot of work into it. It's resolving many aspects of the facade and the structure. So basically it consists of a vertical steel profile, which is part of the main structure, and it is supporting the roof at the same time, and attaching through a slender and a slim support connection, we can support the curved glass with toggle systems. So I have to share with all of you that during this construction stage, so the contractor preferred to use a structural bonding in order to control further the glass tolerances. We carried out all the engineering work and assessment, in particularly for the glass. So it was carried out a thermal stress, and considering the geometry that is concave and convex, that is always a challenge to curve large panels. In this case, the panels were 51 in total and had a width of 2 meters and a height of almost 9 meters. So you probably now can guess who produced those glass panes. So it's, by the way, one of the sponsors that we have with us today, the guys from Sedak Sunglass. And you will see the quality of the glass reflection, although at the beginning it was preferred to be in an annealed process, but due to the glass stress assessment, it ended up being a heat strength, and you can see this glass was produced in Germany in an oven that apparently it can do probably up to 20 meters. Said that, the building has a second area, is this opaque area that has a similar look. It follows the look with the glass, and in order to make it more cost efficient, it was used a rain screen cladding solution, so having the insulation and the vapor barriers and embedded membranes that our colleague was explaining and giving us a lot of useful information, because there's lots of issues behind that. And the rain screen element was the EU glass. You can see some of the images of how the project is proceeding, and it will be hopefully completed soon. So that's it, and thank you again for your attendance, your patience, and also to my little son who made time from his busy schedule to come. Thank you.
Thank you, Renato. Our next and last speaker of the day is the Chief Sales and Marketing Officer and Senior Vice President, Asia Pacific and MEA for Serge Ferrari, Mr. Nitin Govila.
Good afternoon, good evening. Thank you for waiting patiently. I know it's the last one, so it's 10-15 minutes more. I suppose it should be okay. So we'll start. I suppose most of you know what Serge Ferrari is, but just to give you an update of what we do and why are we in this Façade conference, I'll start with a small I'll skip that. I'm based in Singapore, manage the business across Asia Pacific, Middle East, and Africa, and 2 strategic markets, which is tensile and modular, and Façade comes part of that. Okay, yeah. It's a bit of lag. Is this better? Thank you. So that gives a bit of gist of what our strategic markets are, and facade falls into the category of tensile architecture. And as you saw at the last element, which is Act Now for a Better Tomorrow, is a key sustainable message, which is driven by our CSR approach is plus equals zero, meaning trying to create more value, but either using better materials or lesser kind of materials with a lesser impact on the environment. So that's our driving factor as we go along, and the new products which are going to come. So just to summarize, we are in these 4 markets. Solar protection would mean interior and exterior blinds, awnings, all kinds of shading. Tensile is big structures, facades. Modulars could be even tents, even lodges, resorts, and furniture and marine protection. Now, coming to why we are here, so why fabric as a facade? So we'll talk about few things, starting with the first element of advantage with facades is related to thermal insulation and visual comfort, where, as you see, you have 4 big advantages which you can get, which is visibility, thermal control, glare, and natural light. And some of you who might have had a chance to visit our counter outside would have seen with the frame we put that you can actually see all that. And when it's put outside the building, you can obviously get a bigger advantage of that. Now, natural light, as we all know through various scientific studies, is very important for productivity of work in terms of employee health and well-being. There's been a lot of studies which have been given behind that. And it also ensures that not only you're protecting from glare, but also the amount of heat which comes into the building, which is also tying into the sustainability aspect of the design of the buildings. Now, the second element is about unique identity. For sure, this is a second skin product we are talking about. So in that sense, if it's how do you play, how do you ensure that building has a unique signature, if I may say so. So there are 3 elements which you can play with either LED lighting, with actually creating a new structure with 3D designs, and even the element of textile printing. So then when you look at LED lighting, it could be a standard design, but you can play with the backlit to create a right kind of design. Same thing when it comes to 3D designs. I mean, it can be starting from the very initial phase itself from design when you're doing a new building, or you can do a renovation or retrofit, which I'll talk about it also later as a key functionality. And third is textile printing, where, as you see, I mean, depending on the application, you can even print, you can do a brand image or any other identity you can create for that specific building or for a specific product. Then comes the element of energy savings. Now, in energy savings, because it's a second skin, so it's put outside of your first facade. So not only it blocks the thermal heat, but it also ensures that the heat is, in a way, ensuring that inside when you have a right temperature and you're able to regulate the kind of cooling load, which is a very key part in this part of the world. And that is obviously much, much better than actually once the heat is also already inside the building. So that gives a very big impact. Then this is just a small case study to give here. This was in US 10 years back, a small old rundown office where people were the owner was losing money, the tenancy was dropping, but just by a small change in terms of design and the layout, it kind of became very productive. And in just 10 years' time, there was a saving of nearly $700,000 to $1 million over a period of 12 to 15 years. And this is really a remarkable transformation of a building without taking it down, without changing the people or asking people to move out. So this is before, this is after. Then the fourth element on fire characteristics. I don't need to talk more, but we have 2 kinds of fabrics here, which is PTFE based on glass yarns, which obviously fulfills all the necessary criteria for this part of the world. And also, we have the polyester yarns coated with PVC, which also fulfills depending on whatever applications we are doing. I will talk about different applications we've done in the region, but I would like to mention that in the recently completed Dubai Expo, we did nearly 19 pavilions, which were both kinds of shading and facade applications. And finally, as a material, it's obviously lightweight, so you can easily install. It's on the outside of the building. You don't have to, it does not affect the structural load of the building. And at the same time, it's cost effective. It has compared to any metal mesh, has a diminished wind noise and a lightweight structure. Now, these are just some examples of retrofit, before and after. Then building, which you can just change the image and the identity. A small office in Italy. It's a stadium, and this stadium is interesting because the work was just done in 8 weeks' time using 6 people. So in terms of effectiveness and efficiency, it was a very unique example. Then there are 3 types of construction where you can use fabrics through a cassette panel, where everything you do it outside and just connect it to the building. Now, this is the Abbas office in France. This is actually the view from the inside. So you are also still able to ensure that the view through remains, and you're not feeling that you're disconnected with the outside environment. And the third part is, which is a flat classic membrane. This is a site which you all know, and many of you who don't know that we are just completing 25 years, and this is actually a translucent fabric which is put on the outside, giving the shape of sail. So it's already, it was installed in 1999, and now it's close to 25 years. This is monolithic, where actually you're doing the designing along with the structure. So even though it's frame-based, but it gives you the necessary effect of that. Now, there are 4 types of fabric facades. One is breathable mesh, which is porous, depending on the openness. So this is where you have a view through, and also you can play with the lighting. The second part is what we call as opaque waterproof, which by the name, as you understand, will not allow the light. It's a plain fabric, but you can obviously enclose it. Third one is highly translucent waterproof. It's still waterproof, but at the same time, it allows a little bit more light and element coming inside. And the fourth part is a transparent single skin, which is a new product we've introduced in the last 2 years to ensure that you have a certain view through, but at the same time, it gives the strength of a tensile fabric. Now, in summary, if you look at this group, why do we feel it for facades is important? Because there are multiple fabrics to choose from. The mechanical resistance, because it's been lasting for many years across different applications. Resistance to weather impact, resistance to weathering. Color fade resistance is also there because that's a natural question. Easy to maintain. It's as similar as you would do any kind of facades or for building. Long-term aesthetics, service life, and some level of support also, which we've started recently giving in terms of if there's an initial phase when an architect is thinking of something doing, we could support you in transforming your kind of imagination into some kind of reality. Now, we have fabrics on both kinds, as I mentioned, based on glass yarns or the polyester yarns. This is the support I was talking about. We also work very closely with some profile manufacturers in Europe, namely FTI, which ensures that the fabric, the profiles get hidden and only you see in the fabric in the frame, which ensures that the beauty of the building is not damaged. And one structure we've just put outside. If you have time, please feel free to come and see. We have all the necessary certifications also which exist or which is needed in different parts of the world. Now I'll directly jump to the projects. So these are some of the hotel projects which have been done across the world. I mean, one you already know. The third one is in Bali. So the second one is in India, where you can also project on that, or you can play with the lights. These are offices. Again, older offices, you don't need to run down those buildings. You can immediately transform them, or you can even print on them. Cultural centers, obviously that's very important because that can give a unique identity, and it requires a unique identity, either of that city, of that culture, of that country. Then schools and universities. These are all projects in different parts of the world. I'll come to Middle East later. These are sports centers, stadiums, and specifically stadiums. And we all know about the recent World Cup. 5 out of 7 stadiums have been done by Search Ferrari Fabrics, either facades, either the full stadium, which you see Al-Bayt, which is based on a Bedouin tent. Both the outside and the inside acoustic fabric has been done by Search Ferrari group products. Then car parks. I mean, this left side is a FBI car park in US. It's, you can print on it and play with the lighting, so it still provides you some privacy. And then directly coming to projects in this part of the world, these are the Expo projects. I'm sure most of you have visited and would have seen that. So at some places it's facades on the outside, some places it's shading, even the birds, that's a PTFE fabric. The opportunity pavilion, what you saw on the top, that's in PVC polyester facade mesh. Brazil pavilion, that was a translucent membrane. This is a Spain pavilion, different colors. Then Finland. This is an acoustic fabric, which exactly is the same design which has been used in the Al-Bayt Stadium inside, all across the whole stadium, to give the effect of a Bedouin tent. And this is Tamisol. These are some of the Middle East references in Riyadh. So even older buildings, smaller buildings, you can just transform. It does not need to be a total new greenfield project. You can even transform an old building. You can have, we have nearly 16 to 18 colors, but other colors can be done on MOQ basis and demand basis. These are some of the stadiums I talked about. This is the wave design where they play with the lighting also. Some offices. Simple structure just been put outside. And in conclusion, so we are there everywhere across the world. In Middle East also, we have a team. We have people across all the Middle East countries, and even Saudi, we have now an office also. So the company is present across any projects. I know Dubai is also a key hub for specification doing international projects. So we have people around the world to support you, and any kind of other support you need, we are there to help you. So that's it from my side, and thank you for your patient listening, and we are well within time. Thanks a lot.
Thank you. Thank you for being patient with us till the end. I guess the remaining people here are very much into slides. Okay, so enough for the presentation. Now we have a panel with the moderator being Mr. Andy Dean. He's the head of specialist services from WSP Middle East. And with the panelists, Mr. Mustafa Hassan, Mr. Abdul Qadir Saadi, Mr. Benjamin Beer, and Mr. Edward McIntosh. The topic under discussion is, why do projects get delayed? Thank you.
Can you give me? Thank you. Thanks, Osama. I wanted everyone to walk around on stage, but we figured with a panel it might not work, and we decided not to take the risk. So anyway, it would have been interesting. But I'll walk around instead, I think. So I'm the least important person here at the moment, but we've got 3 people who, if you want to come to the stage, can come to the stage, please. And our subject is, the subject that we've been given to discuss or talk about is why do projects get delayed? I think that it's an important subject construction-wide and very much related to everything that everyone does here. Now, I've taken the liberty of canvassing my colleagues here and asking them for their general impressions initially, so I have cheated a little bit. But what's important, most important, is that actually, if we can, we get your questions. Because, we can talk about what we think, but what would be most interesting is if you have questions about this subject. So, obviously, I'm going to have to keep spinning to see if there are any hands up. But I want to, I'd really like to get some audience input if we can. And I'm actually delighted to see so many people still here at the end of the day, because I was thinking at the end of panel session, right at the end of the day, it's a bit of a graveyard shift. But so thanks very much for sticking with us. So thanks, that's great. So from over on this side, sure. Can you give me one reason, somebody, why projects get delayed? Somebody? Approvals? Sorry? Poor planning, fantastic. Over this side? Consultants design details? Okay. Anybody over here? Money, lack of funding. Fantastic. And last but by no means least, I'm going to have I might do a Mexican wave eventually. So, general clarity over the project. Okay, so thank you very much for everybody. So now everybody knows how to kind of interact from the audience. That's good. I've got a mic here for us guys on stage. There you go. I'm going to give it to you. Oh, you've got one. Fantastic. Okay, I'm going to come to you first anyway, Ben. Because one of the things that you picked out when I kind of asked you earlier was planning. So can you just give us a bit of a feedback on the planning issue, particularly kind of from your own experience as well?
Yeah, talking about the planning issue, and what usually happens is that the architect or the design team, they're setting up the tender package, which goes out for tender. This is then, of course, priced by the facade contractors, and then the successful facade contractor is winning the job and started building this thing. So this already has a lot of, let's say, potential for conflict. And conflict also means delay. So if the tender package is not clear in terms of design intent, in terms of technical details, also in terms of quantity, there's start for potential conflict and actually for potential delays. So it could start quite early if the tender package is not sufficient for the tender to fully understand the scope and to be able to price and build this project. Quite often contractors are a bit reluctant raising a lot of queries during tender. This is what I've seen sometimes, of course, they're a bit scared this could kick them out or being seen too difficult during a tender process. So I think this is where at early design stages, early up to tender stage, things could start going wrong in terms of causing a delay later on.
Yeah, funnily enough, what I also did, by the way, we've got Benjamin Beer here is a facade consultant. We also have an architect and a developer. But when I was thinking about this, I thought the party that we're really missing here is a contractor. Now, I'm a consultant as well, if I can call myself that. So I called a contractor as well. And I thought that maybe I would play the role of the contractor in this. And funnily enough, one of the things that you talked about there was the contractors feeling about what they can do during the tender stage in particular. And one of the things that came back from my friend who's a contractor was exactly that they've got a fine line to walk. They've got to try and put in a compliant bid, but at the same time they might have to kind of raise objections. Too many of those kind of create, maybe even disqualify them. But on planning as well, I mean, part of planning is the kind of program planning. I mean, from a developer side in particular, how do you see the program, particularly the early program, like the program that you might set as a developer, affecting potential project delays as you run down through the project?
In fact, we make a plan for the project and we set dates and targets for every stage, from the concept design to the tendering process, then the award and the construction until the handing over. So sometimes you face problems during these processes in all these stages, as my colleague here mentioned about the readiness of the package, tender package, and the design, and many PTCs raised by the contractors during the tender stage, which is delaying the award. So ending this stage with the award, the contractor sometimes has poor planning for the project. As you know that there is a work breakdown structure that is done by the contractor. Sometimes there is wrong methodology, wrong assumptions, bad information fed to the program. So eventually that leads to delays and not meeting the programs and not meeting the schedule.
It feels like there's a bit of a chain there, doesn't it? So we've got an original project plan which might be ambitious. Ben, when we were talking earlier, you were saying that if I remember rightly, tell me if I'm wrong here, but if the development team doesn't get the right information from the consultant early on, then the program's wrong from the start. And then you've got potential delays in lots of tender inquiries, which delays. Then you've got delays in potentially the contractor's interpretation, and you've all then got a project plan that you've signed onto, that program that you've signed onto, that arguably kind of can't be met eventually as well. Any other aspects of other aspects of planning and the program in particular that you think that we should be nailing in order to get it right?
I think from experience here working in the region, the main factor for delays is usually program. It's very rushed. Expectations are quite high from clients. And it has a domino effect because it's the start. So there is not enough time to investigate the design, and which may lead to poor detailing, etc., and that passed on to the contractor. Planning, properly. Also the brief. Most of us, we get a very, very vague brief at the start with a very ambitious program, and things change along the way. So there are a lot of changes that come in, whether a stakeholder, let's say an operator that comes late into the process, etc., and it leads to changes during the design. And the problem is the deadline never changes. It's always the same, and puts us under pressure, and it leads to all these problems for delays.
But do you think we take, and again, to the audience, I'll try and keep an eye on it, but put your hand up and we'll get a mic out to you. Do you think we really take the program that seriously out here? I mean, I've been out here quite a few years now, and it is almost like a kind of, there's almost an expectation that programs slip. And if you get it somewhere near, or even like within 6 months of a year, that, then it's okay. Do you think we take it seriously enough? Because again, if you marry those early stage kind of program issues with the design issues, and then the changes and the late stakeholder involvement, we've got no chance, really. I mean, do we take it seriously, really?
Yeah, we do, because contractually, we have to take it seriously, and we wish for the best. I mean, we know sometimes most of the time, we know the program is not realistic. It's going to be, let's say, a lot of things that the client will discover along the way. But we have, to plan B is you have to deliver it on time. So contractually, we are obliged.
I mean, if I could add, I think especially Dubai and actually Abu Dhabi became quite professional in terms of program compared to the rest of the Middle East. I mean, we're still not Switzerland, I think we have to be honest. But when I came to Dubai the first time back in 2007, almost every single program was more kind of idea. It was, but I think what we have nowadays in Dubai, the projects are run quite professional on an international level, I would say. Then compared to other areas in the Middle East, Dubai, I think, is leading this kind of professionalism in construction, in planning, and then also pushing the contractors on meeting this program. But I think other areas in the Middle East, they're still behind, and it's still more this kind of wishful thinking, and things are slipping. And I think we all know these projects in the Middle East that go on for ages and ages and ages. So I think we are on the right way in terms of being more tight, also being closer to a professional planning and realistic planning of the program.
I might add one, if you don't mind, to that as well, and that is, and again, I'm kind of playing the contractor card here a little bit. So, did you have your hand up, sir? Right. Ben, can I borrow your mic? Because I think we've only got 3. Sure. And I'll get a mic. Oh, no, we do have one, sorry. I'm just going to say what I'm going to say, and then I'm really keen to hear what you want to add to it. So, just give me 1 second. So, I'm playing the contractor card. So, I think that on the planning side, my contractor friend said that he felt that most most project plans that came out were things that they were going to try and hit, but probably thought they were unrealistic in the first place, and actually felt that they could manage any delays through the process, which is an interesting perspective to have. But I'm more interested in what you've got to say, sir.
Hi, good evening. This is Karthik from Bukhatir Group. See, basically, I see that the programs is not taken seriously in many of the projects whichever we undertake. Basically, the program misses the detailing. I mean, it's overall the program is just made for to satisfy the requirements of the contractual requirements, rather than considering this as a part and parcel of the project to benefit the whole project. So it's just taken as a part of a contractual requirement. What I see missing is the full detailing. Each activity-wise detailing is missing in the programs, and even the main thing which we see as a delay is the material approvals and the procurement. That's one of the biggest reason which is causing the delay of the project, because that needs to be detailed properly and perfectly in the program, which I see, at least in our projects, we did many of new high-value projects, which has not been done. Even after pressurizing also, still, it's not been taken care of fully in the projects.
So let me ask you another question, if you don't mind. In a program, do you think there's an aspect of it that could just be an ideal? And there's, sure, in the program, if you sit everything side by side and plan it out, we've got some fantastic planners who plan these things out. There's actually no space for error, and let's face it, there's almost always error. There's almost always an issue. There's almost always something. We've talked about. I went round the room before, and there was lots of reasons why there's issues. But if you then try and fit that into a program, well, then there's no space for maneuver. I mean, is there enough slack? Yeah, I know project managers would probably shoot me off the stage for saying this, but is there enough slack in a program, realistically, to actually deliver the project on time?
I feel that there could be the errors in the program, I feel we cannot fully integrate everything, the whole project in the program. I agree that it's highly difficult to have everything in the program, but at least the major things, which causing delays, those items needs to be detailed fully and integrated into the project in a realistic way.
Okay, so one of the other questions that we kind of, as a panel, we kind of came up with as well, is not just what are the problems, but what's the solution? So maybe would you give it from your perspective? I mean, you're right at one end of the scale. So what's the solution from your view on this?
Actually, I agree with my colleagues regarding this issue for the design, because as a developer, we always put the designers and the contractors under pressure due to our tight schedule and how we have to hand over to end users on time. So sometimes we have to float tender without having detailed design ready. So we have a concept design or a preliminary design, then we float the tender. That's why the issue for the PTCs, many PTCs, and prolonged time for the tender, this happens physically. And also, we put the contractors under pressure by giving very tight schedule for the completion of the projects. However, we consider that there might be delays because there is so many factors that affects the contractor's progress. And as Mr. Karthik, he mentioned about the program details, which are sometimes overseeing things like approvals of the materials and the details which are not really clearly mentioned in the program. So the solution for this is to list all these items and consider assess all the risks that comes from the delays from all these aspects and try to realistically deal with all these factors.
Yeah, I mean, you mentioned one word there that I thought was quite poignant as well, and that's assessing, well, two words, assessing risk. Maybe there's not enough assessment of the risk in the program that I think that's quite an important takeaway.
And Eddie, if I could, maybe also, because we have a client side also here, what I sometimes see also from a consultant side is that the appointment of the main contractor and then subsequently the facade contractor, that especially for the more complex projects, sometimes we see the names of main contractors where we say, are these main contractors qualified? There's a cost issue, and sometimes we then see a main contractor dragging a facade subcontractor into a project where we as a consultant would raise our concerns. And this is sometimes, from my experience, already a starting point for delay, that we're getting contractors on board that are potentially not from day one fully qualified for the project, that they need to team up with other sub-consultants supporting them. So it's sometimes also the mix of the choice of main contractor and facade contractor, which is sometimes not, I mean, a program could be achieved by highly qualified facade contractor easily. If
totally agree with you.
Choosing contractor, first of all, need to speed up in terms of building the production to this quantity that they need, the design team, then there's already a start of delay.
Exactly. As you know, the budget also has constraints for the choices of the contractors. You don't go sometimes for tier one contractor to have a project like a high-rise building. And sometimes you have to meet the budget. So this kind of risks you take by giving like tier 2 or tier 3. And that also causes delays and due to their capabilities and their limited resources.
AK?
Yeah, I agree with my colleagues. I mean, having the right team on the project would help. I want to add on the complexity of projects. We're working on high-profile projects in the kingdom, and the scale and the complexity is unique. They are like projects in terms of, very experimental, innovative, etc. Yet the program is set as like, your conventional, normal project. So the risk is not captured in the planning. I mean, as good as we are and experienced, we've never done these projects before, all of us, and we are learning as we go, and we're realizing things that you would never think of, like, even from long lead items, cranes, like TBMs, etc., and how to acquire them. And, when you look at the program, they haven't factored on all that stuff. So part of the maybe problem is us, the designers, designing things without thinking about how you build that as well. So
what's the solution to that? Is it earlier contractor engagement, possibly specialist contractor engagement?
I think having all the stakeholders at the very early stage of the design is very, very important to understand what you're doing and how you're going to execute that. So it's not things that will come up later as surprises, or so you're fully aware of the risks and you inform the client, so there is an informed, let's say, planning and decision.
But going on from what Mustafa was saying, though, because Mustafa was talking about budget and selecting certain contractors, possibly certain designs as well for certain projects. I mean, you're an architect. Do you think that you get told often enough what kind of development it is? Do you think you get told, actually, we're looking at a 3-star hotel here, or a 5-star development, or a super luxury, or do you think you get that early enough sometimes, or do you get a sense for it pretty quickly?
It depends. I mean, if we're, like you said, here in the UAE, maybe they are more experienced. In other parts of the region, clients haven't reached that level of experience and maturity, so it's having a proper brief at the start is very, very important. Most of the time we get like really vague brief and leads to a lot of assumptions, and which later on leads to a lot of changes and program delays.
We talked about authority approvals as well, or there was a mention about approvals. I actually think that the approvals thing might have been more about the design team approvals as well. Ben, you mentioned earlier on when we were chatting about this that sometimes you've come across maybe kind of brother and sister consultancies who will just automatically put a C on the first set of drawings, which doesn't feel right. And that for me feels like an experience. That for me feels like somebody who's not confident really to review something. So, I mean, do you think we've got a lack of experience sometimes which creates delays in that way?
It's a pretty hot topic, I would say, because I mean, I've been working as a facade consultant since quite a while. We're facade consultants who are working both for clients and for contractors. Sometimes we're called by contractors, please assist us, because this specific facade consultant only knows status C stamp on calculations and drawings. So it is a very fine line. I mean, in the end, the consultant is reviewing the facade contractor drawings. Sometimes the contractor has more qualified people than the consultant. I don't want to mention any names, but also very young facade consultants being put on big facade packages, reviewing drawings, not having the experience, being overly conservative, delaying things. Also would like to mention that I think the consultants, as our profession is, Andy, maybe sometimes we need to be more proactive. And, you know, talking about facade contractors, I've been sitting in a meeting with the awarded facade contractor on a complex geometry project. The contractor told us, oh, they never used Revit or Rhino, so they cannot handle even the architect model. So what do you say? Do we then say, okay, we give everything status C, we're going to give you a name, maybe this could be sub-consultant, if we're helping you, we are, you know, it's about this kind of proactive team collaboration. This is maybe what a few consultants are not willing to do. They more see themselves, we are reviewing, full stop, I'm not helping them anything, and if it's status C, it's status C. But you know, sometimes if you give a status C on a drawing, it's sometimes a call to call the facade contractor telling, listen, if you do this and this, we can help you a bit, then it's getting to status B. And sometimes this could speed up things. So it's a kind of proactiveness also of the consultants without, you know, criticizing our profession too much. But I mean, this is sometimes maybe lacking, yes, yeah.
Yeah, I think you're right. And you know, I think that it also leads into one of the other elements that I have written down here as well, that came from one of you guys. I think it might have come from you, Mustafa, and that's about collaboration. You know, I mean, you must see this. You must see this from a slightly kind of higher vantage point. You know, and let's face it, I think that there is a healthy push and pull from the contractor and the client side. I think that's the right thing that it should be as well. You know, we're keeping the line tight, and it's going to be right. You know, that wasn't meant to rhyme, by the way. That was awful. But you know, this kind of collaboration, I think, is for me feels like the right way forward to get the target.
That's true. Actually, the old model of the employer who's just dictating and the consultant who's objecting and rejecting and all these old models has already is part of the past. Now the teams are working, the developer and the contractor, the consultant working together as a team, because eventually completion of the project on time is for the benefit of all the parties.
Yep.
Okay, so definitely anyone who's, as a developer, when we see someone who's putting obstacles for the contractors or during the design stage, definitely we remove him, because this is not healthy. It's not good for the project, and it's not good for the environment of the project.
Yeah, I think mutual respect's quite an important thing. There's quite a famous contractor out here, and their strapline is respect, and I think that you mentioned before about some consultants maybe not knowing as much as a contractor. I would go much further than that. I would say contractors know most of things. We learn most things from our contractors, and acknowledging that and having that collaboration, you know, with the architect as well, AK, I think it's a super important piece.
That's true.
Okay. Now, we did talk about design changes. From an architect's side, do design changes come from a poor original design? Do they come from funding issues? Do they come from, I mean, I guess they come from quite a few things, right?
Yeah, there is many factors. So sometimes it's late appointment of stakeholders. Like I mentioned, let's say an operator that comes very late into the design stage. Suddenly, let's say Hilton has different standards from Marriott, etc., and that will have an impact on the design. Sometimes it's maybe budget, where we've been working on a project. I'm not I can't disclose any details, but anyway, it's a project where the buildings were designed, and then later on the budget, the client realized that the product was based on a Chinese product that does not meet the standards here, so they changed it to Spanish. Then the cost went up, so they have to take it from the buildings, and that resulted into changing the buildings and value engineering, etc. And there's different factors, whether it's budget, whether it's a late appointment of stakeholders, or a vague brief at the start, and then later on, or maybe change in market trend. You're designing, I don't know, a tower with apartments, and suddenly the market has changed.
Yep.
There's demand for smaller units, so.
Yeah, we're seeing that, you know, we saw that through COVID, didn't we? A lot of repurposing and shifts from to residential. I'm sure we're all working from home to some extent. Anyone from the audience got there's a gentleman over there. Could we get a microphone to this chap over here, please? Thank you. Sorry, I hope you don't mind me calling you chap. It's a friendly thing. Pardon? A lady? I don't know, honestly. I've never thought about it. Yeah, I think I wouldn't stray into that.
Yes. Hi there. My name is Kurt Hanslick, Canadian architect in Dubai. I'm working with Woods Bagot right now. I just wanted to ask about documentation and physical models, which I see rarely now. I think the loss of that is just conceptually you're dealing with digital ideas all the time. The team is kind of fractured. People working in silos because of everybody's on their own tabletop. I just wanted to ask about documentation. How could that be better for teams pricing things, and also for the teams understanding what the challenges might be and how we can move forward with that? Thank you.
AK, probably you're, you know, as an architect, you're probably in tune.
I can only talk about my experience. I mean, in our multidisciplinary, for example, practice is very important to have a fully integrated team from the start, where we collaborate internally and externally. And the project team are structured in a way that they all sit in one, let's say, one corner of the office, whether it's a structural engineer, MEP, architects, constructability, modularity. They are all in one corner so they can coordinate properly and make decisions on time. So having an integrated team is very important, rather than, I mean, I worked in other offices where, you know, boutique, so it's very hard where you're, you know, your MEP structure, etc. They are, you know, sub-consultant, external. So it makes a difference, multidisciplinary.
Kurt, you mentioned physical models, though. Don't you see a lot of printed, 3D printed stuff now? Isn't that like and 3D images that you can, you know, Revit models that you can spin around on a screen? Isn't that taking the place of that physical piece a little bit for you?
Yeah, I guess I just don't see enough of those, but they're definitely helpful because it grounds for everybody's view what the project is.
Yeah, definitely. I mean, Ilsam, I don't know if he's still in the room, but Ilsam was talking earlier about, in his presentation, the chap from Foster's and Partners, he was talking about models, and they printed loads and loads of models just to see what they look like and literally walk around them. There's another gentleman over there with his hand up. Would you mind? Thank you. But it's funny, isn't it, how when that paper and maybe the physical building thing used to be in balsa when I started, you know, they get replaced now, possibly maybe a bit of a dip in between with new things. That's good.
Good evening. Myself, Girish. I'm from Cornish. Sir, I want to ask you one thing. From my point of view, the project delay is starting because of the budgeting issues. Because most of the developers are always looking for the L1 contractor, whether they may not be capable to do that. So they will squeeze the price, they underquote the project, they take project from the developer, then they will start squeezing the subcontractors. Subcontractors is trying to find the material which are like low budget, because everyone have to make profit end of the day. Good example is the Deva head office. It's been awarded to a contractor, 200 million cheaper than the L3 contractor. So right now the contract is disappeared. The project is totally delayed and they're re-tendering it. So why always going for L1? Contractor, why can't you just like, even if you have a budget of 100 million, if someone quoted with 75 million, you have a budget of 100 million. You can go for a right contractor who suits that, who is capable to finish the projects. Many projects are getting delayed because of that issue.
There you go, Mr. Mustafa.
I totally agree with you. However, you have to also understand the position of the developer because for such a building, for DIWA, this is like a government building, but talking about buildings that's been sold to end users, there is a cost for that, for those projects. And the projects has been sold already. When the award is given to the contractors, the project's already been sold. So we cannot exceed the budget, and otherwise we will have losses. And actually we work on the value engineering by changing the specs of the material sometimes in order to meet the budget. So selecting the contractors, the good contractors, as you said, this is something definitely it has a very big value and has to be taken into consideration. However, sometimes we are forced to go for the second or third choices to meet the budget.
If I could add one thing, because I've also seen, and this is another point of delay costs as a political tool. And this is quite often used by the contractors, even the tier one contractors that I've seen. They're causing delay to force payments, to force the clients release more money. So I wouldn't only say that it's the client, it's also the tier one big name contractors are using delay as a tool, as a lever arm for commercial items.
And I've seen
not to be underestimated, yeah.
I've seen also a bit of a, I mean, it's called contracting, right? Not constructing. But I have seen, sorry, I'm going to push back a little bit. Even though I'm the contractor on the stage, I'm not, but, you know. I've seen sometimes things just get dragged out and dragged out and dragged out so that the client, the side team, or we're obliged to purchase this thing because there's no other time to actually don't go and do anything else. So it does happen.
Okay, I would like to add one thing. Actually, those contractors who not first tier, they are also participating in the tender. They are burning the prices in order to get the projects. So they must be prepared. They must be ready for such scale of projects. They must be organizing their finances and their resources and manpower and so on. So when the developer finds a contractor with this capability and his willingness to take the job, why not give him the job?
Right, we're in our last kind of 2 minutes of our session here. I hope I haven't kept you too long, and we've stayed on time, it would be kind of ironic if we didn't, wouldn't it? But I think that we've covered quite a few really important things here, and I think that this is just a you know, it's just an airing of views to some extent. I think that most of us around the room see this, know this, try to deal with it. It's interesting that you're saying about, you know, there's a change in maturity. I do believe that the UAE is a good example of leading, and clients are becoming more aware because they've been through so many cycles of construction now. So I do think that we are getting there. I think we've got to keep pressure on it. In the last 50 seconds, I think that, you know, we're a bit late with this conference, aren't we? We're late starting, and I think that there's a little bit of a I don't think that there's really enough contingency. I think that we need to give a little bit of contingency and a little bit more slack in our programs and try and be less tight. Final word from you, Mustafa?
I think planning is the key.
Planning is the key, AK?
Program and client expectations.
Client expectations. Ben?
What I've seen is managing the site is also key, managing also the contractor.
Right, managing the contractor. 10 seconds to go, we're on time, we weren't delayed. Thank you very much, Osama. Thanks, everybody.
Thank you.
Thank you.
Then I'll close.
Can I request the panelists to just be seated? Just 2 minutes. Thanks, guys.
Ladies and gentlemen, thank you for your time. Thanks, Andy. Thanks, Benjamin, AK. Guys, it has been an interesting day. Thank you so much for being with us and for attending the 113th exhibition of Zak World of Façades here in Dubai. I hope you enjoyed the show as well as the knowledge and the technical know-how shared by all the people. And I wish you a pleasant remaining of the day. Thank you.
Yes, thank you, Osama. Thank you all for attending today's event. I think a round of applause for Osama Abbas, our event host. Thank you, Osama, for taking your time out. A round of applause for our panelists. I think a macho panel we had here on an interesting topic. Thank you, Andy. Thank you, other panelists. Okay, we are done. Can you switch the screen on, please? Right, not this. Not this. This laptop one. This is turned on here. Right. Yeah, the screen's on. Okay, so basically I wanted to show the video about the glass slide. Yes, we are now having the networking opportunity at the glass slide there. Those who have registered, please come outside to the area near the Caparol booth. You will be given a wristband and a ticket. Since we are delayed, we will go straight on top. This is on the next building. So there's an alley over here. You need to take the alley, take the lift, go up to where it shows Dubai Mall glass slide. As soon as you go up on level G, follow the signage. We'll be escorting you, but since it's a large group of 200 people, in case you get lost, very easy way, find the signage, reach over there, show the ticket, and then we meet all of you on top. So thank you all for attending today's event. As I mentioned in the morning, we've recorded today's event, so we'll be sharing the YouTube link of today's event a week from now, and you guys can use that. So thank you all to our partners, and until we meet next time next year. Thank you all.